Okay, once again, good evening to everyone, and also if you guys are not from India, then good morning to you. So basically, let me just tell you what exactly we are trying to do here. So this is a regular DevOps course that we are trying to conduct through online. And since there are a lot of people who are interested, we would like to go ahead with not a demo, but a real-time class wherein you will be free to attend for a couple of days in the initial and get benefited on the very basics of what it is. And later on, based on your interest, you guys can pretty much choose whether to continue. Even if not, you can go ahead by having a good understanding on this first 3 to 4 days that we're going to talk more about the basic concepts of DevOps, what are the different tools that we're going to use, and we'll be talking about each and tool, everything. So that's what I'm going to do in this session for the couple of days. And to get started with, in today's session, I'll be talking for the first 30 to 40 minutes on an introduction to DevOps in a brief way. So in that, we will try to understand what exactly is DevOps, why companies are moving towards DevOps, and in that, what is that we have to do in order to move towards DevOps, and then what are the things that we have to learn in moving towards DevOps, and ultimately, what is the career opportunities in DevOps and why it is so benefited for any particular person who is working in IT to move towards DevOps. So that's what we're going to cover about the what, why, and how of DevOps in the first 30, 40 minutes. And once that is done, we'll be moving on towards what and all we'll be doing as part of this course, the curriculum and the tools overview. And then in the next remaining probably 30 to 40 minutes, I'll walk you through the introduction of the very first module called Software Configuration Management or Version Controlling System. So that's what I'm going to do. And then later on, let's see how much we can cover it today. And then tomorrow, we'll go ahead with the introduction of Git, and we'll try to understand the essentials and the fundamental architecture of Git. And then the third day, we'll go ahead into the hands-on with Git. And then we'll be proceeding with the other tools one by one as we go through. So that's the major agenda for what we are going to do. So as I said, let's start with it. And before it, let me just give a brief introduction about myself. My name is basically Adam, and I'm a software generalist because of my profession, wherein I'll have 12 years of experience working in IT, and my specialized area is on DevOps. So particularly, I'm a DevOps evangelist where I started working as an administrator, then I started looking into the build and release management, and then moved on to the tools. And then right now, I'm completely taking care of DevOps, wherein it is required either to work with the development team or to the IT team or to the customers. I focus on everything. And top of all those things, pretty much I'm a technical trainer, and I've been doing it for the past 3.5 years out of my passion. Okay, so that's a small introduction about me. So to even before we get into it, so basically I do a lot of sessions which will be more of interactive way where we discuss. But since for the first 3 days we are trying to keep it as an open forum, and we'll have a lot of people joining in, it'll be difficult for me to keep answering every questions right away. The problem about that is we are focused more about giving it in a quality. So if you have any questions, feel free to ping me, or pretty much at the end of the session, we'll have an open forum where whatever questions that you have, we can discuss, or pretty much you can contact us later so that I'll be addressing. But as I said in the beginning, I'll focus in such a way that you won't get any kind of questions, or whatever the questions that you might get, I'll be answering each and everything in one by one way. All right. So that's a major plan that I'll be doing. So don't think that this will be a one-way class where I'll be just talking. No, since people are more, I'm focusing more to keep it on a mute way where the recordings will be clear and you can go ahead and refer to it whenever you want later. So that's a major focus. All right. So what exactly is this DevOps? We might be hearing it a lot from around close to 2 years in India, but this pretty much has been evolved a lot in US and UK. UK is kind of emerging, but the tools has been already there in the market. But in India, if you see, focus was from the last 2 years where we have been moving, and pretty much from the last 1.5 years, you hear this a lot. So what exactly is this? Now, before jumping into what is DevOps and why, let's first understand how is the market that we have in IT. So if you look, we know that there's a lot of market evolution and there's a lot of technology changes that is happening. And because of which, each and every organization or a company who are trying to do some kind of service wherein they are trying to either release a product which has been created by them, or they are doing some kind of maintenance of a release for a different company or a client, or they are trying to take care of a service where the product is being given and we are trying to use it. An example could be something like Flipkart or Google or Amazon. So regardless of whatever the kind of organization they are into or whatever their services are, what is that primarily as an organization they are looking at to survive in the business? Because just like how we think what is our career from an organization or a company, they have to sustain in a market, and they have to ensure, because of all the competition is there, how is that they are going to still come up in their business, make the revenue. So only then we will be benefited internally. So that way, from an organization focus, how is that they are going to run the business? So the major requirement, if you look from an organization from that perspective, is the first thing is how is that they are going to do the delivery of whatever services they are doing to their customers or the end users as soon as possible. Because we know that the market evolution is so high as well as the competition is quite high. So regardless of whatever service that you're giving as a company, you have to make sure that you deliver it as soon as possible, because the later you do it, then there are a lot of problems because of our competitors jumping into it. So that is when it is not about what are the good things that you're bringing in, but how soon are you bringing it to the market is the important thing. So from an organization, one of the topmost requirements that they have is faster delivery of their services. The next thing is quality. Now, whatever that they are trying to deliver, they have to deliver it quickly, right? They might have to do it, half the time what they were doing earlier, but it doesn't mean that the quality of the tasks, what they are trying to deliver to the customer, has to be less. Because at the end of the day, if the quality of the services or the product which the end users are going to use, if it is not up to the expectation, then our services or our business as an organization cannot sustain for a longer time. So that is when, along with faster delivery, they have to focus on keeping the quality of the services and the products, whatever they are delivering, has to be at a higher range. Then, is that enough? No. Because from a company now, at the end of whatever the service has been given, the most important factor that comes is how much is the expenditure that they have done to achieve the service, and out of it, what is the benefit they have given. So now, because of the market competition, if you are focusing on keeping a lower price of your service, then if the cost of manufacturing or the production or the maintenance, whatever you have done to ensure the faster delivery and quality, if it is quite higher, then the revenue, whatever the company has to going to do, will be quite less. And as the revenue keeps going down, they will have to be forced to be out of the market. So that is when one of the major problems for recession that happens is they are trying to reduce the cost wherever it is possible. So that's one of the important area where, even though they have a quality product and trying to give the delivery of the product very soon in the market, if the cost of the production and maintenance of their service is not kept lower, then it is going to be a problem for the organization or the company. So that is when companies are majorly focusing on this area, on how is that they can reduce the cost, whatever that they have been put in order to get the service done. So that's another major factor that is driving an organization's need. And finally, since we are talking a lot about e-commerce related products and organizations are focusing towards these e-commerce way, now the services that is being used by the end users is almost continuously happening, right? So if you take about LinkedIn, Facebook, or talk about the shopping things like Amazon, Flipkart, now customers as we or users are trying to use it always. So that is when, if there is a delay in getting up things from their end, then they are going to lose the customers. So that is when whatever the upgrades or the problems or the system maintenance that they are going to do internally has to be ensured in such a way that it doesn't impact the end users or the services. So that is when Outages, which refers to maintenance or upgrade of any services or machine or application, has to be done in a non-disruptive way as much as possible so that the services run smoothly without any problem and the end users or the customers doesn't have any impact in accessing your services. So that's the major important factors that as an organization that they are going to focus on. So now when an organization is thinking about these way, how is that they can achieve? So basically whatever that they have to do has to be focused within the organization. As in engineers, what is that we are doing? So we have to do it in a better way. So that is what the next step that organization has to look. So now as an organization, if you look, whatever services that we are trying to give to our customer has to be worked by two set of engineers. The first set of engineers, what we call them as the development group. And the other set of engineers will be part of a group called as non-development group or the operations or the administration group. Now, again, this classification can be further classified into smaller and smaller engineers. But from the organization, if you look, there could be only two major groups. One is the development, the other one is the non-development group. So who will be part of the development group? So pretty much anyone who will be responsible in doing some kind of release or maintenance will be part of this release group. And who and all will be part of this in terms of engineers? So you will have the developers or programmers, QA engineers or test engineers. You will have documentation engineers, program managers, build engineers, release managers, and you will also have anyone who is interacting with the customer also for working towards the release. So that way, all those people will be part of the development group. And the non-development group, people who will be focusing on maintaining a machine or an application which is available in the data center or in your lab for the organization will be part of that. So in that way, engineers like system administrators, network administrators, database administrators, web administrators, or pretty much anyone who will be directly taking care of a machine or taking care of some kind of application or a service in your organization, which will be used by different people to do the service, will be part of the non-development group or the operations group. So in order for the company to do some changes or to do the things better in order to achieve these factors, they need to first know what is the problem that these guys are facing from these groups individually, right? So we have a development group and we have a operations group who are currently working and they are focusing on many things like improving their day-to-day tasks and automation, but still they are not able to achieve all those things. So primarily for an organization, the focus now starts on trying to find out individually on what these people are doing and what are the problems majorly that these are facing. So that's when organization digs in deeper. So that way, if you look on the development side or the development group, there will be a particular software development lifecycle which they will be following. Now, what exactly do they do? So there will be a bunch of developers who will be working on some code changes. And once it is done, they have to give it to the testers or the QA team to verify. But what happens is we have so many developers and so many changes, and each one of them will be doing their changes in their own respective time. So because of which, it will not be sufficient where we can ask a QA person to keep testing each and every developer's change individually. So that is when what we have to do is we have to put in a lot of waiting period where we will ask all the engineers to complete their work, that is the developers, accumulate the change or integrate the change and then give it to the QA as a product to test it. So that is when there is a lot of waiting period involved in the development side and in the QA side in integrating all the changes. And let's say at some point of a time, you integrate all this change and create a product. And then when it is moved to the testing, there are a lot of possibilities where one particular developer's change is causing a problem because it is not compatible as a product. Because it is not just one developer who's doing a change. There will be many developers who are doing the change. So that is when we will be capturing the problem that one guy's change is not working at the end of the time when we are doing testing. Once again, we will have to put in lot of effort in trying to find out who exactly caused the problem and what and all are the other issues because of it, and then we will assign it to the developer. So once again, there's a lot of time that has been put here in debugging and triaging and particularly sending back the problem to the right developer. So like this cycle keeps going on until you capture all the problems, because you are trying to capture problems one by one. So that is how, if there are any other issues, to capture all those things, it is going to take a lot of cycles in the development. And is it the only thing? No. As I was talking about a lot of competition in the market, as an organization, if you focus, they will be interested to do many releases. Many releases means they would like to give different products at the same point of time, or for the same product, different architecture release that they want to do. So that is when, how is that they're going to handle all those things? So definitely the amount of time that the development group is going to put will be quite higher. So that is when, from an organization, if you look, the major problems what this development group are going to face is they'll be having some kind of software development lifecycle in which they'll be following some branching methodology for doing the development. So that is when, for each release that they have to work, there will be many branches, and integrating the branches, merging them, and then doing a release, all those things is going to take a lot and lot of time. And as I said, we are going to spend a lot of time in integration and waiting. And then, since you are going to do a lot of duplication work in terms of integration, the time is again spent there. And as I said, as the number of developers keep growing in doing the development, the time that you take to debug the number of problems will also be higher, because it is not just one developer who will be working on a product. Think that your product is a complete operating system. There will be hundreds of developers working on it. So the number of time that you're going to take to debug an issue will also be quite higher. And to debug and find out a problem, it is going to take a lot of time. So that's when your complete system is prone to errors. When I say prone to errors, it means that there are a lot of bugs that it will be introduced, because each developer will be doing his verification on his side. And when you are integrating everything together without a proper system, there's going to be a lot of problems. That is one side. On the other side, if you focus on the operations group or the administration group, what and all that they will be doing on a regular basis. So if you take an engineer, he will be responsible in taking care of a machine or an application in it. And in that, his task is primarily to make sure that the machine is up and running or the application is up and running. But it is not just that, because along with the machine or application, he has to do certain other maintenance tasks. Because as a system administrator, you will have to ensure that the operating system upgrades are always available, or whatever the libraries that is needed for your architecture or for your application that you need to run, you have to take care. Now, as a application manager or an administrator, to take care of that particular application, you have to do frequent maintenance in terms of backups. You have to ensure that whatever dependencies of that application is there should be there. And if a user has to access, what and all accounts that you have to create in it, giving them proper privileges and permissions. So like this, there will be lots and lots of maintenance activity that we have to do. Now, all these things are not the same on all the machines that we have. Because in our lab, if I have 100 machines or if I have 10 applications, not everything will be the same. So that is when each machine will be different in terms of the architecture and the application that you're going to run. So that is how the amount of the maintenance task what we have to take care from the operations group or the administration group will be quite huge. And is it the only thing? No, because at the end of the day, if the machine is just running or the application is running, is not just sufficient for us, because if a user has to connect to it, and if it doesn't work, then there will be a problem. So that is when it is also equally important for the operations group or the administration group to take care of the health of the machine or the application, whatever they are looking at. Okay, so that's when they have to do this for all the machines and the application which is under their control. So that way, From an organization, what is that the major problem that they are facing towards the operations group? That is high availability. So high availability means at any point of time, any user should be able to connect to whatever machine that he is in need, and at the same time, whatever application or the service that he wants to run on that should be available. So that is the primary requirement from an organization. Second thing is effective maintenance. Because now, if you keep putting too many people to maintain different machines, then again it is going to be a problem. And top of that, on a single machine, you will be having many applications or services. How is that you're going to take care? So that is another major problem on how is that you can ensure operational excellence, which is the most important thing. And then reducing the downtime. As we know that being in IT, it is inevitable where when we have a problem, how is that you're going to fix is one, but at the same time, we cannot say that you might not have a problem, right? Now, let's say you are trying to install some application, a simple one. Let me say that you are trying to set up a web server. When you try to set up a web server, what will happen? It is not always that everything will be fine. Suddenly something goes wrong. Whatever the libraries that is needed will not happen. So that is when, from an organization, whatever problems that you're trying to fix or whatever the upgrades that you're going to do or maintenance that you're going to do has to be done so that it is not going to be a disruptive service to the customers or to the internal stakeholders, whoever is going to access. So that is when, as an organization, now if you see, they have to make sure that any person as an engineer who is working, he should be able to do his day-to-day activity without a problem. For him, whatever machine that he needs and the services that he needs should be there. And in order to take care of that, a person should not be put too much of effort into it, right? As well as you're not going to put too much of cost in the maintenance, because if you use all the licensed softwares, again that you're going to put too much of cost in the maintenance. So that is when they have to ensure operational excellence. When I say operational excellence, it means that you are going to take care not only of the operations in maintenance, but you are also going to take care of the future planning, ensuring that any kind of problems that you're fixing will be based on a non-disruptive way so that it doesn't impact the service, as well as the cost of the maintenance also has to be kept in mind and it has to be brought down. So doing all these things together is what we call it as operational excellence. Because as an organization, they are not just going to think about from the engineer's way, but they are going to focus more from the way that they have to do the business. So that is when, given a release, how is that they can do it quickly? For that, whatever machines that they need, how is that they are going to ensure that everything is available and up and running? So that's the major requirement through which they should be able to focus on the 4 important factors that is needed for their business. So what is that they have to do? Now, organizations, if you look, already we're trying to do something called as automation, where automation is simply all about whatever that we were doing it manually, they are trying to do it automatically without much help of the manually or the user. So that is how they were trying to reduce the total amount of time that you're going to put into it, and at the same time, not too much of cost needed in terms of resource maintenance. But as the business is growing, as the technology is growing, we have lots and lots of tasks to be done. So that is when automation also has to go to the next level, where they don't have to just focus only on the automation, but also on the cost and the maintenance of it. Because if you say that you are going to do some automation and you are going to reduce some time, a company is not happy, because internally, if you are going to say that by doing it, the company has to spend too much of money into it, then again, it is not a big benefit. So from a company, you have to bring up solutions which you can help the automation to be done in a better way, a faster way, that is efficient, as well as keeping the cost, whatever you're going to do for maintaining that should be lesser. So that is when one such solution that came up into the industry is what we call it as DevOps. So what exactly is DevOps, or what exactly is the solution that the organization are trying to implement? So DevOps simply is going to act as a bridge between these two groups, that is the development group and the operations group. So as a company now, if you focus, they don't want people to work in silos. That is, they want to focus only on their problem. No, they want to focus as an organization's requirement where this DevOps, which is a culture which tries to bring a bridge between this development group and the operations group. And in that, these groups are going to work collaboratively as a single group in which you are going to do automation as much as possible to achieve all the organization need. And in that, you're going to communicate and pretty much collaborate in such a way that if there is a problem that is going to occur in one area, you are also going to solve the problem from the other area. So that is when a DevOps is simply a culture which the organization is trying to bring, where both the development and the operations requirement will be put together, and the culture will be focusing on both of the requirements as a one single group. So that such culture wherein the organization drives towards their basic factors of requirement is what we call it as DevOps. So this way, DevOps is not related to one area, because you might see people will think that, okay, DevOps means you are going to focus only on the infrastructure. Let me bring some tool on the infrastructure. Or some will say that, hey, DevOps is only on doing the release automation. It will talk only to the development. No, as the name says, it is a combination of both development and operations together, where it is the culture which the organization wants us to focus on both the problems that is needed for the development group to release, and for that, whatever is the infrastructure that is the system requirement or the IT requirement, you're going to take care of that. So that kind of culture where we come out of our mindset where instead of just working on only one area, we have to start focusing on both the sides. So that is when, if you have to move towards a DevOps culture, or if an organization wants us to move towards DevOps culture, we will not be just focusing on only the development side. If I'm a developer or a QA person, I have to step out of my day-to-day roles, wherein I'm not going to step out completely, but along with what I'm doing, I should also focus on what are the system requirements for me to do this development or testing requirement. The same way, if you're focusing on the operation side where you'll be taking care of the infrastructure, you have to come out of it, and along with what you are doing, your mindset should be prepared where along with the system requirement, you will also do some automation which will help the developer or the QA or someone who is part of the release management to take care of the releases to do it better cycle. So such a kind of culture, what an organization uses to overcome the problems and achieve their primary goal, that is faster delivery, higher quality, lesser cost that is being put into the maintenance, and effective maintenance of the outages, is what we call it as a DevOps. Okay, I repeat it. DevOps is nothing related to a particular tool or a particular area. It is a culture which the organization is trying to drive to overcome their problems and get them to be running in the business. Okay, so that's first thing that you need to understand. And as part of the DevOps, what is that organization wants us to do? The organization is going to focus on both the sides, that is the development related problems, as well as for that whatever is the operation or the system requirements, that is also going to be taken care. So what is that we are going to do now? As a company, I said they are going to move towards a DevOps culture where they're going to put a solution for combining or putting a bridge between these two groups, that is development and the operations, and working collaboratively. So that way, if you see DevOps, it is all about trying to implement industry's best standards, following certain modern software methodologies, and using open source tools through which they can automate everything and make sure the maintenance is done easily, and at the same time ensure the cost that has been put into it is quite lesser. So the first thing that what an organization is going to focus by coming towards the DevOps culture is moving in an agile way. So that is when whatever the kind of development that they are going to do, the first thing that the DevOps culture talks about is if your organization is trying to do things in a better way, first thing is move this complete software development into the agile methodology of working. So in the agile methodology of working, we have a lot of ways that you will be achieving it. So in that, a simpler definition would be is that agile tries to divide your day-to-day work into smaller and smaller tasks, and it goes through some kind of cycle where in that cycle all the respective engineers will be working in that development group will be working together. So that is when, as soon as a change has been done by the developer, immediately it will be integrated with others' changes, and immediately it will be tested, and immediately you will be creating a product. So that is how you can ensure that if there is any problem, you're going to detect at the earliest, and also the time that has been put in waiting and debugging, everything will be reduced. So ensuring there is a directly proportional to the productivity. So that is how, by adopting the agile methodology and the way of implementing modern processes and the methodologies, DevOps is going to ensure that the productivity of the release cycle or the engineers in the development group will be higher. And at the same time, they can always focus on the parallel releases. So that's an, since the release cycles are going to be reduced by doing automation as much as possible, you will have a lot of times to focus on parallel release. So happily, as an organization, we can focus on many customers' need and do the releases on time so that our customers will be happy and we continue to be in the business, being into the competitive world. Okay. Now, how is that they're going to do? So that is when, if you're focusing only on the development side, then there are different ways how we can implement the agile. So some of the examples on how an agile way of software development can be done is using Scrum or Kanban or lean development, or sometimes if you see, if it is a testing related organization, or if it is a testing related business unit on which your development is driving, then they will be using certain test driven development. So that's when people would be using, that is the development group will be using any one among this agile methodology of working, where they will be having certain kinds of stand-up meeting or scrum meeting or a dashboard meeting, where they will be splitting the tasks into smaller and smaller ways, and they will be trying to capture and trying to go through certain cycles, or in terms of the scrum meeting that you will be calling it as a cycle, where you will be focusing it to finish it as soon as possible. So that's when the focus is the agile way. You will be using any one of this as the development method. Now, okay, the method is for the development, but still, what is the process that you're going to follow where both the development and the testing and someone who's part of the release has to work? So that is when, from the DevOps, there are different best practices that we have to follow so that the productivity will be high, the time that you're going to utilize will be lesser, and the quality of the product will be quite high. So among that, few things are continuous integration, which is one of the things that you could hear a lot that is happening, where through the process called continuous integration, we will ensure that as soon as a developer does a change, immediately we will let him know if there is any problem, or if it is completely okay, we are going to go ahead with the complete testing and verify everything is okay or not. So that's what we are going to follow. Then we will follow some process called nightly builds, where we will be giving whatever the developers have created or done the change to the QA to do the actual functional testing. And further, you can do things about automated unit testing or functional testing, or even you can think about how can you do a continuous deployment. So if you focus on the e-commerce side, let me take an example of Flipkart or Amazon. They just say that, hey, there's going to be some, $1 million sale that is happening at some point of day. Now for that, internally, they have to do some changes, right? So the developer, whoever is going to change, now it has to be tested and immediately it has to be put into the production so that we as the end users access. They are not going to say that, okay, we are doing a development, so our site will be down for one day. So wait, we will be uploading all the new products and images. No, whatever the development does, immediately it has to be integrated with the product and it has to be delivered. So such a kind of process where the DevOps focuses on faster delivery is what we call it as continuous deployment. Okay, so by implementing and adopting these practices, the release cycles would be completely reduced and the quality of the product would be quite higher. So what I was talking about is only on the release, but as a DevOps culture, we are not focusing only on the release, but we are also going to focus equally and more than that on the operation side or on the system administration. So that is when from the DevOps side, we are going to do a infrastructure management as better as we can do. So in that, the first focus what we have to do is replace all our physical machines. Because now, as we keep having newer and newer requirement, if you keep procuring new and new machines, what will happen? As an organization, they have to pay too much of cost in the maintenance. And in also for procuring, they have to put in too much of cost. So that is when focus is completely towards the virtualization, where we have to focus on how is that we can create the machines virtually. And in that, how can you leverage all the services so that whenever a user wants a machine, rather than spending too much of cost and time in procuring and maintaining, we will use these machines. So in that, if you look as an administrator, still we have lot of softwares or tools that we call it as hypervisors. For example, we have things like VMware, or pretty much we also have certain more things like Oracle's virtual machine, or pretty much HyperX or anything like that similar. But if you look, by having VMware or any of these machines, you can create virtual machines whenever you need. But the maintenance effort for this is going to be quite higher. And at the same time, the resource utilization will be quite higher. What do I mean by that is, if you install, let's say, VMware on one machine, then you cannot directly start using it because that VMware itself will utilize all the resources that you have on your machine. So if you want to now create many machines virtually on it, then you should have a very good space in it, very good RAM in terms of your server, CPU, everything has to be kept on updating as we keep using more and more. So that is when you are going to put in too much of cost and maintenance. So that's when from the DevOps side, the focus is to do a effective infrastructure management by using latest methodology called as containers, where containers acts as a OS virtualization, or it is a OS virtualization where it does something similar to virtualization, but it is going to be having a lot of advantages when compared to the normal virtualization. So containers is quite lightweight and you can do it at any point of time instantly, and there is no problem from the maintenance, and cost wise it is quite very, very effective. So that is when on your own laptop, if you want, you can create 10 to 15 containers as long as you have enough resources in it. So that is how you don't have to spend too much of time as well as the maintenance as well as the cost in terms of resources. So one area that majorly that we will be focusing is how is that we can leverage these container concept, which will be helpful for the developers or to the QA or pretty much any user within the organization who's trying to do his day-to-day activity. So whenever he needs a machine or an environment, you can use. At the same time, if he wants to do a testing like performance testing, for which he needs 10 machines instantly, which will be exactly the same configuration. Rather than we spending time in creating everything, you're going to use this container through which you can replicate the environment also easily. So that's one of the major area where the process can be improved in terms of the time and maintenance using containers. Then there's one more area called cloud. What exactly is cloud? So we'll talk deeper about what is cloud in the later sessions. But for now, just think this much, that if I have a machine in my data center or in my lab physically in the company, then I have to take care of the maintenance. I have to take care of the power supply for that. And let's say suddenly our business is growing, then I want to add 100 machines. Now, for procuring machines or to create some machines virtually, maintain it, everything is going to take a lot of time. Then let's say suddenly that 100 machines you have utilized, and then you feel that you want another couple of machines. Then once again you have to set up some strategy to analyze that your business is going to grow, and based on that you have to spend time and maintain it. That is one area wherein you need to do something called a scale up. Scale up means you should ensure that whenever you need more machines for your business, you should be able to provide it. And the same thing is on reverse. That is what we call it as elasticity. So the reverse is, let's say suddenly you have completed your work and you don't need this 100 machines anymore, out of which only 20 machines or 30 machines is needed for the maintenance. So what is that you're going to do with the remaining 70 or 80 machines that we had? So unnecessarily, we are going to pay for it in terms of maintenance, in terms of power. So that is when from a company, they need to take care of the infrastructure effectively, and whenever they want, they can add more machines or remove machines. So, and all these things should be happening at a lesser cost. So that's when cloud comes into the picture, where cloud is nothing but you can consider it as a machine which is available on the internet. So who is providing? There are some service providers who give us the machines virtually through the cloud or through the internet. What is the advantage? So the advantage here is, first, we are not having the machines in our lab. So we don't have to worry about maintenance. So that if I need a machine, we will go to the internet service provider, that is the cloud service provider on the internet, and I'll say, hey, I need 100 machines. Now, without wasting much of the time, these service providers will give us the machines instantly. So that is when you're not spending too much of time in creating a machine. Now, let's say you are using this machine. And as I said, after some time, you feel that you need only 30 machines. So all you have to do is give him back and say that, hey, I'm going to use only 30 machines. So that way, now you're going to continue paying only for 30 machines and not for the remaining machines. So that way, your maintenance is also effective and it is cost effective because you're not paying for everything. And top of that, if the machines is there in your lab, let's say that there is a power outage, there is some problem in the network, what will happen? It is going to affect your complete company. But if the same thing is being taken care by the cloud service provider on the internet, it is his responsibility to take care of anything. And on top of that, it is not going to happen, but if it happens, they will already have a backup plan for that, so that our services will run without any problem. So that is how we don't have to take care about the complete infrastructure or maintenance, and we can get as many machines and configurations on it whenever we need, and whenever we don't want, we are going to give it back, so that we are going to pay only for what we are going to use, and anytime that we need, we can add more machines or remove those machines from our requirement. So that's the advantage on moving to the cloud. The next thing, is it the only thing on the infrastructure side? No. Okay, just a question. So which technologies do cloud provides internally, and how are they going to maintain physical service? So like I said, I'll be talking more about the cloud in deep, but for now, what is that you have to focus is, we are not literally worried as a company on what is that they are using, because it is the responsibility of the service provider in the cloud to give us all those machines, because we are going to pay him only for the machines that I need. So ideally, it is the responsibility of the provider to take care of it. So that is how one of the most popular things, what you call it as Amazon Web Services, which is provided by the Amazon.com. Now, they have lots and lots of data centers and labs, which they are taking care, using which we are going to take our service. Now think about having a huge data centers with thousands of machines, which is going to act as a backup for our single machine that I need. So that is the power where I am completely going to be happy, where I don't have to worry about the maintenance, as well as I don't have to worry about how the Amazon or AWS is trying to create the machine. It is up to them to take care of the business. But from my end user or a customer or as a company, if you look, I am happy because I need a machine, I am getting it from them. Whereas how they are maintaining it is up to them. But the advantage here is, if there is a problem, we have futures in the cloud where we can easily do a backup, and we can always have something in a redundant way which will act as a failover mechanism. So that is when, even when the machine that we are using, if there is a power outage or if there is a problem, we will always have a failover node or a backup machine available for that, on which our services will be transferred. So that is how our services will run uninterruptedly, and whatever the problems that is going to be faced will be taken care by the service provider, and it is very well maintained where we will not face any problems. That is the advantage. It doesn't mean that whatever the problem comes, they will take care, but still, if the problem is going to happen, our services will be impacted. So that is when they have such a kind of network and the maintenance of their data center where they have lots of backups and failovers. So if there is any problem that is going to happen, they will try to fix it. And again, we don't have to worry about anything. All we have to do is continue using our machines only for the time that I need. So that's the major advantage why companies are moving towards cloud, where they don't have to take care of the maintenance, and they don't have to take care of a huge space for putting these machines and hiring many people for taking care of that. So that way the cost is very much reduced and maintenance is effective, and whenever they want to scale up their business, they can easily scale up, or whenever they want to remove the machines, they can remove it. That's the major advantage on moving towards cloud. Then the next thing what we have is configuration management. So why is it configuration management important as part of the infrastructure management in DevOps? Now, let's say that you are an engineer, you are trying to create a machine virtually or container or a machine on cloud. Okay, so you are fulfilling only one requirement, that you are trying to create a machine. But as the end user, when someone wants to log into this machine, what is that he needs? He needs a particular application or a service running in it, right? For example, if you're a developer, let's say you want to do some Java coding and you need Java in that. Now, a test engineer comes and he says that, hey, I need to do some automation testing. I need some tool called Selenium. And then there will be a build engineer or a release manager who comes and says that, hey, I want to do some kind of management activity, so I need some tool like Jira installed into it. So that is when, on the same machine, there will be many users who are going to work. How is that you're going to configure all the requirements? And you have to ensure that whenever anyone comes and works on that machine, the application should be running as well as the configuration should be there. So that is when the number of machines are going to increase, the activity and the effort is also going to be increased. So that is when one of the concept called configuration management, through which in the DevOps, we will ensure no matter how many machines you have, we are going to automate the process of configuring all the machines, so that at any point any user goes to that machine, he will be having the state of the machine exactly as he needs. So when I say the state means for a developer, whatever he needs, that is the state. For a QA, whatever he needs, the software, the files, the services, anything that he wants in that machine would be available, and we are going to make sure to automate that no matter how many machines that we have, whether it could be a virtual machine or it could be a machine on cloud, we are going to maintain it through configuration management. And it's not just that. Finally, coming to that, in the DevOps, we are also going to focus on keeping an eye on this application and the machine, so that if there is any bottleneck that is going to happen, a bottleneck in the sense, if there is any issue that we are seeing it, we have to proactively try to fix it and provide a solution so that it doesn't cause a big impact to our productivity. So that's why, as a DevOps culture, we will also focus on monitoring all the machines as well as the services that we are going to run. Okay, so these are the ways that we can focus. Now, what exactly does the company need from an engineer? So this is the culture that we are going to do. So now we as a normal engineers, where we might be working on different role as of now. So what is that we have to do in order to get into this DevOps, or what is the organization is looking at? Rather than we moving, we should see in this way that what organization needs. So that is when DevOps is going to focus on different problem areas. So now a company wants a person who is capable on working all these different areas that we have seen. So that way, if you can classify them into a problem solving area, We have different groups like continuous integration, continuous delivery, cloud computing, configuration management, continuous monitoring, and automation, where each one of them is going to talk or solve a particular problem for the company, where as a DevOps culture, a company would be using all of them together to achieve a problem. So that is when, if you see, every organization is moving to this DevOps culture, because by this they have an advantage. On the first thing is, engineer, if they take, he will be trying to solve all of the problem or a combination of many of this. And the advantage for us now is, rather than working on one particular domain so far, you will always feel a saturated way where after some time you would have already done so much of automation and there is nothing much to do the improvement. So that is when, if you focus towards the DevOps, you have lots of career opportunities where one company would be focusing on this area, the other company would be focusing on this area. So you always keep moving towards your comfort zone or your expertise level, wherein you have lots and lots of opportunities to grow, because a company has all these problems. So it is up to us on what are the skill sets that we can develop and try to provide a solution to the company. So that's when, rather than isolating ourselves or sticking ourselves to only one domain, we can actually think about growing our career in a different way. So we have lots and lots of opportunities where we can grow ourselves as deeper as we want. Because now if you say you are a system admin, you are always going to think only about doing system administration and improvements. But now here, you are not going to talk only about that. If there is a problem on the development side, you're going to jump and provide a solution. If there is a need for taking care of the configuration of the machine, you're going to help. If there is a problem in doing a faster delivery, you're going to help in this. So that is how the career opportunities which is needed for a person to work on DevOps is quite vast, and the same thing is going to be benefited for the company because you're going to solve many problems for them. Okay, so now how is that you're going to jump into it? Now, pretty much what people would think is, I am a developer, or I'm a QA, or I am a performance engineer, or I'm a system administrator, or I'm a tech support guy, or a documentation engineer. How is that I can be a DevOps engineer? The first thing that you need to understand is, you're not trying to be a DevOps engineer, but you are trying to adopt a DevOps culture as an engineer. So what is that needed? So the first thing that you need is, you need to take care of your existing responsibility and keep a value added to it. So that is how whatever task that you're already doing is some way or the other way part of the DevOps, because DevOps is going to focus on all the problems areas, which is going to be part of the development as well as the administration or the operation side. So the first thing that you have to focus is moving towards the culture is do a cross training. So that is when come out of your comfortable zone. Comfort zone means you would have been experienced with 2 years, 5 years, or 10 years or more than that. Don't just focus that is the only area that you should focus and improve. You have to come out of it and start doing different tasks. That is when you have to be aware of different problem solving areas, and in that, what and all the methodologies or modern practices people are using. So that is the first focus, what you should be doing moving towards the DevOps. So that way, what and all are they? So that's when, whatever that the previous slide I was talking about, you should be understanding different processes for continuous integration, continuous delivery, cloud computing, configuration management, and what are the different ways you can do automation. Everything has to be learned. Second thing, DevOps doesn't start as a scratch. You always have in your existing job. So that is when the ideal way that you should focus is, what is that you're already doing? And what is that you can do the current job in a better way, in which, in addition to what you have done, you keep adding more and more tasks. So as I said, if you are already an administrator, or if you are already a person who is working on the system, don't just think only on what are the improvements that you can do. Go beyond it and see what are the automation that you can do to help the development group. That is how you will be called as a DevOps engineer. Because if you're focusing only on your administration skill, yes, there is a limitation for it also, because if you do the automation, after some time, you don't have much to do the automation. So that is when you have to think something else. So that is the opportunity what DevOps is going to give you. where you have to start with your current profile, see what and all you can add to your existing profile, and then try to do cross training where you're going to look outside your profile and start taking up more towards the development side or the operation side. And then try to do automation as much as possible. That is the key point to the DevOps. Where when I say automation, it could be anything that either you are improving a process which a company is using, or you're trying to provide a better solution to a tool that you're using, or it could be a better way of what the day-to-day task you are doing. Let's say there are a couple of engineers who are trying to do a task in 2 hours. You are trying to do something where it could be a process improvement, a tool, or handling different people. You are trying to reduce the time to 30 minutes or 15 minutes. So that is going to be important for the company that you're increasing, right? Yes. So now the question that someone was asking is, what is that you have to do as a fresher? Now, as a fresher, if you go to a company, the focus is, what is that as an interview that people would be checking? So the first thing that you will be focusing as a fresher is, how is that you're going to get in where you are aware of the latest technology? So that is when, rather than just saying that, I know only on the development side, or I know only on the administration side. If you go and now tell to a company saying that, sir, I am not just focusing on one area, but I am trying to develop a skill where I am putting forward my skills through which you can help the organization to grow. So how is that you're going to grow? That is when you're going to put in the DevOps culture where you are ready to work on different aspects. If needed, you are ready to do some improvements on the development side or on the testing side, or if needed, you are also ready to do something on the administration side. So that is when it is a kind of open culture where you will be ready. So that way, now, if a fresher comes, who will be more preferable? If a person who is having experience or willing to do only on the development side, or a person who has knowledge on all the problems that is needed for an organization to solve. So who is more preferable? Obviously a person who is capable of doing different things and who is ready to do all those things. So that is how it is, regardless of what kind of engineer you are or you are trying to get into the IT, the always focus from an organization is they need someone who can do more tasks rather than focusing on one task. Okay, now let me take a simple example and give it to you. Now, you have a house and you are trying to hire a maid, okay, or you need some worker for your house. So you have someone to do the cooking, you need someone to wash the clothes, you need someone to take care of, cleaning the house or utensils, whatever it is. Now, whenever you talk to a maid, you will be talking in terms of the charges. Now, the person who is going to come to take care, they will be saying that, hey, pay me, let's say, $1,500 for washing, and give me $1,500 for cleaning, and $1,500 for cooking. Now, what you will do? You will talk being an effective way that, hey, it's okay. I don't want to take 3 separate people to take care of different things and paying $4,500. Instead, I can hire one person who can do all the 3, and you will negotiate and you will pay her somewhere around 2,500 or let's say 3,000 rupees. Now, what is the advantage for us in this? The advantage is, rather than having 3 people, you are trying to use one person and making use of that person to get all the job done. So at the same time, your cost has been reduced to whatever it is done. That is the same concept what the companies are focusing. Now, it is not directly the way, but as an example, now they don't want someone to do the development. They don't want someone to do the administration. They don't want someone to do the maintenance, or they don't want someone to do the management. So that is how they want someone who is ready to solve different problems, be more of a generalist rather than saying that, hey, I will do only one area and I will focus only on that. That's the focus what an organization is looking at towards the DevOps culture. Okay, right now you are calling it as DevOps. Tomorrow you might call it something else. But the focus here, if you really understand what company needs, is they want you to work on different problems, that is both on the development side, the QA side, as well as on the administration side or on the maintenance side. So the final thing, that is what you need to develop, that if you are focusing towards coming into this kind of culture, is try to understand different things. Don't just focus your mind on only one area. Keep yourself broader, where you will be ready to be a generalist on solving different problem areas, and that's when it is equivalently proportional to your growth. As I said, that is why companies are paying people who are working in the DevOps side more than what you can see in the other engineers. That is because they are trying to solve more problems than a normal engineer. Okay, so that way, now, since I've been talking about that, how is that they are able to pay, and what is the pay scale that you can expect for a person who is working on DevOps? So generally, if you see, it depends on the number of experience, and it is directly proportional on how many things that you know and you can help the company to solve the problem. So that way, I'm just trying to put a median salary, which is nothing but an average salary. So don't come to a conclusion that this is the maximum that you can get or this is the least that you get. There is no limit for the salary that you're going to get, but it is directly proportional to two things. That is your skill set that you're going to help the company, and what are the futures or the skill set that company is going to take from you. So it is both directly equivalent. So that way, for a beginner with 1 to 5 years of experience, you can expect a salary difference of 3 to 6 times when compared to others, because in IT you'll always have the standard saying that your salary will be proportional to the number of years of experience, or 1 time the experience what you have. But if you see in DevOps, people are going to get somewhere around 3 times to 6 times their experience. Now that's when the average salary could be noted here. But as I said, it is not that everyone is going to get, but it is completely dependent on the company, as well as it is dependent on your skill set. And we have people who have get even more than that or less than that. That is completely dependent on these two factors, wherein this is an average salary that you can expect. In the same way, for experienced people between 6 to 10 years of experience, once again, their salary range will be anywhere between 3 times to 4 times their years of experience. And that's when equivalently the average salary, what they're going to get, it somewhere around this. Okay, so whatever the salary that I'm putting is the per annum in lakhs. And if you grow more and more experience, now once again, the salary range would be somewhere around 3 times to 4 times. But again, there is no limitation here. It's completely again up to the individual on how much they can grow. But if you see, ideally the average person among this experience would be getting up anything this much. And why is it? It is again because you are not focusing on only one area. As I said, an example of Mate, the company is also going to focus in that way. How is that they'll be ready to give more and more for a person who is doing only one area? Is it that, or they are happy to give someone who is working on different problems, helping them to grow their business and reducing the cost? So that's how the salaries are directly proportional to the number of quality things as a service that you're going to provide. Okay, so yeah, so I saw a question, how effective you are going to do? That's a very good question. So now, as I was saying, it is more important now that if a person who is going to come into the DevOps culture and solve different problems in the company, then he needs to know all the problem areas that we have in the organization. That is when we have different kind of problem solving areas called as version controlling, build management, continuous integration, configuration management, virtualization, cloud computing. So it doesn't mean that now if you're trying to do work of 3 guys, and if you are going to do all the work of 3 guys, then you will never have time to do anything else. So it is not about doing the work of 3 guys directly, but how smart and effectively are you going to do? And for doing it, how is that you are going to do automation that is needed for it? So that is what you're going to learn and be ready with yourself as a DevOps engineer. So I cannot just say that, okay, I need 3 guys for doing some task in one development, one maintenance, and one operation. Now, if each one of them are going to spend 8 hours, now if you say, I want you to do all the 3, are you going to spend the 24 hours a day on doing it? No. With the same given 8 hours, how is that you're going to effectively do all this task? And in that, what and all the processes that you have to implement, what improvements are you going to bring in, and for that, what are the tools that you're going to use for doing the automation is the important thing that you need to understand. Okay, so that's the key, where for someone with any kind of background that you want to come to such a kind of culture where you are ready to solve different problems, you need to know certain fundamental and the essential things. So that's what we are going to focus as part of our course, where for someone with any kind of background or without any kind of background, we'll be going from the scratch, where we will be not just talking about the tools, because tools will be there today, tomorrow there will be one tool. So the focus what we will be doing is, you need to first understand the concept of how you can do automation in each of the area. For that, you should understand what is the problem, how is that you're going to approach. So that is how we will be going in module by module, where each one of them will be talking specifically about a particular problem that you have in an organization, that either could be in the development side or it could be in the operation side, and together you will be ready with everything. So at the end of the course, you will be ready with knowing all the details, and in that we will be taking one tool which is most important and most widely used in the market, and you will be getting familiarized. So that is when, if you go outside to the market and be ready to market yourself, if a company needs, they can pick anything from this and they can give us task to you. So rather than you say that, hey, I know only the cloud, or rather than saying that I know only the build management, now you should be ready with knowing all those things. That is when, if a company needs you to work on build, you are ready and you know that, so that you can directly jump on and provide the solution. And if they want you to work on cloud, you can jump on and provide a cloud solution. If they want you to do some automation and scripting, yeah, you know that and you will be working on them. So that is how the, pretty much what we are focusing here is giving all those things which is essential for a person with or without any background to get into such a way that you will be confident and ready to get into the market to give suggestions and solutions to a company as being an employee. So that's the confidence that we are going to develop in understanding all these tools. So this is the beginning and to an intermediate level where you will be exposed to everything. And then after this, you have to focus on the specialized way. So that is when, once you know all those things, you will be under area that now, let me say that I want to be specialized only on this area. So that is when you have to get certified in any one of the tool. So that's when you will get into the very advanced concept of that particular tool or that particular area and get certified. But other than that, you are going to be a generalist where you are aware of all the problem solving areas and get well versed with one tool, so that if a company asks you, whether it could be a fresher or an experience, you're not just going to say that, hey, I know only this, I know all these things. You ask me any problem that you want me to fix, I will be helping you by providing a solution in working in any one of them, or you can even create a process by joining all these tools together and give a solution and working on the automation. So that's the advantage how you should be approaching towards DevOps, and that is the major focus on what we will be doing. Okay. Yeah. So on the certification, yes, pretty much you have certifications on the tool. So there is no such certification as anyone can give you saying that you are a DevOps engineer. No, because DevOps is a combination of all these things. There is no such person or anyone who can give you a total certification, because a company doesn't want a certification in a process. A process has to be learned, but you can get the certification on a tool specific. So that's when, if you want to get an expertized certificate in, for example, on the cloud, you can go and get a AWS certificate either as an administrator level or as an architect level. The same thing, if you want to get certificate in a continuous improvement process, then you can go to CloudBees or Jenkins and get a certificate only on the Jenkins. So that's how first you understand how it is going to work, what and all you're going to do. Then based on your area of interest or your skill set, you can focus on any one particular area and get the certificates. Okay. Yeah. So as part of our course, the major 6 modules that we'll be talking about is version controlling. And as part of that, we will be going with Git, which will be the distributed version control. And then as part of the build system, we'll be focusing mainly on Java, because the entire development is happening on Java only. So we'll be using Maven as the latest tool to work. And then continuous integration, we will be focusing towards Jenkins, where with the integration of Jenkins, we'll be looking into different tools like Artifactory, Code Quality, SonarQube, doing a deployment on different tools. So that is how we will not be just looking at continuous integration or Jenkins. We will be seeing how you can help the release and do the automation with various tools. And then for the configuration management, we will be focusing on a tool called Ansible, because that is one of the most popular tool that is coming up. And trust me, within another couple of months to years, everything is going to move towards this. So that is where people who are already working on tool like Chef or Puppet on the same area called configuration management, they will be moving towards it. The reason behind that is cost. Because as a company, you have to focus on working on a tool which is free for us to use, and we don't have to pay, because that is how it will be effective for the company. So that is when we are going to focus on the latest tool called Ansible for configuration management. Okay, and then yes, whatever that we are going to talk as part of the course is completely free, because you're not learning, you are trying to learn something which you can implement in your company for free. Okay, so that's the advantage that you're going to say to a company, saying that, hey, I can provide you a solution which will not cost you anything in terms of maintenance. And then for the virtualization, we'll be talking about the container concept using Docker, where how you can manage everything. And then for the cloud computing, we'll be talking on the essentials and the requirements of AWS and what exactly is cloud computing. Okay, and then additionally, based on the time what we will get, we will also go through scripting, because many companies now they ask Python. Again, it is not a requirement from a particular way that you can do automation or scripting only in Python, but it is kind of a standard where people are following. So it's always good that we also follow it. So whether you know shell scripting or Perl scripting, it is also mandatory at least to know the functionality and the essentials of Python. So that is when we will also make sure that we will go through Python. But again, as I said, it is completely dependent on the time where we will focus majorly on this area. But additionally, we'll also ensure that we will go through scripting. And if needed, we'll also be sharing on some of the previous recordings that we will be having for other tools like Chef or Nagios, that we can share it for additional along with the course. So as the course, we'll be focusing on these tools majorly. Additionally, we'll be getting more tools videos that you can do it as self-learning on top of this. Okay. Okay, so AWS Cloud with DevOps engineer and of a cloud worked using DevOps. Is my understanding correct? AWS Cloud with DevOps Engineer Professional is a certification of a cloud specialist. Exactly. Now, if you learn only cloud and if you get a certification in cloud, yeah, you are certified to only take care of the cloud or the infrastructure. Whereas in this, what we are going to see is how is that you're going to leverage that cloud to do different activity for automation as part of DevOps. So that is what I'm saying. This is the first where you should understand the essentials. And next, based on your interest and your skill set, you can get deeper into a particular WS and you can work on it. And the focus here, what we are going to do, especially on AWS, is on the essentials, because if you're looking on a certification, then you're going to focus only on that for 25 or 30 hours. But here, whatever that we are going to do for 5 weeks or more than that, beyond 50 hours, we have to cover all the tools. So that way, whatever is needed for an engineer to work on AWS, understand the concepts of AWS, different concepts of the AWS on futures and whatever the services that you're going to give, we will be completely doing. So that is when the next step for you is, if you are interested to get certified on that, with this fundamental, you can always jump on to learning the advanced topic and get a certification as an administrator or as an architect. Okay, so that's the focus that we're going to cover. And this course is going to be in the same way as we did for 1 to 1.5 hours strictly, and it is going to be completely on the technical side, and we will be giving you more and more examples on scenario based, and we'll be talking about each problem one by one, and in that we will take up one tool and we'll be solving everything. And as I said, only for the first few days, since we have more and more people, I cannot keep it more interactively. But as we drill down later on, for those who will be interested, it will be completely on the interactive way, where we'll be going from the scratch on the basics. Even for someone who doesn't understand what is Linux, we'll be going through. And there is no requirement or prerequisite to come into the DevOps. As I said, it is our responsibility and it is my responsibility to take you guys through from the scratch. And there is no need of knowing any programming language, or you don't have to know anything. If you know Linux commands, it is quite good. But if you still don't know, then we will spend some time and we will also share you certain videos where you can go through and spend some 3-4 hours of time and get ready with understanding of the Linux. And that is our responsibility to begin with that way. So that's what we are going to do. And it's going to be completely technical, and it's always going to be a practical scenario based, where my way of doing is we will first spend time in understanding the concept. So that is when you will be having some 10 to 20% of theory. It is not theory, but you need to understand the concepts, because without understanding the concept, if you jump onto the tools, you will not be able to answer questions in the interview, because in the interview, it will be a mix of tools and process. So they'll be asking, the very first question is, why did you do this? Then you will never have an answer for that, because you will be only thinking on, okay, this is the tool for this is the XYZ command, or this is how you will be doing. But the question that comes is, why did you do this? What are the benefits of it? Who did you give the service? How did you get the request on what you have to do, when you have to do? All those things you'll not be able to understand. And as I said, the tool can keep changing in another 2 to 3 years. Then what is that you will do by understanding a new tool? No. So if you understand the core subject, it will be easy for you to understand any tool that is changing, and you will always be suggesting a better improvements in the tool and the process only if you have the understanding of the core. So that's what we are going to do as part of this course, going through in the next couple of sessions one by one, and it is going to be around 5 weeks or plus or minus couple of days, depending on how people would be taking up. Okay, so that's the approach that we are going to get, and it's going to be completely focused towards interview oriented and scenario based. So that's how I'll be guiding and I'll be telling points. So if you can just note it down, and if you can just talk to anyone in those words, people would really understand and they will believe that you know DevOps, rather than just talking on the tools. You should talk now as what are the benefits that the organization is going to have. So be clear that going forward, DevOps is not a tool. That is the future where a company wants you to work on both the sides, on the development as well as the operation. So whatever is needed for that is what we are going to focus as part of the course. Okay. Yes. Whatever tools that I'm saying, pretty much we are going to cover from the scratch, and we will be spending closely, a week on each tool. And I say each week, we are going to spend at least 1.5 hours every day. So we'll be spending around 7 to 8 hours minimum on each of the tool to cover everything. Okay, so that's the way. So that's the example that I'm going to do in the next couple of sessions, where I'll be going through from the fundamental rather than just jumping on the tools. Okay, just showing you the command. I can do everything in 2 hours, but that is not the focus. We are going to give you the fundamentals so that you have the confidence to address any kind of questions that you're going to get in interview and solve the problem when you're trying to do it a real-time experience. So that's the way that we will start from the scratch, understand the concept, understand the problem exactly, understand the architecture of the tool, and then come to the practical, where for each problem, how is that you're going to solve with a particular command or a tool. That is the level that we are going to drill down. Okay. Yes, we are going to provide, first thing is all the sessions, whatever that we are going to do will be recorded, and everything will be shared to you on a daily basis. And as soon as we complete each and every tool, we'll be providing you material for all of them. Okay, so that we will be giving you exercises, we'll be guiding you on what exactly the problem you will be facing, so that you will be clear on what you will be doing when you go to an organization and not just learn the tool. So materials, exercises, pretty much for the interview point of view, what questions they can ask, that I'll be talking as if I go through the course, as well as I'll be focusing towards the interview questions, that whatever is possible that we'll be sharing, so that you can prepare onto it. Okay, so now let me stop about it here, so that that's just an introduction of what DevOps is. So For any kind of questions that you have on, once again, on the course content or other details about the duration, please feel free to write back to us or reply back to the email that you have got for the invitation so that we can help you to share the details about all the course and content. Okay. Yes. So once again, at last, we are not going to get into the basic, but we will be always covering from an intermediate level, which is above intermediate and below an expert level. So that is when you talk about Python, we cannot go completely into the OOPS concept, because if you want to be a Python developer, then again, you have to spend at least 30 hours only in Python. But it is my responsibility to make sure that we will be ensuring you will be having a hands-on understanding on Python or whatever scripting that you're going to take in such a way that you'll be ready to write any script and automate it on any requirement that you have. So that's how we'll be going from the scratch to a level above the intermediate level. Okay, so that is what we are going to cover in all the tools, from the scratch to a level above intermediate and little below to the advanced level. All right. Okay, so as I said, please get in touch with us for any questions or any queries regarding the course. That will be always happy to help you. Okay, now jumping on to the actual subject. So since I was talking about this, we will be going through these modules one by one in our class, and pretty much each of the module will take around 6 to 8 hours depending on how we're going to take, wherein we are going to start from 0 to a level above the intermediate and almost covering all the essentials that is needed for you to understand the tool and process. So that way, the very first thing that we will get into is version controlling. And I'm not going to talk about Linux as of now. The reason behind it, many people would be experienced. So for those who doesn't know Linux commands or what it is, I'll be touch basing about it a little later, or we'll be sharing you certain videos, as I said, which will be helpful for a quick start into the Linux. So first, as of the course, I'm going to get into the version controlling system, and let's spend some time in understanding that. So the first thing that we need to understand is version controlling. So in the version controlling, or we also call it a software configuration management, the tool that we are going to look and we are going to understand and work around practically is Git. Before we get into Git, first of all, let's have an understanding on what is software configuration management. Okay, and even before getting into what is software configuration management, first let's understand why do we need this? And where does it fit as part of an organization, and where does it fit as part of the operations group or the administration group? So now, if you take any software development lifecycle, the developers are the beginners who are going to write code and get the tasks to beginning. That's what they will be writing the code, right? So let's focus only on that for a time. So when we have these group of developers who are writing code, it is not just one group who will be working on the product. There might be many group of people who are working on the same product. And the developers can be in the same region, or they can be distributed across the globe. That is when you will have a person working from India, you'll have a person working from US, or you could have a person working from UK or pretty much anywhere else. So that is when what will happen is, first thing is, when a developer is writing a code, he has to share it with his peers across the globe to make sure that whatever changes that he has done is being picked up by the other person and they are collaboratively working. What will happen at this point of time is there'll be a lot of coordination problem where you do some change and your peer is also going to do the same change on the same file, and at the end, when you want to give it to the QA, which change will you give? How will you integrate both these things? So that is when there's a lot of complexity that's going to happen. The same thing now, if you are dependent on someone else's task, how will you know whether he has done it? In case if he forgot to send you a mail or notify, then you have to keep waiting until the changes is done. So that is when you have a dependency in such a way of working in the development, then we need some process to be followed. Next, let's talk about process, where in a company, you need a code. Sometimes you need to use it as part of your product and get some functionality, which could be a common code, or you could just use it as a future without doing any development. So that is when you should be able to allow people to do the changes, and we should be able to allow people only to see the changes but not to modify anything in the code. So that way, how is that you're going to ensure all this process oriented approach and permissions? And coming back to the last and the major problem, when you are working as a developer, you are not going to write one file. For example, you are trying to use Java for doing the development. What will happen? Now you will have to write many Java files to get the actual functionality of a product. So that is how, if you look a product might contain thousands of Java files and thousands of other related files. So when a developer is trying to write a file, he will not be just writing a file in one day. Depending on the criticality of the task and how long the product is going to take, you might have to take several days and several modifications that you will be doing on the same file. Now, what will happen if you are trying to do the changes on top of changes for the same set of file? At some point of time, if you want to refer anything what you have done, it will not going to be easy for you. So what is that you're going to do? You are going to take a backup and keep tracking everything. So that is when it is not easy, where if you want to know that what is the changes that you did last week, you don't know because you're doing changes on top of that. And if you literally want to take a backup of each and everything, it will not be available. And are you going to store everything in your machine? For one file, if you have modified it 100 times in 10 days, you're going to keep 100 files as a backup, so that you will know for this time this change you did and this time this file you changed. Like that you cannot keep. Now the same thing, if you have 1,000 files in your product, how is that you're going to maintain? The same thing, if you have 100 developers working on this 1,000 files 100 times, then how many backups they are going to take, right? It is not an easy to track everything. So that's when the most important thing that we need is, whenever we are working on such a kind of development activity, we need a process where that kind of process which will help us to properly track who is doing a change, when he did the change, what he's done the change, and we can store everything in a proper place where we can have a control on who should access and who should not access. So such a kind of process which a company is going to implement for the development and storing the changes is what we call it as a software configuration management. Okay, or it is also called as version controlling. Why it is? We'll talk about it a little later. But for now, understand software configuration management is a process using which we will be making sure all the code that we are writing will be stored and it will be effectively tracked, so that any point of time, no matter how many users are working, we can clearly say this user modified this file in this line at this point of time. And same thing, who should access and who should not access can be clearly classified. So that's when the goal from the SEM process is to ensure teamwork, track any kind of problem that you have easily, because now when you have too many developers doing the same change, it is very difficult for us, right? As a DevOps, you're going to focus how quickly you're going to find out a problem, so that you can do it using SEM. And if you need it for auditing purpose, you can easily track on who did it, when he did, what and all they have done. And also ensure a process is followed, so that who is going to do the change and who is not supposed to do the change. Okay, so all those things can be tracked very easily using software configuration management. There might be a question that might be coming to you as, okay, what you're talking is about the developer. How is that as a DevOps engineer, I am going to do all these things? I'm a developer, no, but we are going to assist the tool, whatever that we are going to use for it. We are going to define the process on how the development should be working. And coming to the other important point is, it is not only the source code or the Java code or whatever code you are using for creating the project should be stored. Pretty much now at this level of the culture in IT, everyone has to do some kind of scripting or coding or documentation which is needed for automation, right? So that is when, being a QA engineer, you should have been writing some automation scripts. by a developer other than let's say you are a build engineer, you are trying to write some build scripts. You are a system admin, you are going to write some automation scripts for your maintenance. So like that, everyone is going to write some kind of script. May not be a program, but a script or a documentation. How is that you're going to store all those things? So pretty much any text related files that you want to store and maintain, everyone will be using software configuration management. So it is not just a developer. The SCM is going to play an important role in almost all the areas where you have automation. So that is when everyone, including developers, QA, and build engineers, program managers, documentation engineers, IT engineers, or administrators, everyone will be using software configuration management. So that is when it is quite important for us to come into the DevOps culture where we will be effectively managing the process and taking care of the tool. Okay, so that's the important thing. So that way, now let's talk about one more thing before we get into the history. So there are certain common terminologies that you should be aware of, because sometimes if you go to an organization, you will also be working on some older tool that we have in the market for SCM, because in the SCM, one of the tool that most popularly used in the market is Git, because of a couple of reasons that we will talk. But we also have many other tools like Subversion, Perforce, or ClearCase. So what is the advantage of all those things? Now that is independent of each one of them, but the focus, what we need to know is there are certain common terminologies that we will be using in SCM, that the same thing we will also be using in Git. So that first let's understand it and then jump on to the actual Git. Okay, so to understand, let me walk you guys through some diagrams so that it will be more easy for understanding. So when you talk about a SCM system or a tool, basically how you implement a process, you will use a tool for it. Okay, now I'm not talking about Git, but I'm talking about a generic tool, any kind of tool that you're looking into the market. This is how it will be working. So primarily, when you take any tool, it will be having a server and a client model. What do you mean by a server and a client is, you will be having a server software where you will be storing everything. Whereas you will be having one more thing called as client, which we will be accessing it from our laptop or from our machine. Okay, so you can consider that as the client, and whatever that you are going to store and maintain, we are going to call it as a server. Okay, so now let's take that for your SCM tool, you are having a server where you are maintaining everything. So what is it going to do? This is the server where for each product, whatever files that you are going to write, you are going to put inside it and store it. Okay, how you are going to store, that is what we are going to learn in the practicals later, but here focus on the concept on what is the terminology. So now in the server, I'm going to put all the files related to all the products that we are maintaining. That way, the same server will be having various products that we are going to work in the company. So let's say your company has 3 products, A, B, C. Now, if you're going to use the same server, you're going to put all the files related to product A, related to product B, and related to product C inside it, right? Then it will be confusing for us to maintain. So that is when what we are going to do is, basically, we are not going to dump everything directly, but inside this, we are going to create something called as container. Okay, so what do you mean by a container? Container is nothing but a place where you store something. Same way, inside our server, we will be actually creating a container which is called as repository. Okay, where a repository is nothing but a place inside your server where you will be storing and maintaining all the files related to one product. So like this, for each product, you will be having one container or repository in which you will be trying to store all the changes related to that product. Okay, so now I can have a repository A, and I can have one more repository called B, where this is the one where I'm going to store all the files related to this product. Same way, I can have one more repository where I can store all the files related to this product. So that way, a repository is the place in your server where you're going to store all the files related to that particular product. Okay, now you can have as many repositories as you want depending on how many products that you're going to work on. Okay, now here, if you get into a repository, in this, as I said, all the files related to that particular product will be available in this. So if you have these two files for your product A, then it will be available. So anything that you do here will be known only to this. Same way here, if you have some file, now anything that you're going to do inside this is known only to this repository because it is a closed environment where you're going to store all the files related to only that product. So that's why even though you can see the same name, both are not same. This is something similar to only this product, and anything that you're going to store is known only to this repository or this product. Like this, you will be having many repositories where you actually store all the files. Okay, now this is where you're going to store. But now as a user, what is that we are going to do? So that is when on our machine or our laptop, wherever that we are going to work, first thing what we will do is we will create something called as workspace. So a workspace is nothing but a directory where I will be trying to work on the files of a particular repository. Now, let's say that you are interested to work on product A. So to work on the product A, you need all the files to be visible on your laptop. So that is when you are working on SEM, you will create something called as a workspace, which is actually a directory. Directory means a folder in which you will be able to see the files corresponding to a particular repository, and this is the place where you will be doing all the changes. So it is nothing but a directory in your machine. But how is it on your machine when you have a directory, you are going to get the files from your server? So that is when we will be using the client. Okay, so you will have the software called as client, which will help us to interact between the server and your machine, so that anything that you want from this machine, you will tell it so that it will get it from the server. The same thing that anything that you want to do from the server, you will be interacting. So the interaction between the server and the user's directory or workspace is going to happen through client. Okay, now you are interested to work on the product A. That means you should be able to see the files of the product A and do the changes. So that step where you will be trying to get the copy of the file from a repository inside your workspace, so that this is where you will be actually modifying the files, not in here. Like this, every user will create his own workspace, and in that workspace, he will be trying to get a copy of the repository where he will be able to see the files and do the changes. Okay, so this step where from the server, you are taking a copy of the file and putting inside your directory or workspace is what we call it as checkout. So checkout is the process where you will be able to see the files inside your workspace on your machine corresponding to a particular repository. Like this, if you want to work on product B or repository B, you will create one more workspace, and in that you will do a checkout so that the files corresponding to this repository will be available in that particular workspace. Okay, so the first thing that you will do is create a workspace, and in that do a checkout based on a particular repository, and from that you will be able to see the files. Then in this you will modify this file as a developer, and once the changes has been done, you have to store it back to the repository. So that process where you tell to the server that these are the changes that you have done and you want to store it back to the repository is what we call it as check-in. Okay, so checkout means you will be able to see the files, do the modification, and do the check-in where you will store the files back to the repository. So like this, each user will do a checkout in his workspace and do a check-in corresponding to that. It will be trying to store all the information. So how is that it is going to store? So for every check-in that a user does, pretty much, it is going to create a reference in the corresponding repository. Now, if you see, you are working on the repository A here. So if you do a check-in, it will be trying to store a commit or a reference here. Okay, before that, let me tell you in this way. So it is going to create a reference. So like this, for each developer who is going to do a check-in, it is going to put a reference inside the corresponding repository. Suppose you are working on this repository. If you do a check-in from your workspace, it will be creating a reference here. So like this, for each user, when he does a check-in, a reference will be created. And this is the reference which will be having all the details about who is the person who did the check-in. In that check-in, what files he modified, when did he modify it, and what and all he modified, and how many files he has modified. Everything will be stored in this particular reference. Okay, that is how we will be tracking on who changed it, what changed, when did he change, and what all he changed. So everything will be referred. This way, for each of the repository, there will be specific references which is created. Okay, and now these references that you're going to have will be individual, or it will be with respect to only that repository. This repository doesn't know anything about this because it is stored only for this files. Same way, anything that you store here is known only to this. So these references that we are going to store in each repository is what we call it as a version. Okay, so a version is nothing but a unique identification as a reference which we will be using to track who changed, what changed, and how and when it was done. So all this information we will be storing it inside the repository. So getting it? So this is what you will be doing practically when you're working. So you will be having a server in which you are going to store a repository where all the files related to one product you are going to store in it. And in that, if a user wants to work, he will create a workspace, and in that workspace, it is nothing but a directory. He will do a checkout with respect to a product repository. He'll be able to see the files, do the modifications, and do the changes, and do the check-in where it will store it as a reference, where each reference is called as version. Okay, that is why the tool or the software configuration tool is also called as version controlling tool, because this is the one using which we are going to maintain and track everything. That is why it is also called as version controlling system or tool. Okay, so hope it is clear for everyone on what the concept is. Okay, so that way now if you jump on to the Git, so we have lots of other tool, as I was talking about, which works on this concept and provides a solution, but there are a lot of disadvantages on these tools, and that is when majorly Git came into the market to support few things. That is, the advantage why companies are moving towards Git is speed. So comparatively, if you have worked on other tools and you work on Git, you can see that the operations, whatever that you are going to do, that is checkout, check-in, or creating workspace, or versions verification, creating repository, all those things is going to be very fast. And next, there is a concept called non-linear development or branching, that there is no limitation of that in the Git, whereas we have a limitation on the maintenance aspect on other tools. And then Git is completely distributed. Okay, and you can handle a very huge product also simply in Git. So these are the major advantages on why Git is being used. And pretty much when we are going through the practicals, this is what we are going to go through and understand on how it is faster, what is the non-linear development activities it is going to help, how Git is fully distributed. That is what we are going to see one by one in all of the later sessions. Okay, so let me stop it for today so that in tomorrow's session, we'll try to understand on what is the architecture specifically. So let's try to compare with what is the current architecture that we have spoken, what is the architecture of Git, how it is different, and let's go through internally on each and every details on how this version is getting stored, what exactly you will be doing in terms of check-in. So we'll spend some time in understanding the concepts, and then in the next tomorrow session, we'll try to see on how to create a repository, and we'll be proceeding further. Okay, so let me stop it here for today. And if there's any questions, I'm open to discussion for the next couple of minutes. All right, so in the last session, we were just trying to quickly go through on what is the advantages of Git, and we try to understand what exactly is SCM. And in that, we try to basically understand what is the SCM terminologies in which, what do we call it as a server or a client, what is a repository, what is a workspace, the checkout and check-in, and the revision. So those are the fundamentals of the particular SCM technologies or the terminologies that we learned. Okay, so with this understanding, let's move ahead directly into the Git, where we'll try to understand further on what are the details on how Git is architectured and how Git works and how is it different from other tools. So in the last class, that whatever we were discussing on the client and the server architecture, where the repositories will be stored in a server, and whenever a user wants to work, he has to create a workspace in his client machine doing a concept called checkout and check-in. So typically, if you can see the diagram over here on the left-hand side, now this is the centralized model which I was trying to explain you yesterday. That is this particular model, okay, where you have a server in which you have one particular repository onto which from different machines where the user have clients, they'll be trying to do some changes and store the changes into the specific repository. So that kind of repository model where we are going to have one central server in which there will be only one repository and all the users have to do the changes and store into that particular central repository or a server. So this kind of model where we have a separate server and we have a client where users will try to do the changes and store into it is what we call it as a centralized model. Now, typically, all the other SCM tools so far that we have in the market, other than the Git, especially like Subversion, ClearCase, Perforce, or CVS, everything works on the same model called centralized model. But the problem with these kind of models that we go ahead is, the first thing is, since we have a separate server and a client from which a user will do the change, in case if a user wants to do some change, the operations will not be quick enough to get it done. That is because the central server can be obtained or should be available in a different zone. For example, let's say your organization's headquarters is present somewhere in US. So they will have the data center in US, and because of that, this central server on which the repository is residing could be somewhere in US. And now, as a user, when you are trying to work from your machine somewhere in India, then because of the network latency, there's going to be a lot of delay in doing the process. So that is when a simple checkout where you have 10 files or 100 files which you want to get it from the repository to your workspace is going to take a longer time. Now, consider about working on a product where you have 100 gig of storage, or you have the data of 100 GB of your source code. So to do the simple concept of checkout, in order to just see the files, a user has to spend more than half an hour or 1 hour just to create a simple workspace. So that is when any kind of operations that you're going to do over the network is actually going to take a lot of time. The next problem is, since if you want to keep working on it, there always have to be a connection between the client and the server. So if there is a network outage, or if the network is not available, or in case if you're bringing your machine out of your network, then you cannot do any kind of the operation. So that is when you have a drawback where the client and the server, unless and until it is in connected mode, you cannot do anything else. So if it is not connected, then you cannot do anything. So that's the second problem. You can do the operations only if there is a proper network between the client and the server. And the third important thing is, it is not just one user who will be working. So there will be many users who will be having many clients, and each one of them will be doing changes from their own workspace or the client machine. Now, if one person as a developer or a user has to share his change with someone else, then first he has to do a checkout, and then do the changes, do a check-in so that it should get updated in the central server, and then the other user has to do a checkout once again. That's how he will be taking the latest changes what this person has done to his workspace, and then on top of that he has to do the change. So like this, if this person has to share his changes directly with anyone else, then he has to go through the same process where it is going to take once again a lot of time. So that is when working on a centralized model is actually time consuming, and it requires a lot of maintenance effort, and it is not much of a user-friendly way. So what is that the Git is going to give as a solution for all these things? So that is when, if you try to understand, Git is also a version control system or a tool, but it doesn't work on a centralized model. So what is the difference between Git and any other tools? The first thing that you need to understand is, in Git, there is no concept of server or client. Once again, in Git, there is no concept of server or client. Now, that might lead a confusion to you that, okay, if you say there is no server, then where are you going to store everything? Because in the centralized model, we had a separate server in which we had repository, and that is where we were trying to store everything. But now, in Git, if I say you do not have a separate centralized server, then where is that you're going to store? So to understand this, the very first point that you need to understand is, in Git, everything is a workspace. Once again, in Git, everything is a workspace. Okay? Okay, the font is too big. All right. So the first thing is, in Git, everything is a workspace. So now, when I say everything is a workspace, every workspace now will have a copy of a repository inside it. Okay? So the second thing what you need to know is, every workspace will have a copy of the repository. Now, what do you mean by copy of a repository? Unlike in the previous model, when we were trying to discuss this, in the client where the user will create a workspace, you will be able to see only the files, right? But in Git, you do not have the server at all. All you have is only the workspace, where every user, when he creates a workspace, he will also get a repository inside it. So that is how, if you're trying to create a workspace to do some changes for a particular repository, then you are actually going to create a workspace in which you will also be getting additionally a small repository. Okay, so that is what is going to happen in Git. So that is why now every workspace in the Git will have a repository associated it. And now everything in Git is a workspace. Now, once again, that might lead to another question, that if I say everything is a workspace, you always need a place from which you have to start doing some changes, right? Because a normal workspace is nothing but a work directory where a user will be doing the changes. But where is that you're going to store everything where every person can share? So that is when we will be following the methodology of centralized model, where we will take only the concept, in which what we will do is, we will take a copy of a workspace and we will keep that workspace as a centralized workspace. So now what we will do is, in Git, everything is a workspace. That is first. And second thing is, every workspace will have a repository inside it. And now, by saying it, what we will do is, we will take one particular repository or one workspace, and that workspace, we will mark it as a centralized workspace. Why is that we have to do? It is because now, that workspace which is going to act as a centralized workspace is used only for sharing the contents. So that now, if a user wants to do some changes, what he will do is, he will try to create a workspace based on this central workspace. And in that, what he will get is, he will get the complete content of whatever you have in the central workspace. So that now, he can do the changes whatever he wants in his workspace, and when he wants to share it with others, then he will first share it to the central workspace, so that others will try to take the changes from this central workspace. So that is the same concept of how you are going to do. But the advantage here, what you have is, you will have a copy of a repository inside each workspace. So that is when you will be having one workspace which is going to be treated as a central workspace. And what is the purpose? The purpose of that workspace is to only store the change and share the change. So now, if a user wants to do some change, then he will try to create his workspace, which is nothing but a copy of this particular workspace. Now, when he creates his own workspace for doing the changes or development activity, he will be getting all the files that you have in the central workspace, and along with it, you will also get a copy of the repository inside his workspace. So that way, every user who creates his workspace will get a copy of the repository based on what central workspace he is creating. So now, the advantage here is, unlike this, you don't have to worry anything about being on the network. So you have a copy of the repository in the same directory. So you can see the file, and any operations that you do, it will be very fast because you are not taking anything to view from the central workspace. You have a copy of the workspace repository inside your workspace. So that is how the operations will be quite quicker, because if you want to get some data, you are going to get the data from the repository which is available on the same workspace. So that is how the checkout and the check-in concepts is going to be very faster, because every workspace will have its own copy of the repository. So that way, now a user can continue to do the changes, and he can store all the changes in his own workspace where there is a repository that will be getting stored all the details. And whenever now he wants to share the changes with others, he will be sharing it to the central workspace. So that now, if this person wants to share changes with another person, he can directly share between it, or he can share it to the central workspace so that he don't have to worry who is asking him. So that way, where you can directly share the changes between the user's workspace or between the user's workspace and the central workspace, is what we call it as a distributed model. So that is when we have an advantage where every user who creates a workspace will have a copy of the repository. But the difference is, in this workspace where the user has created, he will have the ability to see the file, modify the file, and store the file. Whereas the central workspace will also have a copy of the repository, but you cannot see any file in it or modify any file. The only necessity of the central workspace is to store the changes. Okay, so that's the difference that we need to understand. So be clear in this. The first thing is, in Git, everything is a workspace, and every workspace in Git will have a copy of a repository. And basically, we will have two types of workspace. One is central workspace, and the other one is the user or the local workspace, where the central workspace is used to store all the changes and share the changes, whereas the local workspace is used to modify, edit, or store and share. Okay, so that's the major difference on what are the advantages that you will be getting. Okay, so now when I say that, basically every copy of the workspace is going to have a repository, which means every workspace that you're going to create will ideally have a repository inside it. Now, by saying it, then there might be a problem that all the information, that is the references that we are creating, will be stored internally, right? Here in the centralized model, I was saying you will be having all the references that a person does when he does a check-in will be stored here. Now, when I say that every workspace has a copy of the repository, then all these references will actually be stored inside it. So will it not be a huge problem and the storage problem where you are not only able to see the files, but you are having the complete repository in this workspace? So that is when what we need to understand is how Git is trying to store the changes. Okay, so pretty much now Git uses a concept called snapshot. So what do you mean by snapshot? So you might have heard this word a lot of time in your mobile or in your PC where you try to take an instance or a reference at that particular point of time. So let's say that you're working on a web page and you want a screenshot of it, right? So at that point of time, what do you exactly have? So that is what we refer it as snapshot. So how does Git uses it? Now what Git does is, whenever you do some change and you are trying to store it into the repository, what Git will do is, rather than storing the change directly, it will try to take the delta or the difference between what you already had and what is that you have modified. Okay, so only the difference it will try to take a snapshot, and that too, it will not take the complete content. It will take only the snapshot reference of what you already had and what is that you're trying to put. Okay, so that terminology is what we call it as snapshot. So using the snapshot, it will be trying to store all the details. So at any point of time, if you want to know who did the change, what change he did, and when he did, internally, it will be through the snapshot what it creates. So as soon as a user does a modification and he is requesting the Git to store the changes into the repository, he is not going to store the changes directly, whereas the Git will take a snapshot, which is nothing but the delta difference of what he already had and what is that he is trying to modify, and that snapshot difference is what it is going to store. So that is why the repository that you're going to have inside your Git workspace will not be huge. So it is very lightweight. Okay, unlike other repositories that you've been using in Subversion, Perforce, or ClearCase, the Git repository is very lightweight because you're not storing everything as a file. You're just storing the snapshot difference between what you did and what you already had. Okay. Next, so in Git, when you do the check-in, that is after you modify, you are supposed to do the changes to be stored into the repository, right? That is what we call it as check-in that we understood from the last session. A check-in is nothing but in your workspace, you do some change and you want to store that change as a reference inside your repository. So in the same way, now, if you take a particular workspace on your working, you will do the change, and when you try to do a check-in, it will try to store the reference in terms of snapshot into the particular repository which is available in his workspace. So now in Git, we don't call it as a check-in. Instead, we call it as a term called as commit ID. In fact, a check-in is referred as a concept of commit. Check-in or commit both refers to the same terminology where you are trying to take the changes that you have done in your workspace and you are trying to store it inside your repository. Now, every time when a user does a commit, there will be a reference created inside the repository. Once again, that we saw from the last session, and that is what we call it as a version. And specifically in Git, we call that as a commit ID. Okay. So, okay, I had someone asking the question, what is snapshot? Now, to be clear once again, so what is a snapshot? At that particular point of time, what is that you have? So when I say the relation between what you do in Git is, you will have some file and some content already stored in the repository, and you are trying to do some change on top of that. So you will do a checkout, take the changes from the repository inside your workspace, and that is the directory, and do the changes. And once you do the change, you will try to do the check-in. That is the concept that we were trying to see yesterday. Now, when you try to do a check-in or a commit in Git, what Git does is, it will not directly take all the changes or the complete file and store. So what it will be doing is, practically, it will be taking only the difference of what you already had and what you have modified now, and that too, not the content, but only the snapshot reference. Okay, it's just like a screenshot copy that you take that will tell you what exactly you had at that time. Same way, what you already had and what you have modified, that screenshot or a snapshot is what Git is going to take, and that is the reference that it will be storing it every time you do a check-in or commit. Okay. So that way, every time when you do a check-in or a commit in Git, you will be actually creating a version or a reference. And that reference in Git is what we call it as a commit ID. So why is it important that we should know? Now, commit ID is the reference which Git is going to exactly store. And only with respect to that, we will be able to track on what exactly the changes has been done, who exactly modified it, and what and all you have modified. Okay, so every time you do the modification and do the check-in or commit, Git will be creating a commit ID. So what exactly is this commit ID? As I said, a commit ID is a reference which the Git will be using to track the changes. Now, for us, if you look, a commit ID will be a 40 long characters that the commit will be creating. So every time a Git does a commit, you will be getting a 40 long characters that is unique. So every time a user does a commit with some change, every time for the commit, there will be a unique 40 characters that will be created, and that is what we call it as a commit ID. Okay, and this ID cannot be changed or manipulated because it is going to refer internally to the set of changes that you have. So that way, every commit ID that we are going to create will be having certain factors, like the first thing that the commit ID refers is the snapshot of that particular change. Because what is that you are doing? You are doing a commit. What is the purpose of commit? You have modified something, right? And in that way, what is that you have modified? So that reference will be taken care by creating a snapshot. Okay, so that is when a commit ID is nothing but a 40 characters, which is a unique ID, which is being created by Git and stored by Git, which will have the details about who is modifying it and what he has modified and when he has modified. Okay, so that way the commit ID, every time a user does a commit, it will have the details about what is the snapshot. Snapshot means now we can get what is the changes that you have done. So that is how it is going to store the snapshot, not the content of the file. The next thing, who is the author of the changes that has done? Okay, then the committer. Kavya, commit ID, once again, if you're not clear, commit ID is not the username. When a person does a commit in his repository or his workspace, Git is going to create a 40 character. Okay, that is a unique ID which Git will be using to recognize or to track what that person has done. Okay, it's just like, if you're trying to write an exam, you will be given a unique ID, right? That ID is not your name. That is an ID which refers to who is the person, what is the exam is going to write, and for what particular subject you are going to write. In the same way, every time when a person does a commit in a Git, what Git will do is it will uniquely create a 40 characters, which is the ID using which you will be tracking everything. And that ID will be actually consisting of several factors, that is the snapshot of the changes what you have done, then who is the person who is trying to do the commit, and then what is the date and time on which you have done the commit. And top of that, you will also give something called as a commit message, where it is going to be helpful to know whether the person is doing a change for a particular reason. Because at any point of time, if you look at the commit ID, it is going to be a 40 characters. So it is going to be a combination of number and some kind of alphabets that is unique to Git that we won't be understanding. But how is that I can know who modified? So that is what the commit ID is going to have, all these details. Okay. Now, commit ID, once again, Kavya, if you're not clear, it is just a random number which Git is going to create. It is nothing related to a company. Okay, so it is going to be a random number which it is going to create. So it is a random 40 characters which is going to be created uniquely for every person who is going to create a commit. In that commit ID will be having the details about who is the person who modified. Now that depends on which company are you working in. That company, what is the person's name that has been given to work. So that details will be stored. Okay. So a commit ID is the actual reference using which Git will be storing everything. And if you look at a commit ID, what and all details you will be having in it. You will be having the details about who is the person who is doing the commit, what date and time he did, what exactly changes that he did, that we will be getting from the snapshot, as well as what is the reason on why you are doing this. So that we call it as a commit message. So all those things will be stored together as one commit ID. Okay, so like this, every person who does a change on a workspace, it will be clearly tracking with a unique 40 characters that is referred as a commit ID. So if you are going to do changes 4 times and you're going to do 4 check-ins or 4 commits, in Git, the repository will contain 4 unique 40 characters, where each 40 unique character will be representing at that point of time who modified, what he modified, when was the date and time it was modified, and what is the purpose on which you are modifying. All those things will be tracked. So that is how we will be able to easily know who exactly is modifying and what has been modified. Okay. Now, when I was talking about Git, so I said one thing, that in Git, everything is a workspace. And second thing, in Git, you will also have a repository in every workspace. So that way, now if you try to do a deeper dive into a workspace. So if you open a Git workspace, what and all do you have inside it? So ideally, when I say a workspace, it is nothing but a directory in your operating system or a folder in terms of Windows that you call. So if you go inside a Git workspace or a Git directory or a folder, you will be basically having 3 areas inside it. Okay. So what are the 3 areas that you have inside it? The first area that we will have inside it is called as a working directory or a working folder. So what is the need of this working directory? The working directory is the location inside your workspace where you will be actually doing the changes, where you can see the file and modify the file. So remember, in a Git workspace, it is an area called working directory. Only in that place you will be able to see the files and modify the files. Okay. The next thing, as we know that in Git workspace, you will also have a repository inside it. So that is when in the workspace, there is a second area called Git directory, where this Git directory is what going to be acting as a repository for that workspace. Okay, so that is the second area where any changes that you do will be getting stored into this place which acts as the repository. So the second area that you have inside your Git workspace is Git directory. So now, what happens when a user does changes is basically first the user will be going inside his workspace. In his workspace, he will be able to see the files and modify the files from working directory. And once he does the change, then he has to do a check-in so that everything will get stored into the Git directory or the repository. But we now know that if you want to do a commit ID requires the snapshot, right? Only then it will be taking a reference of what exactly changes we have done. So for that purpose, we have one more area inside your workspace that is called as a staging area. Now, staging area is actually a buffer area, which means you cannot see the directory or you cannot see this workspace inside your Git workspace, okay? But logically, it is present there. So what is the necessity of this? So now, if you are trying to do the check-in or commit concept in Git, then it is not directly taking the changes what you have done here and putting it inside to the repository. So in Git, the check-in has to happen in two steps, where the first step what you will do is in your working directory, you will modify the file, and from this directory, you will take those changes and put it into the staging area, where as soon as you put the changes into the staging area, Git will be taking the snapshot of the references on the difference what you have done. Okay, so that is when, as soon as you have done the changes, the first step that you have to do is put into the staging area. Then, after you have put into the staging area, then you have to do the actual check-in or commit, where what Git will do is it will take the snapshot reference what you have tried to put here, and with respect to that, what is the user who is doing the change and at what time he is trying to do the change, it will collect all those information along with the snapshot that it has created in the staging area. It will try to create a unique 40 characters, which is the commit ID. So that is how the workflow is. First, user will do the modification in his working directory, and then he will take the changes and put into the staging area, where the Git will take the snapshot. And after that, from the staging area, we will be actually doing the commit, so that we will take the commit process for which the Git will take the snapshot from the staging area, and then it will take the other details on who is the user who is doing it and what is the date and time and the message, and with the combination of all these things, it will be creating a unique ID which will be 40 characters. And at any point of time, using that unique 40 characters, which is the commit ID, we can know what was done in that and who did this change and what and all are the change that we did. Okay, so that is what you are going to have. So remember, if you go into a Git workspace, you will be having these three areas, and the workflow that you have to follow is first modify here, then put into the staging area, and then from here you do the actual commit where it will be storing into the repository. And all these things are going to be part of your single workspace. Okay, so don't think that everything is going to be separate. So if you create a workspace, okay, now you are going to have all these three things together. Mujahid, that is what I was trying to tell you, that when you want to create a commit ID, you need a snapshot. Only with that reference, it can tell you what has been modified. So that is when you cannot directly do a change and put into the repository. So if you have to do the commit, the first thing that you have to do is take the changes from the working directory and put into the staging area, where only in the staging area, Git will be taking the snapshot. So for doing a commit, you need one of the factor that is the snapshot. That is how it is going to track everything, right? So that is what you are going to get by putting the changes into the staging area. So that is how there is a two-step of commit where you do the changes first, put into the staging area, where it will take the snapshot of what you already had and what you have modified now. Only that difference snapshot will be taken, and that will be considered as putting inside to the commit ID. Okay, so as I said, you need to remember that you will have all these three areas inside your workspace. So just to quickly say, now if you create a workspace in Git, let's call this as a Git workspace. Now every Git workspace will have three areas. So that is, the first one, you will have the working directory, and then you will have the buffer area called the staging area, and then you will be having the repository where you're going to store everything. Okay, so the first area that you're going to have is your working directory, and then you will have the staging area, and then you will have the repository, where in this particular working directory you will be actually seeing the files and doing the modification. And once you have done, what we will do is we will try to put the changes from the working directory to the staging area. And in the staging area, what we will do is we will take the snapshot reference of what you already had and what you have modified. And once you have done the changes, then you will be trying to do the commit, where in the commit, what we will be doing is we will be creating a unique 40 characters, which we call it as commit ID. Okay, so you will be creating commit ID 1, commit ID 2, like this, where each one of them will be 40 characters, which is unique to the reference, where each one of them will refer to a particular snapshot and the changes what it has been done. So remember, everything together is what we call it as one Git workspace. It is not separate directories. Everything is inside one directory under your workspace. Okay, so that way, the only thing that we now need to understand in the Git is what is the life cycle of the Git files that you're going to undergo. Now, when you consider a repository, any kind of repository, you will not be having everything there, right? Basically, you have to always start from scratch, no matter whatever it is. So that way, when you first create a workspace or a repository, so internally now, whenever I say that you are creating a workspace, we now know that in Git, a workspace comes along with the repository. So that is when I say a workspace, it will always have a repository inside it. So you can either call it as a repository or a workspace. Both are pointing to the same directory. Okay, so that way, when we create a new workspace, that will always have a repository and that will be empty. That is the first time that you're going to do. So now, when you try to put a file inside it, the first thing that you will be doing is putting the file inside the working directory, because this is the only place where we can see the files and modify the files. I cannot go inside any other place and do modification. This is the only area that we have to use to see the file and modify the file. So that is when first we will try to create a file in this working directory. So now, when you create a file in your working directory, and that is a very fresh file or a new file, and there is no details about it in the repository, or your repository is completely empty when you start for the first time, right? So that is when what Git will be considering is any new files that you are trying to put inside your working directory will be called as untracked file. That is because there is no detail about that in the repository. So what do you mean by tracking? Tracking means we know something about it, right? So if you say that, hey, I know certain details about it and I'm trying to follow that guy, that means you know much details about him or a particular person or a particular data. That is how in Git, with the reference of the commit ID, it will be trying to track, saying that, hey, you did some change. That is because I already know that this is the content what you had in this file, and top of that you are trying to do.
So that is when a file will be tracked in terms of the commit ID and internally the snapshot. Whereas if you're trying to put a new file, what will happen is there is no reference about that file in the repository. Hence, the file will be called as a untracked file. So remember, a new file that you're trying to put inside the repository will be basically considered as an untracked file because there is no information about that file in the repository. So whenever you first have a file, you will put into the staging area, and as soon as you put the files into the staging area, then the file will be considered as a staged file. Okay, and then what will happen is when you try to store the change from the staging area to the commit ID, now the file has been tracked inside the repository using commit ID. So that is how the status of the file will now be considered as unmodified. That is because whatever content you have in the repository is the same content that you have inside your working directory. So from the untracked status, you are going to make it as a staged status, and then the file will be marked as unmodified, because when it compares with the working directory's content and what it has in the commit in the repository, there is no difference. So that is how going forward the file will be called as a tracked file. And when you say a track, you're not going to say that I know the information. Specifically, you're going to say what is the status of the file. So that is when you create a workspace and on an existing file, if you try to do some modification, what Git will do is it will try to compare the content, what it has in the repository with what it has in the working directory. And in case if there is any difference, then the status of the file or the files will be called as modified. Okay, so modified means it knows about the file, right? That is how you are going to say it is modified, because without knowing anything about it, you cannot say whether it is modified or unmodified. So a modified means the file has been tracked by the repository or Git. In that way, when you do some change, first the Git will be considering the file as modified. And then when you put the file into the staging area, the status of the file will be called as staged files. And then when you try to do the commit, the file will be stored into the repository with the reference of commit ID. And in that, you are going to change the status where the file will be called as unmodified, because whatever that you have now in the working directory, the same thing has been stored into the repository. So there is no difference between these two. Hence, the file will be called as a unmodified. So remember, any new file that you're trying to put into the repository, for the first time it will be called as untracked. But as soon as it has a reference into the repository, then it will be called as unmodified or modified or staged based on what you have in it. If there is no difference between what you have, the file that you're looking at in the working directory versus what it has in the repository, then it is called as unmodified. And as soon as you do the modification, then when it compares between what you have in the working directory versus what it already had in the repository, then you are considering the file as modified. And once you do the staging, it will create a snapshot. And after that, when you put a commit, now whatever that you have here is being stored permanently into the repository. So that is how the file will be called as unmodified, because there is no difference. Okay, so this is the life cycle of a file or a directory that you do changes. And the next thing that you need to know is in Git, you will be working on the working directory. And once you have done the changes, you will put into the staging area where it will create a snapshot. And then finally, you will try to do a commit where it will take the snapshot reference and create a unique 40 characters, which is called as commit ID. Okay, so this is the workflow and the fundamentals that you need to understand, because as we keep going on into the practicals, we will be talking only about this itself. So be clear. So Any questions or doubts before I jump on into the practical and show you everything on what is a workspace, what are the areas that you're going to have inside the workspace, and what is the purpose of each one of them? How is that you're going to do a commit, and what happens when you do a commit, and how exactly the commit will be storing, so that we will see all those things in the practical on how to create and what exactly each one of them, what commands you will be using. Is it clear, or any questions? You can write in the chat if you have any question.
From my end, nothing.
Okay, so I take it as a S that you have understood. So again, if you have any questions, just stop and ask it. So now, if you have understood those essentials, now let's move on to actually creating a workspace. Okay, now, before you get started, the first thing that you need to do is get the Git installed. Now, unlike other tools, as I said, you do not have a separate server and a client. So all you have to do is install one small application or a software called as Git client, and that will help you to start working, where using that, you will be creating workspace, you will be trying to do the changes, you will be trying to do the commit, and you will be trying to sharing it between the central workspace and the local workspace. So all those things you will be doing using one tool. So if you want to work on Git, all you have to do is on your machine, make sure that you have installed the client of Git. So there is nothing called as a separate installation for server. There is only one installation that we call it as a Git client. Okay, so how is that you're going to install? Now, if you go to the Git download site, or if you go to the Git site, you have different types of executables based on the operating system. Okay, so all you have to do is, whether it could be a Windows machine or it could be a Linux machine, or if you're having a Mac, then you can just go ahead and click. This will try to download the specific executable. Once you download it, just run it. Okay, so there is no difference. And pretty much now, whenever we are going to work, there is again no difference on how you are going to install, but we are going to use completely from the command line way. So that is how, whether you are installing it on a Linux machine or a Windows, for practicing, it is not going to make any difference. But the only difference that is going to make in your production is, if you're trying to install it on Windows, then there might be certain performance issues, because we know the Linux fundamentals is, on a Windows machine, you cannot access multiple users at the same time. Whereas in Unix, you can access the machine or a software at any point of time as a multi-users. So we have certain limitations that way. So that is when in organization, when you go for production, they will be using Linux machines. But pretty much for our practicals or for your practice, you can install it on Windows also, because it is the same command, whatever that you're going to use in Windows will be used again on Linux. So there is no difference in the concept or the workflow. Okay, so only difference is where you're installing it. So that way, even in my case, I'm going to install it on Windows, and we are going to work on using the Git command lines. Okay, but in Windows, if you're installing Git, you will have an additional feature where as soon as you install Git, after you download a specific executable that you get here, if you go, you will be getting an option like this, where in that you will have two command lines option that you can use. One is git cmd, the other one is git bash. Now, the advantage of using this git bash is, as you know that, in case for those who doesn't know what is the bash, I would suggest to go through the Linux essentials so that you will get an understanding on what bash is. But again, to just quickly give an introduction, a bash is nothing but an environment using which you will be working on any Linux machine. So what is that Git is doing here? So if you are installing Git on Windows, additionally, it is going to give you a command prompt where you can have a bash-like environment in this. So look at this. This is not a Windows command prompt. Okay, this is my Windows command prompt, whereas this is the bash command prompt which is coming by the Git. And the advantage here is, if you want to work on the basic Linux commands, you can use it on the git bash command prompt, whereas you cannot run it on the command prompt given by Windows. For example, if I want to type in some basic commands, that is Linux commands, this will not work on Windows. But instead of installing everything as an operating system, you can try to install the git bash which comes along with the git download. Now, I can use it on Windows and run all the basic Linux commands, so that I am going to have a feel of running the Git as if I am running on a Linux machine. So without installing Git on a Linux machine, by installing Git on Windows and using this git bash, I can pretty much run all the Git commands, and I can also run all the basic Linux commands. So pretty much in my class, I'm going to use completely this command prompt, that is git bash. The reason behind that is certain operations like creating a file, deleting a file, or moving or editing a file will be very easy in this bash command prompt, because we have a lot of Linux commands which can help us to do those activity easily, just like how you're going to do in the production. Because in Windows, if you have to create a file, first you will say right click and create a notepad, or if you want to edit a file, you will use an editor. Those kind of things has to happen. But since we are going to focus completely on the command line way, I'm going to use this bash command prompt given by Git, which is going to help me to have a complete Linux environment with all the basic commands of Linux will be working on this. Okay, so that's the advantage where I'm going to make use of this git bash on Windows. So I'm going to have all the basic Linux features that I want to run from Windows. I can get it using this. So I can use this to run some Linux commands. It is not that I have to use it only for running some Git commands. You can run it treating similar to a bash environment, how you would have been connected to a Linux operating system. Okay. So the first thing that we have to do is, once you have installed, we have to do certain configuration. So what are the configurations that we have to do? Now, before doing it, one thing what you need to understand is, going forward, if you want to invoke Git, you will always be calling a command or a executable called Git. So through which we will be able to perform all the operation. So that is when, to make sure that you have installed Git properly, just run git ---- version. That should give you the result of what version of Git that you have installed and you're using. So that way, now any command that I'm going to run will first invoke the Git executable, and followed by that whatever command that I'm going to use. And it is going to be a straightforward way where the name will be quite easy in the operation what it is going to do. So for example, if I'm trying to do the configuration, then we will be using a command called git config, where config is a short name given for configuration. Okay, so that way the command will be directly giving us the indication on what is the purpose, and any option that you're going to pass to this command has to be followed by a double hyphen. So a double hyphen represents you are passing a value to the command. Okay, so the first command that we are going to invoke is git config, where using the git config we are trying to do some configuration through which if we run the Git, it will be running based on what configuration that we have given. So when you're working on Git, there are primarily 3 major configurations that we have to do. Okay, so there are a couple of others, but they are not mandatory. Depending on the use case you can set, but in order to work or to get started, the primary requirement is you need to have 3 configurations. So what are those? So you need to tell on what is the name of the user on which you are working, then what is the email of the person as whom you are working. That is because when you are working in an organization, you will be given a specific user ID so that whenever you do a commit, it will be taking that user ID or the login name and create the commit ID so that if anyone wants to know, they can easily know that, hey, okay, this is the commit ID which corresponds to a person working in an organization so that they can get back to you if needed. Okay, so that is why you're going to give the username as whom you're trying to work, and then you're going to give your company's respective email ID so that if someone wants to reach you by looking at the commit ID for some purpose, they can know that, okay, when I say a commit ID, it will give me the complete details about who modified, and it will also give me the email ID so that I can get in touch with him saying that, hey, I have some doubts, can you help me in understanding, or if there's a problem, you can get in touch with that person. And then the next configuration, what you have to do is something called as push.default. Okay, now what exactly it is and why do we need, I'll explain it later when we go through a different concept, but for now just remember that you need to set a value called push.default as mandatory. So let's try to set this one by one. So first I'm going to set the value. Now if you look here, I'm going to set the username, but in addition to this, I have actually passed a argument called global. So what is the necessity of this? So now on this machine where I'm going to use Git, I can create more than one workspace and work. And every workspace will have its own repository. That is also we saw. So now if you want to have different configurations on each of the workspace, then you can set it locally. If not, the standard what we are going to do is use an option called global so that I am going to set it only once, and no matter how many workspace I am working on this machine, I will be always using the same data. So that is why we are going to give it as a global so that I don't have to keep doing the configuration again and again for every workspace that I'm going to create and work. Okay, so that is the option. The next thing what you're going to do is the user email. And in this, as I said, you will be giving your companies. Now, for your testing, it doesn't matter what you're giving because it's just a reference. Okay, so once you have done, the third thing what you're going to do is push.default. And the value for this, you're going to keep it as simple. And once you have set, at any point of time, if you want to know what and all are the configurations that you have set for Git in this machine, then simply say git config and list. So it is going to give you all the configuration that it has been using. And as I said, these three are the mandatory one that we have set. And pretty much other than that, we have a couple of others like what is the color of the screen or width, and those kind of things is not important for us. So that's how the most important things are these three. So once you have done this thing, we are pretty much ready to work on Git on this machine using this Git bash. Okay. So to get started, what is that we have to do? Now in Git, everything is a workspace. And then every workspace is a repository. So that is when, as a best practice, now, if you want to create something, first, let's create the central workspace, because you will always create the central workspace, and with respect to that, you will be allowing the users to do some change, right? I'll talk about it, Mujahid. As I said, in order to understand what is that push.simple, we'll first have to understand the workflow, and then I will try to talk about what exactly that push.default does. Okay, so that's what I'm trying to do first. So before that, first we have to create the workspace or the repository. Now, when I refer to workspace or repository, it is one and the same because both of them are present in the same directory. So when you actually go to a company and you want to work, you will create a workspace that will be your user workspace, but you cannot always create from scratch. So you will be actually taking a copy of something which is existing, and top of that you are going to do some changes. So that way, now if you want to create a copy of a workspace, you will be taking a copy of the central workspace only, because this is going to act as a common workspace where everyone will store their changes. So as a practice, the first thing what we will do is we will create the central workspace first. And note it down, it is only a one-time activity when you are creating a new repository for a product. You will not be doing this always. Okay, so the first thing what we will do is we will create a central workspace or a central repository, and from that we will create a local workspace or a user workspace. Okay, so to create a repository or to create a workspace, so that's when I said a repository or a workspace, both are going to be pointing to the same thing. So in Git, we have actually two types of repositories. So what are the two types of repositories that we have in Git? So one is called as a bare repository and the other one is called as a non-bare repository. What is the difference between a bare repository and a non-bare repository? So to understand it, first let us go back to the same diagram what I was trying to show you here. And now here if you see, this is also a workspace, this is also a workspace, but the difference is this is a central workspace whereas this is a local workspace. And if you look at this, I have clearly mentioned that a central workspace is a workspace where you are going to use it only for storing and sharing. You cannot do any modification in this, right? As well as the user workspace or the local workspace, you can store and share, but top of that you can do the modification. So that is how, if you are creating a repository which is going to be treated as a central workspace, then we call it as a bare repository. So a bare repository simply means you are using it only for storing and sharing. Okay, so where will that be present? So pretty much a bare repository will be present inside your central workspace, or a central repository is what we refer as a bare repository. And this is going to be acting as a central workspace or a repository which will be used by different people to create their workspace. And remember, you cannot do any changes in it directly. And what is the non-bare repository? So if you go back, non-bare repositories are the user repositories or the user workspace, and inside the user workspace you are going to have a repository, right? So that repository where a user can modify the change and store the change is what we call it as a non-bare. Simply, all the user workspaces or the local workspaces which is used by users will be of the type non-bare. Okay, so that's the simple thing that you have to think, that every user who creates his workspace will be of the type non-bare because he can do the modification in it as well as store the change. Whereas if you go to the central repository, it is used purely for storing and sharing. You cannot do any changes in it directly. Hence, it is going to be acting as a bare repository. All right. So in order to set up our infrastructure or to set up the project, the first thing what we will do is we will create a bare repository. And from that bare repository, we will try to create our workspace, do the changes, and then put the changes back to the central repository, and we will try to work on in multiple user concepts. Okay, so the first thing that we have to do is create a bare repository. So for doing it, you will be using a command called init, which represents that you are initializing a repository, and for that you will be passing an option called bare, so that the repository that you are creating should be of the type bare. If you do not pass, then it will be creating a non-bare repository. So as a standard, we are not interested in it because we are first going to create the central repository of the type bare, and from that we will allow the users to create a copy and not create a new repository, but a copy of that repository. Okay, so this is what the first thing that we are going to do. So before that, what I'm going to do now is I'm going to create a folder in my machine. Okay, so this is just a folder that I'm creating it for my reference, because all the Git related workspace I'm going to store inside this directory, so that any point of time if I want to view something, I know that it is going to be present inside my directory called cvisva git. So pretty much if you see, it is a Windows machine which I'm accessing through the Git bash. So if you go to your C drive, okay, so you will have the Git. So this is the same thing what I'm trying to access it here. Okay, in this, now when you're trying to create a central repository, first thing is you have to create a directory for it. And while creating a directory, now you can use any naming convention, but for our simplification on understanding, I'm going to name it as central, so that we know that it is a central repository or a directory. But make sure when you are trying to create a directory which is used for the central repository purpose, then always end the name of the directory with .git. So that is how, if you look at a directory, you can know that if it is ending with .git, then it is not a normal directory, but it is a central directory, or it is a bare type repository, is what we will be easily knowing. So how can you simply differentiate between a bare repository and a non-bare repository is by the naming convention. So all the workspaces which is going to have a bare repository will end with the name .git, and all the user workspaces will not have any .git. Okay, so once you have created your folder which is going to be acting as our central repository, now inside this you will run the command called git init bare. Okay, so now you can see that it is saying that it is going to initialize, or pretty much it has initialized, an empty repository inside this directory. So going forward, this directory is what going to be acting as our central repository of the type bare, and I cannot do any changes in it directly. I can use it only for storing and sharing. Now let's come out of it. So on this Git directory, I'm just storing all these things. Okay, so now all the other workspaces that I'm going to create, I'll be putting here itself. Whereas in your production, you can have the central repository in some other directory or some other machine, and you can create your local workspace in some other machine. So it is not dependent. Now, how is that you are going to create a user workspace? Because now I am not supposed to do anything on this directly, right? So as a user, if you're trying to work, for every product, there will be one central repository. From that, you will create your copy of the local workspace. So that way, in order to create a local repository or a non-bare repository, you will use the command called git clone. And for this, you will give the option of what is the name of the central repository or the remote repository. Once again, another name what we are going to use for a central repository is remote repository. The reason behind that is, in production or in your organization, you will not be keeping everything in one directory. For our example, when you practice, we are going to do it. But in organization, your machine is separate, and where you are going to keep all the central repository will be in some other machine. That is why we are going to call it as a remote repository. Okay. So the first thing that you will say is your remote repository name and what is the name of your local workspace or the repository which you are going to create a copy based on the central repository. Okay, so that way, now first remember to come out of it, not to run anything inside, because if you do anything inside, it is going to give you an error. So you have to come back to some other directory or to the parent directory and then run git clone, and I will say the central repository. So when I'm saying central repository, you have to always give the complete path so that the Git can access this. So when I say complete path, in Linux or Windows, we have two kinds of reference to a directory. One is absolute, the other one is relative. So absolute means you will always refer to that directory from the beginning. If not, you can always refer it from the current directory. So once again, for those who doesn't understand the difference, please go through the Linux essentials what we have shared, and you will get the clarification on what I'm trying to say. So now the two ways of referring this is either I can say it like this, okay, or I can also say git clone central. The difference is we are already inside this directory, so I don't have to specify the complete path. So this way of referring is what we call it as relative. But let's say you are running this command from some other directory, then it won't know exactly where is this. So you have to give the complete path. So depending on where your central repository is located, you have to use the path. If it is on some other machine, then you will be using the complete location on that machine to use it. So that we will see it later, but for now let's understand on how to create the workspace. So this is the central workspace from which I want to create a copy, and what is the name of the workspace that I want to create is what I'm going to give here. So what Git is going to do is, as the name says clone, it is going to create a copy of this workspace into this workspace, and inside it you have a repository, right? That is also going to get copied as a replica into this. Okay, so that is what we are going to do. It shouldn't be taking longer time, but it's just that some problem with my machine. But if not, if you look, actually this is an empty repository. So now if you go inside this, you can see that this is also an empty repository because you are trying to create a copy or a clone of this empty repository. So now you have one more workspace and there is no .git. It represents that you are trying to work on a non-bare repository. And inside a non-bare repository, I can basically do the changes and see the changes and store it. So right now, you can see there is no content in it. So here, you can see the same thing. I have a new workspace created and there is nothing inside it. Okay. So what is that we did? Now we created a clone of a workspace so that we have our local workspace, and in that we are going to do the changes. Okay, and remember, you are going to have the repository inside this also. Okay, so the first thing what we will do is let's do some change or create a file and store it, because as of now we do not have anything in it. Okay, so to get started, the first thing that we will do is we will try to create a file. So I'll simply use a Unix command or a Linux command called touch to create a file. Okay, so what touch will do, it will just create a dummy file. And this is the reason why I am using a git bash. If I'm doing all those things on a Windows command prompt, I'll not be able to run this command. So basically I have to go inside this directory and then right click and create a file. So instead of doing all those things, I'm just trying to make use of the git bash to run the Linux commands to simplify our task. Okay, so we have a file created. Okay, now if you run the command called git status, it is going to clearly say that this file is not tracked. It is because, going back to the basics that we saw some time back, any file that you are trying to create freshly, there is no data or details about it inside the repository. Now, let me take this diagram once again. So in this, if you look, we do not have anything in it, right? Same way, I do not have anything inside my repository also. So this is the current status of our workspace. There is nothing. In this, I'm just trying to create a new file called 1.java. Now, does it have any information about it in the repository? Nothing. That is why the file is being called as untracked file, which means there is no previous information about this file in the repository. Okay. So once you have created the file, now I am interested in storing this into the repository. That is what as a user you want to do. So if you want to do that, now once again, in the basics we saw, I cannot directly take the file and put into the repository. So I have to go through the staging area and only then I have to do the commit. So how is that you're going to put the file from your working directory in which you are modifying the file to the staging area? So that is when we will use a command called git add, okay, where git add will take all the files that you have modified in your current directory and it will put into the staging area. Okay, so now either you can give a specific file name if you are interested to take only one file, or if you simply say dot, it is going to take all the files that you have modified in your working directory to the repository. Because in Linux or Unix, git means current directory. So actually you are inside the workspace. So in this, if you have modified many files, if you just say dot, it will try to take all the files in the working directory and put into the staging area. So pretty much now what is that we are going to do? We are going to put this and create a snapshot of it. Okay, so if I run and if you do a git status, you can see the file is not called as untracked, whereas it is being called as staged, or it is ready to commit. That means you have staged the file and taken the snapshot. Okay, so that is what we have pretty much done now. So we have taken the changes and we have put into the staging area and the snapshot has been taken internally. So the next step what we have to do is take this snapshot reference and create a commit ID. Okay, so how is that you're going to do? So let me clear the screen. So to do the commit now, we will use the command called git commit. Okay, and when you enter the git commit, whatever the changes that you have put into the staging area which has been taken as a snapshot, it will try to take that and the other details, that is the username and then the user email, and it will try to add the date and time and it will try to store it as a commit ID. Okay, so one more thing that I was saying is, once again the basics, if you are trying to do a commit, it requires 4 factors. One is snapshot, and then it requires the date and time, and then it requires who is the author on which is working, and then finally you will be giving the message on why you are doing this commit. That is another important factor that you are going to give. So when you are trying to run the commit, keep it as a mandatory practice where you will pass an option called -m and give a message on what is that you are doing and the purpose of it. So I'll say this is our first commit so that later on I can understand. So what is that we have done? Now we have basically taken the changes from here and we have created a commit ID. Okay. So I have created some kind of commit ID. So now if I go back and see the status of the file, you can see that it is going to say there is nothing to commit and your working directory is clean, which means the files are in unmodified state. The reason behind that is whatever that you had now has already been stored into the repository and it has been tracked. So that is why the file has been called as untracked, or the status of the files in the workspace is called as untracked. Okay, now let's go this once again quickly and see the practice or the workflow. First, if you have a file, last time we created, now we already have a file. So what I'm going to do is, now quickly I'm going to put a line into this by modifying it. Okay, as of now this file is an empty file, right? So quickly I'll put a line inside it. Once again, this is just a Unix command where instead of printing something on the screen, I'm redirecting it. So usually if you just say echo and something, it is going to print it on the screen. So what I'm doing is I'm trying to redirect this to this file. It's a quickly, a quick one-liner where rather than opening a file and adding a line, I'm just trying to put it. So now if you see, you will have a file 1.java which we already created, and inside that there is one line that we added new. Okay, so this time if you look at git status, it is going to say that the file has been modified. That is because Git has been started tracking this file and we have the reference of this file already. So what is the reference that the repository has? It says that you have a file and it is an empty file. So that is when you did the change on top of this empty file by adding a line, it is saying that whatever content that I have in the repository is not the same what you have, which means you have done some change on top of it. So the Git is considering that this file is modified. Okay, so once again, now once you have done the changes, what you will do, we will try to add it to the staging area. So you will say git add dot. And now if you run git status, you can see it is going to show it in a green color, where it is not saying that it is going to be adding the changes, but you are ready to commit. That means the snapshot has been taken. Then how is that you are going to commit? You are going to type git commit and give a message which is mandatory. So we will say our second commit. Okay, so we have done the changes, and now if you do a git status, it is going to say everything is clean, because whatever that you have modified, you have taken through the staging area, and we had done one more commit now, right? So because of the second commit, now we have the changes being tracked. So that is why it is going to call it as a unmodified, because whatever you have now, the content is there. So like this, no matter how many files you have, you are going to modify and Git is going to track it. Okay, so this is how you modify a file, you put into the staging area, and then you commit it. Okay, so to quickly understand that, what are the commands that we used? So the first thing is we used git init to create a repository of the type of the type bare or central. From this, if I wanted to create a local copy, I would say git clone, and I would give the name of the central repository, and then I would give the local workspace name. Correct? And then if you want to do the changes, you don't have to use any git command. It is all your operating system command. But if you want to put the changes into the repository, you will say, sorry, if you want to put the changes into the staging area, you will say git add. And then if you want to put the changes into the repository, you will give the commit message followed by a -m. And any point of time, if you want to know the status of the file, you will use git status. Okay, now we will use one more command called git log that will give us the list of commit IDs that we have in this workspace. Okay, so now if you look quickly, it is going to show you 2 commit IDs. That is, we have done the commit 2 times, and with respect to that, it should have created 2 40 long characters, which is going to give the reference of what we did and when it was done and who did it. Okay, so that is what you can see here. So now you can see that it is giving you 2 commit ID, where this is the first commit ID that we did, and corresponding to it, it is created a 40 characters, which is a unique one. And for that, who is the author that we created? What is his email? And then what is the date and timestamp on which it was committed? And then what is the message that you have given? Same way, the next commit ID, the recent one that we did, a unique 40 characters for that, the author, email, date and timestamp, and the message. So this is how for each ID or each commit that you're going to do, you're going to get a unique commit ID and it will be tracked. Okay. And now let me quickly open one more git bash prompt and let us go to the central repository. Okay. So a commit ID is not with respect to a file. Okay, so that was the next thing that I was anyhow going to say. So a commit ID in Git is a collection of a file. So it is nothing related to one file. It is a collection of files. But if you want to look on what and all are the changes that has been done by this commit ID, then you will use a command called git show and give the commit ID, where you can give the complete 40 characters or you can give the first 7 characters. Okay, so now this way it is going to give you the complete details on what exactly the snapshot of this commit ID refers to. So you can see that it is going to refer to a file called 1.java where you have actually added a new line called line 1. So that is how it is going to say that you have added one line, and what is that line? Called line 1. Okay, so that is how you can get to know on what exactly you have modified for the change. And as we go on, every commit ID will not be pertaining to one file, but you can have a collection of files or a group or a set of changes, and you can store it as one commit ID. Okay, coming back to this. So if I go to the Git repository, let me go to the central repository, and in this, if I type git log, you can see that it is going to give me a message saying that there are no commit IDs available. Why is it? So let us be more clear now. Where is that we have done the changes and all the commit has been stored? So all the commit IDs has been stored in this particular repository of the workspace. What is that workspace? This is the workspace. So as we know the basics, every workspace will have its own repository, and because of it, anything that you do to that repository will be stored and known only to that workspace. This is the very first basics that I was explaining you yesterday in this. So if you remember, I said if you create a commit ID in a particular repository, only this will be knowing. In the same way, if you do a commit and store it in this workspace in Git, only this workspace knows about it. So now, like this, a user will continue doing the changes. Okay, so once the changes has been done, the next thing what you have to do is you have to share it with others, or we have the central repository. This is where you have to permanently store so that others can take your change and modify. So that is when now you have to take the changes from your workspace, that is the repository available under this workspace, and you should be putting everything as a copy back to the central repository or the workspace which is being used as the sharing for central purpose. Okay, so how is that you are going to do? So that is when you will use a command called git push. Push means you are going to push all the commit IDs, or simply in terms of Git, we are going to push all the references that is available only in your workspace, and that which is not available in the central workspace will be taken and shared. So that now if you look here, you will be getting all the commit IDs that you had in your local workspace, which has been shared to the central repository. Okay, so that is how first you will do the changes in your local repository and keep continuing storing the changes, and whenever you feel that you have to share it with everyone, then you push it to the central repository so that now it is completely available for everyone else to use. Because when you go as an organization, there will be, let's say, 50 developers, and each developer has his own workspace. So if you are dependent on one particular file change, you don't know who is the workspace, who is the user working and what is the workspace on which he is working. So rather than that, you can always refer to the central repository. If those changes has been pushed into the central repository, you can always use this central repository and create your workspace. Okay, so that is the process. And going back to the first configuration on why did I use a configuration called push.default, it is because of this. Now, if you say git push, it automatically goes to the origin of this workspace. What do you mean by origin? Origin is nothing but the workspace or the central repository from which we created this. So I ran the git clone command. with respect to this workspace, right? So when you do a git push, it is going to automatically go to the central repository, that is the origin of this, and push everything. That is why we give that push.default as a simple way. So I don't have to give the name. Automatically it will go to the central repository, which was the origin for creating this. Okay, so like this, every user will create his own workspace and he will try to push the changes to the central repository. So now let's say a new user has to create his workspace. What he will do? So pretty much in his machine, okay, what he will do is he will once again do a git clone of the central repository, and he can give some new name for this. So what I'm going to do now is, in the same directory, I'm trying to create as if a new user is creating a new workspace. Okay, so this time I'm creating a new local workspace called new workspace 02, which is going to be a clone of central repository. But this time when we are cloning, we have already some content in the central repository, right? So everything is going to be available in our new workspace. So now a new user, whoever is creating the workspace, if he goes inside it, you can see that he's getting the complete content what you have in the central repository. So that is how, if a user is creating a workspace, he will be getting all the changes that he has in the central repository, and along with it, he will be getting the complete list of commit IDs also. Okay, so remember, this is how everyone will be creating their own workspaces and they will be doing the changes. Clear with it? So the last thing that we saw is, once you have done the changes, if you want to share it to the central repository so that others can take, you will do a git push. Okay, so let me stop it for today and we'll be going. All right, now in the last session, just to recap quickly what we saw. So we saw how is that you're going to create a repository, and in that there are two kinds of repositories that we have. One is a bare repository, the other one is a non-bare repository, where a bare repository is a central repository in which you will be able to do the changes and store the changes. Pretty much you cannot use it to modify any change. That is what we are going to do. Whereas the other type of repository that we have is a non-bare repository, which means it is the users or the local workspace in which you will be having the repository. And in this kind of repository, you will be able to see the files and modify the files. Okay, and in that, to get started, you will always do a git clone, and based on a git clone, you will be able to get a copy of the workspace, and from there you will be proceeding with doing your changes. And after you do the changes, if you have to put the changes into the staging area, the first thing that we saw last class is you will be putting into a staging area by using a command called git add. And after you have added the files to the staging area, a snapshot will be taken. And once the snapshot is taken, the next thing that you will be doing is a git commit. So where there will be a commit ID that is created, which will be a 40 long unique character, and that will be used to represent that particular changes what we have done. And once we have done the changes, at any point of time, if we wish to share it with others or with the central repository, we used something called as git push, so that from our local workspace, we try to push the changes to the central workspace or repository. So this is what we saw in the last class. So now, to continue that, let's once again create a new workspace and start it as a fresh. But this time, what I'm going to do is, now, if you remember, we created one more workspace yesterday, right? So now, once again, if there is a new user who's coming, and if he wants to create a workspace, he will do the git clone, and he will give the new name for his workspace. So let me say this as a new workspace 03. So at this point of time, whatever that you have in the central repository, you will be getting everything into this new workspace for that user as whom he's going to run the command. In our case, all the commands has been run by us, but in production, different users will be running this command for their necessity to create a workspace. So we have created a new workspace, and if you go inside it, you can see all the contents in the central repository. At that time, what you have, you will be getting a clone or a copy into your workspace. And at the same time, you will also be getting the complete commit IDs. So that is how now the first workspace that we created is exactly the same, because from here we pushed something to the central repository, and then from the central repository we created a new workspace called workspace 03. So everything are in the same set of changes. All right. So now quickly let us do some change into this. Okay. Now in this, quickly I'll create another file. Okay. And I'll call this as 2.java. Okay. And along with it, I'll also add another line to the 1.java. So here what I'm doing is I'm creating a new file called 2.java. In this existing file called 1.java, I'm adding another line, and that is what we do by 2 greater than. So 2 greater than means you are appending the existing content of the file. So now you can see there are 2 files in that. The 1.java will have 2 lines because which you have added now, whereas in the 2.java there is 1 line. Okay, but we have not yet added to the repository. So if you look at the git status, what is that you see? Now first it says 1.java is modified. That is because the repository already knows about this file called 1.java. That is why it says that it is a modified file. Whereas in our repository, we do not know anything about 2.java. So that is when we created this 2.java, there is no information about it in the repository or any commit ID corresponding to it. So Git says that it is an untracked file. So now what we have to do is we have to take these changes and put into the staging area. How you will do? You will simply say git add dot. But now when you do a dot for the git add, it will take all the changes that you have done in your workspace, that is more than 1 file, it will put into the staging area for the snapshot. So you can see now in the git status, it is showing in a green color where it clearly says this is modified and this is a new file which you have added, and both of them are ready to commit. Okay, so that is how we will be having a particular set of data being put into the staging area, and we have taken a snapshot of it. Okay, so that is how when you use git add dot, we will be trying to put both the changes or all the changes together. So that's the advantage why we use a dot here. So now both the changes whatever we have done has been put to the staging area, and this is ready for the commit. So how do I commit from here? My system is quite slow now. Sorry for that. Anyways, now if I have to do the commit, if I just simply say git commit -m, and I'll say set of changes to be committed. Okay, so what we are doing this time, we are committing a set of changes, which means more than 1 file that we have modified, and we are trying to store it. Okay, and corresponding to that, there is nothing available because whatever changes that you have done, practically we have created a new commit ID for that, and that will be available in our repository. So now if you see in our current repository, we will be having 3 commit IDs, where 2 are the old ones and the current one that we did will be the latest one. So that is how we will be having 3 commit IDs in our workspace. Okay, let it complete. So you can see that you have 3 commit IDs. But we know the concept of Git is every workspace has its own repository, correct? So whatever changes that you are doing in that workspace is known only to that workspace. In that way, this commit ID, whatever that we have created newly by adding these two modifications in 1.java and 2.java, is available only in this workspace. So to cross check, if I go to the central repository, let me go to the central repository, and in that, if you do a git log, you can see you still have the older commit ID that you pushed from the first workspace. Okay, so the new change, whatever that we did, is available only in the new workspace because there is a repository inside this itself, and because of which whatever that we are storing here, that is the commit, is first storing only in here. So now, in order for us to make it available from our local workspace to the central workspace, what is that we have to do? We have to push the changes from the local workspace to the central workspace. Okay, so now if you do a git push from this current workspace, whatever changes that is not available in the central repository, that will get updated. So in that case, what commit ID is not available in the central repository? This new one, that is E531C9, whatever that it is showing, right? That is not available, whereas other things are already available. So now, since we are doing a push, whatever the change that is not available in the central repository and that is available only in your workspace or repository will get pushed to the central repository. Okay, and hence when you use the configuration called push.default is simple, it will work here also. By default, what is the origin of this workspace? We created this from the central repository, right? So automatically it is going to push those commit IDs which are not available in the central repository, that is the origin, automatically. So it captures and it knows everything. So now if you come here and rerun the same command, you can now see that, okay, if it's not clear, this is the first time I ran. The second time when I ran, you can see it is giving all the 3 commit IDs. That is because we have now pushed the changes. Okay, so like this, every user will create his own workspace by doing a git clone, and in that we will be doing the commit. And whenever we are interested to share with others, then we will do a push so that those commit IDs will be put into the central repository so that others can take it. Okay, so this is the workflow. So what is that we did? Let me just put it up once again. So we have a central repository, okay, and then we have our local repository. So first, what is that we did? Well, let me put it up this way. Let's say this is our local workspace. Now, in this central repository, we first created an empty one, and from this, we created workspace 01. And then in this, we did 2 commits. Okay, so, and after that, what we did a push. So from here to here, we did a push. So when we did a push, what happened? These 2 commit IDs that were available here were shared to the central repository. And then from this, what did we do? We created a clone, and because of the clone, what happened? We created a new workspace called workspace 03. And in this, since it is a clone, it is also going to get the same set of changes whatever you had in the central repository. Now on top of that, we created a new commit ID, and that we did a push from here to here. So when we did a push, what happened? Whatever this new commit ID which was not available in the central repository, it got updated. Okay, so like this, every user will do the change in his workspace and then push it to the central repository. Okay, now like this, if a user wants to create a new workspace, let's say that he's creating a new workspace, then he will be getting all the commit IDs, whatever that you have in the central repository, exactly here. Okay, so that way, all the things that you have in the central repository at that point of time, you will also be getting it. But let's talk about this person, for example, where he already has a workspace. And in this, if he wants to update his workspace with the latest change what you have in the central repository, then how is that he has to do? Because if he creates a new workspace, then in that, you will be getting a clone of the central repository, so all the changes will be available. But what if on an existing workspace, if we want to take the latest change, that is this particular commit ID that we pushed to the central repository, if you want to take that, then what you will be doing is, you will be doing something called as pull, where push means from your workspace, you are trying to push some changes here. The same opposite, pull means from the central repository, whatever the commit ID you do not have in your workspace, you are going to pull it. So in this case, from this workspace, if I do a pull, what is it going to do? First, it is going to check between the central repository and your repository, is there any change which you don't have here and it is available here? So what is that commit ID? This third commit ID. So when you do a pull, what it will do is from the central repository, it will take that commit ID and it will put it here. So that is how, if you have an existing workspace in which you want to update what you have in the central repository, then you will do a pull. Okay, so remember, push means from your workspace, you are adding new changes to the central repository. The same thing, if you want to update your workspace with whatever the latest is in the central repository, you will do a git pull. Okay, so that way, now let's go to this workspace. So in this workspace, if you see, we have only 2 commit IDs and we have only 1 file, and in that file, if you see, there will be only 1 line, because that is what is corresponding to 2 commits that we did yesterday. So now, if I want the latest changes that is available in the central repository to be available in this particular workspace, then I can do a git pull. So watch it very closely. If I say git pull, by default, it is going to connect to the origin of this. So what is the origin of this? Central repository that we have used, and that it is going to take all the commit IDs and put. So first, if you look now, you're going to have 2 files, and if you look at the content, everything will be the latest. And not only that, if you look at the git log, you're going to have the latest commit ID also. So that is how, when you do a push from your workspace, it is going to update the central workspace. If you do a pull from the central workspace, it is going to update your workspace. Okay, so that is the difference. Push means from your workspace to the central workspace. Pull means from the central workspace to your workspace, the updation that happens. So this is how typically the workflow happens in the development, where first time you will do a git clone, do the changes, create a commit, and then do a push. Then if someone also has done the push, that will be updated in his repository, but it will not be updated in your local repository. So you will do a git pull so that whatever the latest is available in the central repository which has been pushed by someone else, you will be updating your workspace with that latest change. So that is how you will be doing a git pull and a push based on the necessity what you will be doing. Okay. Now, this is the regular activity that you will be doing. But let's consider a scenario where here this person is now doing some change. Okay. Now going forward, he also does some change, C4. Okay. At the same time, this guy also does some change. Let's call it as C5. Now, this guy will try to update by doing a git push. Okay. So when he does a git push, this will be available in the central repository. Okay, and now when this guy tries to do a push, it will not be updating. That is because in the central repository, you have something latest which is not available in your workspace. So that case, how will you resolve the conflict is, first, you need to do a pull so that you will get the latest C4, whatever is available there in your workspace. Okay, so now if you see, whatever is available in the central repository is also available in your local repository. And then you will do a push so that only that which is not available in the central repository that you have in your workspace is the 5th commit ID. So that will get updated here. Getting it on what is the workflow? Because every time when you're trying to do a push or a pull, your workspace should be exactly as that of the central workspace, and top of that you should have some changes. But if you are lagging behind with something, then first you have to do a pull, update your workspace with the latest change, and then try to push the latest change to the central repository. Okay, so let's try to do that quickly and see. So from this workspace, what I'll do is I'll try to create a change. So for the same file, quickly I'll try to create a file called 3.java. Okay, and then what you have to do is let's quickly add it. Okay, and then let's do a commit. Now corresponding to this, you would have got a commit ID. Okay, so it will show you a commit ID. So we have created a new commit ID called 61C013F. Same thing, what I'll do is quickly go to this new workspace, and in this I'll create a file called 4.java. Yes, Kavya, this is the process which the developer has to go through, because from a developer, he has to do the change, then he has to create a clone. After creating a clone, he has to do the change, do the commit, and push and pull. That is the standard that he has to follow. Now, once again, I will add it, and now I will commit it. Okay, so corresponding to this, now you would get a specific git log in this. You can see that 3.java is not available in here, whereas in this we have the 3.java, and corresponding to this a particular commit ID. Okay, so for this commit you will be getting a corresponding commit ID. So here we got something called as 20791. Okay, now what I'll do is from this workspace I will do a git push. So now what is that? It would have happened in the central repository. You can see that only this is updated, whereas from the first workspace, whatever that we added, the 3.java, you can see it is not available. So now from this, if you try to do a git push, you can say that it is giving a message because it is not allowing us. The reason behind that is we have something latest in the central repository, and that we have not updated in our workspace. So first we need to update our workspace. So here I will do a git pull, and because of that in my workspace that 4.java will be available, and then if I do a git push, it will be updating the central repository with the 3.java. Okay, so that is how you will first update your workspace and then do a push to resolve the conflict. So you can see now you have the 4.java available. So now if you do a git push, correspondingly it will do a push, and that you can see it in the central repository. Okay, so you're going to get this in the central repository. So that is how, when you want to try to do a change, first make sure your workspace is up to date with the central repository and then do a push. Okay, so this is the regular workflow on what a user will be doing. Git, commit, and then pull and push based on the need so that others can share the changes. Getting it? Okay. If you have understood, let's jump on into the next topic. So now we have used a command called git log, right? So it is one of a handy command which will be used for many purposes. Now, if you go into this, at any point of time, if you type git log, you can see that it is going to give you a list of commit IDs. Now, just in 2 days, for simple explanation, I created more than 5-6 commit IDs. But in production, if you can assume, if there are 100 developers and they are doing so many change, within a day, you will be getting like too many commit IDs. And it will not be easy for us to scroll the screen and keep seeing the output. Because when you type git log, it is going to completely give all the commit IDs which is available on your local workspace. Okay? And in that, it is going to show you in the order of latest commit ID to the old commit ID. Okay, so that is how it is going to show. So if you can look at this, it will show you that whatever the latest commit ID that you have created, from that, it will show you the last commit ID. So it is in the order of latest to oldest. So now, you can actually manipulate the output so that you can see only a particular content if needed. So what you can do for that is, for the git log command, you can pass a number. So if you pass a number by hyphen, then only those many commit IDs will be displayed rather than displaying everything. So as of now, here you have 1, 2, 3, 4, 5, 6 commit IDs, right? So now instead of seeing all these things, if you simply say -3, then it is going to display only the first 3 commit IDs. So remember, it is once again going to show from the latest to the oldest, but not everything, but the first 3 which is available on the latest list. Okay, so like this, depending on how many commit IDs that you want to see, you can show that and you can see only that. So right now it is displaying only the first 3 commit IDs and not others. So suppose if you quickly want to know what is the latest commit on which you are working, then simply say -1. So -1 will show you the current or the latest commit ID on which we are currently working. Okay, so like this, you can choose a number and it will be showing you only that many number of commit IDs in the same order of latest to the oldest. Okay, and if needed, we can also use another option called one line. As you can see, one line means it is a short form of displaying the commit IDs. So rather than giving the complete list, it will be showing you the short form of the commit with the first 7 characters and only the commit message, so that you don't have to see the author, date, and other details. So one line will be an easy option where you can see everything in a short form. And if needed, you can combine the previous option with this also. So now if I say one line -2, it will be showing only the first 2 commit IDs and the short form of that and not everything. So like that, you can play around with combination to get only the desired output on your screen rather than showing everything on the display. You can see only the particular content. So short form, you will use online. Whereas if you want to see only a particular number of commit IDs, then you will use a number. If you don't give a number, then it will display everything that is available in the commit ID and again in the same order of latest to the oldest. Okay. Now, sometimes there might be a requirement where you want to find or search for a commit ID. Now, suddenly by looking at a commit ID like this, it will not be easy for us to identify, especially when you have hundreds of commit IDs. You cannot scroll and keep finding everything. It will be difficult. So that is when there is one more option called grep. Okay, so a grep is nothing but an option where if you specify a string to it, a string or nothing but a character, and if that character or string is available in any of the commit message, then it will show all those commit messages matching it. Okay, now let me clear this. I'll show you here. Okay, now let's say I want to display all those commit IDs in which if the commit message has a word called file, then you need to display that. And I don't want to display everything in it, but display only the one line of it. So now you can see there are two commit IDs in which there is a string called file in the commit message. Since it is matching, it will give. If you don't give one line here, then it will give you the complete details about those two commit IDs. So like this, you can quickly match a string based on the message. That is why we will be giving a message, because just by the commit ID, it will not be easy for us to know what you have done. But by reading the message, I can find out and identify what is the purpose of this commit. So that is how, using the grep, you can search for a particular pattern and it will be displaying only that. Now, let's say instead of file, I'll say commit. Now, it is going to display all the changes, that is the commit IDs. In that commit ID, whichever message has a string called commit, it will try to display that. So in my case, it has to show 1, 2, and 3 commit IDs. Okay, and once again, it is going to show from the latest to the oldest order. So that's how you will make use of this git log and try to see only those commit ID of our interest. Okay, and not everything else. So it is one of the handy command where you can use. The question, if someone asks, hey, what is the latest commit ID on which you are working? Just say git log -1. And if you want the short form, then just say git log -1 line, and it will give you that latest commit ID that you can refer to. Okay. Now, jumping to the next topic. To understand this, first, let's understand the scenario where now as a user, a developer, or a test engineer, anyone, what will happen is you will be trying to write some files and trying to store it. But practically, when you have written some file, you will not directly add it to the repository. First, you will verify whether whatever you've written is getting or giving the exact output as what you needed. So every time when you're trying to write a script or some kind of program, you have to verify. That is important, because blindly if you try to commit, and if someone tries to take it, that is after the push, it will be a problem. So first, as a developer or as a user, we will have to verify it. But what happens is, whenever you try to verify a program, it will try to generate some output file or some runtime file. Now, a simple example that I can say is, let's say you are trying to do some testing against a file that you have created. It might generate a log file. A log file is nothing but it will have the complete information of what you ran, what are the output that you got from it into a file that we call it as a log file that you can refer and see at any point of time to know what happened to it. Okay, so that way you will be getting log files. Or specifically if you're talking about program, for example on the Java file, when you try to test it, you will be getting some file called as .class files. Okay, so for every Java file, when you try to test, we don't call it as a test, but we call something as a compilation step. And then you do that, you will be getting a output file called a .class file. So I'll talk about more on what is class file, what is compilation in the next module when we are dealing with the build management. That is after the development, what is that we have to do. So that I'll be focusing there. But for now, you just think when you're testing something, you will be getting some runtime file. Runtime file means while you are doing that testing, you might get some files. So those files are not actually needed for us for putting it into the repository. It is only for the runtime to get some output. So that way, let's say for example, if I do the compilation or testing of this, I'll be getting a file called one.class. Now this file, if you see, it will be available in the same directory, but it is only for my testing purpose and I don't want this to be added to the repository. Okay, but what happens is if you do a git status, this file will be called as untracked file. Why is it? It is because in our repository we don't know anything about that file. That is why all these files will be treated as untracked files. And if by mistake, if I do a git add and dot, what will happen? It will also take these files into consideration, right? Then it is a problem for me where unnecessarily I'm storing all these runtime files or the output of a test that you have done, which you don't want to store in the repository. Because when you say a repository, you should be keeping it clean in terms of keeping only the actual source code or the actual files which you need, not all the test files or runtime created files or the log files. So that way, suppose, let's say you create one more file called log.txt. That is again a runtime file. Now all these things will be considered as untracked file, and by mistake, if you do a git add dot along with some other file modification, you will also be getting this into the repository and it will add it, which we don't want to track. So such a scenario when we want to exclude some files when git is working, then we will use a concept called git ignore. Sorry. So what do you mean by ignore? Ignore means you should not consider it. So that is how when you're working on git, if you say git add, whatever is available in that workspace, it will take everything. That is what we saw from the previous session and also in the first half of the session. Now, if you do not want Git to consider some files like what we did in the class file or text file, then we can tell to Git to ignore certain files. So that can be done using a file called as .gitignore. So the concept is now on any workspace in which you want to ignore some file, then simply create a file called as gitignore, and inside that file, if you put a name of whatever files that you want to ignore, then Git will not consider those files at all. So what Git will do is every time when you perform some command like git add or git commit, it will read if there is a file called gitignore, and in that if you have given any file names, then it is going to ignore those files and proceed. So that is how, without worrying, we can try to add all those file names which we do not want to consider inside our gitignore file, and if you run the command, it will not be picking those files at all for consideration. So let's try to do the same thing here. Now in my current workspace, I will create a file called .gitignore. Okay, I'll create a file called .gitignore. Why do I put a dot? In Linux, if you put a dot in front of a file or a directory, it will be hidden for us to see. So now if you can see, this file is not visible. That is because it is a hidden file. Okay, now why is that we want to hide it? Because by mistake, if you try to delete, then the gitignore concept will be going off from this workspace. So if you do a git add by mistake, all the runtime files like this will be added. So that is how we don't want the user by mistake to delete. So simply we will hide it by putting a dot, but that file is available in this workspace. So now inside this file, I'll put some content. Okay, now I will say one.class. All right, and I'll put this into the .gitignore. So now if you see in the .gitignore file, I have one file name called .class. So if now I run git add or git status or any git command, it will not be considering this file at all. So you can see now when you run the same git status, it is not considering this file, but it is considering only the log.txt. So like this, if you keep adding as many files that you want inside this, that is the .gitignore file, then so now I have added 2 files, and now if you run a git status, you can see both the files is not considered. Okay, it is trying to take this dummy file. So now you can see it is not considering these 2 files, but it is saying that you have a new file called gitignore itself. That is because gitignore is again a file which is available in our workspace like others. The only thing is hidden. So that is why it is a best practice to add this file itself to the repository so that you have this file added to the repository, and whatever contents that it has, it will be excluding for the operation. So now if you go ahead and do a git add, and if you do a git status, at any point of time, it will not be considering any file that you have mentioned inside it. That is the class file, one.class and the log.txt. Okay. So now you can have the file, but still it will not be considering it. Now, if you add any new file, for example, this will be considered. That is because in your gitignore file, you have mentioned only these 2 files. So if you do not want to add this also or consider for ignoring, then the other best practice what we can follow is simply, rather than giving the file name, what you can do is you can give a pattern that is going to be matching. Now simply if I say star here, so what this means is any file which is going to end with .class. So star means any pattern or any string that you can have. So I can have it as one.class, two.class, three.class, test.class, whatever it is. If the file name ends with .class, then don't consider. The same way here also, I can simply say it as star.txt, so that now any file which is ending with txt should not be considered, and at the same time any class file or any file which is ending with .class will not be considered. Okay, so if you do a git status, it will not be showing the 2.class at all, and even if you create 3.class also, it is not going to show. But it is showing, the reason here is you already have a gitignore file added to the repository, right? Because of this, it says it is modified. So simply if you do git add, it will be taking only that into consideration, and it will not consider any of the class files or any of the text files that you're going to create. No matter how many text files you create, it will never consider that. Okay, so now you can go ahead and do a commit. Getting it? So this is how, when a user tries to run some files for testing, he might get an output. So make sure if you want to ignore certain files where Git should not be considering for any kind of operation, then simply use the name and put it inside the gitignore. And the best practice is don't give the full name of the file, but give the pattern matching so that if you have similar kind of files, everything will be excluded. And then the best practice is to commit this file itself into the repository. Getting it? So now if you see, we have done couple of changes, right? So now I have to do a git push so that if anyone else wants this to be taken, then they can do a git pull from their workspace, or if they create a new git clone, all those things which is available in the central repository, they will be getting it. Okay. Clear so far on what exactly is a git ignore and why do we need it?
సర్లే అయితే జాగ్రత్త ఓకే ఏదో ఇచ్చేయండి ఇంకా వాళ్ళు ఆ డాక్టర్లు చెప్పినట్టు ఫాలో అవుతానండి ఆ టాబ్లెట్స్ వాడడం అదంతా చూస్తాను కరెక్ట్ చెప్పండి చూస్తాను పాసిబిలిటీ ఉంటే అదే నాకు కొంచెం కడపలో పని ఉంది చూస్తాను నేను
Okay, this is the reason I keep muting it. So guys, if you don't have a question, it's better to mute. If not, I have to keep everyone on mute and you have to use only the chat. Yeah, Vinay. So if you add a file by accident and the git ignore is only for new files, yeah. So we'll see about that. How is that you are going to undo a change, whatever that you do? I'll be talking about it in the later sessions. But for now, try to understand if you have any file that you want to ignore and that you know already, then pretty much go ahead and put it into the git ignore file. So that is the first concept I want you to understand. So I hope this is clear for everyone. So let's move to the next concept called branching. Okay. Now, what exactly is a branching? So before we get into the details about how to create a branch and all those things, first we need to understand what is branching and why is it needed, especially in Git, and how is that we are going to use. So ideally, when you talk about a workspace like this, okay, what is that we did now? We had a working directory in which we modified the files, and then we tried to put the changes into the staging area and we did a commit, right? So that is what we were doing so far. Now, to just make it clear, I'll just change it. So let's call it as C1, C2, C3. So this is what we had, correct? Now, what exactly happens here in the workspace is it gets added into the repository. But now, let's talk about a scenario where this is a product workspace where a user is trying to do some change for a particular release. Now, when I say a release, now let's consider you are working for a mobile app. That means the product that you are trying to create is a mobile application. And for that mobile application, you are using this workspace or a repository where all the files which is needed for creating an app, you are trying to produce it inside this workspace and storing it. Now let's say the mobile app that you are trying to create was first initially planned to release for Android-based mobiles. Okay, so your aim is to create a mobile app for Android mobiles. Okay, that is as simple as that. Now, the company says that I want you to do the release for the same product also on other mobiles like a Windows-based or an Apple. Then what is that you're going to do? Now, are you going to create another product? No, pretty much it is the same product, right? But it has to just have little changes here and there whenever is needed so that you will actually going to put it into the release so that you can use it for a non-Android mobile. Now, for this, what we call it as a parallel release. Parallel release means it is the same product, same functionality that you are trying to create, but you are going to release it once separately for Android-based mobiles, and once again you are going to release it separately for Windows-based mobile, right? Now that way, here, both of the things has to be done parallelly, and such a kind of scenario happens a lot of time in the development because company wants to do parallel release. Now, other examples that you can have is, you will be already working on a product. Now for that product, you would have already given a release. Now they will come back with some kind of problems when a customer says that, hey, I'm already using your product and there is a problem, can you help me to fix it? So what is that you are going to do for it? So that is when, along with whatever new changes that you are doing, you also have to take care about that fix. So that is when that is separately going to be given as a release, and whatever the new changes you are doing will be a separate release. So once again, you have to work on parallel releases here also. So at these kind of scenarios, if you look, it is the same product on which you are trying to work, but different kind of fixes. So in that kind of scenarios, when a developer or a user wants to work parallelly on different releases, then what is that he can do? So one thing he can do is simply he can create a complete central repository once again. So one more copy of this once again he can create, right? So instead of having like this, so let's say here you have the content of the Android based files. The same thing, what he can do is he can have one more copy and he can work it on the Windows based mobile contents. Okay, so like this, he can use it to have a central repository separately for Android based content for the same product and one more central repository. Okay, now this way he can do, but this is not an ideal solution that we will be doing, because what if I have to do one more release? Are you going to create one more copy of the central repository? But from the user perspective, it is not a big difference, but from the maintenance part, you have too many repositories, right? And also, if look at the developer, he has to create many workspaces, right? So all those things will be a problem in the maintenance as well as the developer, where he doesn't have to create so many workspaces. So instead of that, what we can do is we can use a concept called branching. So branching will help us to do parallel development. Okay, so that is the first thing that you need to keep in your mind. Branching means for the same product, if you want to do different releases with just some small changes in the content of the product, you are going to do the release and everything is one product, one repository. So how is that you are going to work? Okay, now in order to address this, let's understand how exactly the files will be stored in the repository. Now, so far what is that I have been telling? A repository means all the files related to one product you will be storing and the respective commit IDs will be storing. Now, if you dig a little deeper into the repository, a repository is not directly going to store the commit IDs, but there will be one more container or a layer inside this particular repository, and in that you are going to store. So such a kind of layer in which you are trying to store the commit IDs in a repository is what we call it as a branch. Okay, so what does it mean now? It means when you create a repository, by default you are not storing the commit IDs directly in the repository, but you are going to create a branch or a layer, and only in that you are going to store. Okay, so no matter how many repositories we have created now, everything must and should have a branch, and only in that you are going to store everything. So a simple concept is, if you are storing anything in the repository, it is not directly in the repository, but it is going to be inside a branch. Okay, so until now, whatever commits that we have created is actually being stored in a branch. And by default, when you create a repository, you will be getting a branch. And in Git, we call that default branch as master. Okay, so if you look at all the repositories now, you can see that this commit ID is whatever that we have stored, it is actually being stored in this branch, which is the default branch on which we are trying to store everything. Okay, So remember this, a branch is the place inside your repository where exactly it gets stored. In the same way, in all the other repositories also, you can see that there is a branch available. In fact, even on your central repository, you will be having a branch. So without a branch, you cannot store the commit IDs in the repository. Okay. Now, how is that I can see what and all are the branches available in the workspace? Simply say a command called git branch. So right now you can see that there is one branch called master, which is the default branch on which we were working so far. The same thing here. You have the default branch. The same thing even on your new workspace 1. So by default, whatever commits that we were doing is actually on the default branch called master. So now, if you want to work on a parallel release for the same product, then simply create a copy of this branch and you will be getting all the content inside your repository itself, so that now you can give whatever name that you want to give for this. Let me say this as Windows. Now this I was using the example where the mobile app that you created is for Android. So you want to have one more branch that you're going to use it for Windows. So now what we can do is like this, we can create as many branches that we want within the same repository, and you can switch between the content, whatever that you want to work in this. Okay. Now let's say in this, I am going to add one more change. So like this, now I can create as many commit IDs that I want. The first thing that you need to understand is you are free to choose between what branch you want to work. And anything that you do in a particular branch will be stored only in that branch. Okay, just like how I said, if you store something in the repository, it is going to be stored only in that repository. But now we know that inside the repository, there is one more layer called branch, and we have many branches in our repository. If so, whatever that you do with respect to this branch will be stored only in this branch, and whatever that you're going to store in this will be available and visible only in this branch. So that is how a user can choose now what is the branch he wants to work, and corresponding to it, whatever files that you're going to have will be available only in that, and you can switch between it. Now to put it in a better way, let me put it in terms of file content. So now let's take the default branch. Okay, it's the same color. So in this, now let's say you have the file called 1.java and 2.java and 3.java. Now this is the default branch called master. And then if you try to create a new branch from this, then on that new branch, you will be having the entire copy of this. So let's say you call this as a test branch or a Windows branch. Now in this, if you do some changes, it will be available only in this, and it will not be known to the other branch. And how you can switch between the workspaces, until now, we were working on only the master branch. So that is why whatever the content was there on the master branch, it was visible for us in the working directory. And anything that you did the check-in, it was directly coming to the master branch. But going forward, when you have more than one branch, we have to tell to the Git on what branch you want to work. Now, let's say you are actually working by default on the master branch. And now, if you say to the Git that you want to work on the other branch called Windows branch, then what Git will do is, first, it will remove the content of the current branch which you are pointing in the working directory. So the current branch on which by default we work is on master. So that will be removed from the working directory, and then it will take the content of that particular branch which you are interested to work, and that will be visible inside your working directory. So that now it is providing the link between your working directory and that particular branch, so that if you do some change and try to put into the staging area and check in or commit, it will be directly getting stored in the Windows branch only. Okay, so once you have done the change, if you want to work on the other release or on the master branch content, if you switch the content saying to the Git that you want to now work on master, what it will do, first it will remove the current content of the working directory of whatever the previous branch it has, and then it will try to put the content of that particular branch that you want to work. So that is how at any point of time you will be able to see only the content of that particular branch in the working directory, and any changes that you do in it will be stored correspondingly only to that particular branch. Okay, so remember this. This is the concept of how branching is going to work. So if you switch, it is going to remove the content and show the content of that particular branch only in the working directory. And because of that, any changes that you do will be stored only to that branch. And once again, if you want to switch, then it will remove the content of the previous branch and it will show the content of that branch which you are interested. And correspondingly, the changes whatever you do will be stored only to that particular branch. Okay, so that is how using the same workspace a user can switch between more than one branches and he can do the parallel development easily. And this is the advantage in Git, where you are not actually doing all these things in the central repository, because going back to the basic, anything that you do in your workspace is known only to you. So you don't have to worry about doing all these things in the central repository, unlike other tools, because in other tools, if you want to create a branch, it has to be first created in the central repository and then you will try to get it a copy inside your workspace. But in Git, we have a copy of the repository, so we are completely free to do the changes and keep storing. Because let's say if I'm doing it for my testing purpose, I don't want to share it with anyone, then I will continue to keep it here itself and I don't share it anyone. So that is the advantage, where in Git you can create as many branches as you want that will be available only on your workspace unless and until you share it. Okay, so that's the advantage, where from the maintenance also it is very easy, and also for the user, he has no need to ask any administrator to create a branch. He can create the branch directly on his workspace whenever he is needed. Okay, so if that is clear, let's try to see practically on how to create a branch. Okay, so first, as I said, if you say git branch, it will try to show you the branch that is available. And by default, we know that now when you create a workspace or a repository, there will always be a default branch called master, which will come, and that is the place where we were storing so far by default. So now, to create a new branch, you just simply say git branch and the name of the branch. So now what is that I have done? On my workspace, I have created two branches. That is, one is the default and the other one is the one that I've created. So now you can see it is showing two branches available. And in that, the star represents that you are pointing to this branch currently. So that is why you are able to see the contents of all those things. So here, what did I do? I created a new branch, right? So what happens when you create a new branch? It is the same concept of what you do in a git clone. So what do you mean by a git clone? At that point of time, whatever the contents you have in the central repository, you'll be getting everything into your workspace, right? In the same way, when you actually create a branch, from where are you creating? Currently, we are working on the master branch, and in that, we have so many commit IDs, right? So on the top of the latest commit ID, you are creating a branch. So because of this, now this new branch is actually a replica of this master branch, and whatever content you had on this master branch, you will be getting inside it. Okay, so that is when the beginning. So going forward, anything that you do in this branch will be known only to this, and anything that you do here will be known only to this. Now, how it works is, so let's consider that this is our master branch, okay? And in the master branch, you have some commit IDs. Now, let's say you have some commit IDs like this. Now, this is the latest commit ID on which we are working. So from this place, we created a new branch. So what Git will do is, from this place, it will create a new branch called Windows. And in this, it is going to put a copy of entire thing, whatever that you have here. Okay. Now, because of which, whatever that you had at that location in the main branch or the master branch, it is going to come here. So that going forward, anything that you do here will be known only to this, and anything that you do will be known only to this. So that is how you can do a parallel development separately on this and this. So if you choose to work on this branch, it will be showing you only the content of this. And if you choose to work on this branch, it will show you only the content of this. And whatever changes that you're going to do will be stored only in this. Okay, so let's try to see that. Now, in Git, how is that you are going to move or switch from one branch to other branch? So that is when we will use a command called git checkout and the name of the branch. So watch very carefully. Now I have switched from my master branch to the Windows branch. And what it is going to do here, as soon as you switch, it is going to remove the content of master and show you the content of the Windows branch. But since this is the first time we have created, both of them will be the same. So that is why you can see that if I do a git branch, now the star mark will be on Windows, which represents that we are working on the Windows branch. And not only that, if you do a git log, you will be having everything that you had on the master, because Windows branch is a replica of master at a particular point of time where we created. Okay, so everything will be there in the master and Windows, same as of now. But going forward, anything that I do in Windows will be known only to this branch. Okay, so you can see we have the same 4 files. Quickly, let's try to do a change and see how it is going to work. So now I am working on the Windows branch and I'm trying to create a new file called 5.java. Okay, and all the concept is going to be the same. So let's add it to the staging area and let's commit it. And I'll give a message that adding 5.java from Windows branch. Okay, and because of this, you will be getting a commit ID. And what is that commit ID? Just remember this. It is the new commit ID that we have created, right? And now, as per the concept that we were seeing, so we have added a new file called 5.java pretty much here. And now that is available only in the Windows branch. Now, if I switch back to the master branch, first what it is going to do is remove the content of our current branch, that is Windows, and then it is going to show you only the content of the master branch. So that is how we will not be seeing the 5.java on this master branch. Okay, so once again, to switch the branch, you will say git checkout and master. That is the name of the branch. So you can see that it is switching. To cross check, you can run the git branch. It will show that the star mark is on the master, which means we are working on that. And corresponding to it, if you do a ls, you can see that it is not showing you the 5.java. And the same thing, if I do a git log online, it will not be showing you that particular commit ID, that is 86. It will be showing only until here, because this commit ID or the changes what we did is known and stored only to this Windows branch. Okay, so that is how you can continue doing the changes on each branch and you can store the commit IDs in that. Okay, so at any point of time, if I go back to the Windows, so I have switched the branch. Now you can see the content as well as you can see the commit ID coming up. Okay, so remember now, as a user, you have the freedom to choose which branch you want to work, and any changes that you do will be available only in that branch. So this is the advantage where a user can do the changes. And Now, if you look, all this thing is available only in this repository, not on other repository. So this is the workspace on which we created this branch. So if I go to any other workspace and do this, it will not be knowing, because anything that you do in that workspace is known only to that workspace and it doesn't know anything beyond it. Okay. So clear so far on what is branch and how is that you are going to actually create a branch and what is the changes that you will be doing, so that any changes that you do will be available only in that branch. Getting it? I'm just going to quickly unmute. Any questions? Is that clear with everyone so far?
Yes, sir.
Okay, that's great. So what did we see now? We saw how is that we are going to create a file, and how is that you are going to commit, and how is that you are going to create a branch, and how separately you are going to do. Now quickly, let us try to do some change on the master also and see whether it is going to be reflecting in the Windows branch. So we have the file.java here. Let me do a git checkout and the branch name. So we are back to the master and you don't have this file. In this, let me create a file called 6.java. Okay. And let me add it here. So now if I do a commit, where will this be stored? Can anyone tell me? So you have 6.java, right? So where this will be stored? Will it be available in the Windows branch? Yeah, pretty much, because now we know that we are actually pointing to the master. So in this, I created a 6.java and correspondingly that will be added into the master. Okay. And because of this, now we can see that you would have got a new commit ID called CDA. Okay. Now, if I switch the branch from master to the test or our Windows branch, you will not be seeing this, whereas you will be seeing only the content of this Windows branch. So in our case, it will be actually showing you the 5.java and you'll not be having the 6.java. So if I do a git checkout of the Windows branch, you can see that you do not have the 6.java, and corresponding to it, you will not be having the CDA commit ID at all. So that is how whatever that you do in this branch is known only to this branch, and whatever that you have done to the master branch is known only to the master branch. Okay, so like this, a developer can continue to do the changes on whatever branch he wants. Okay. Now, if that is clear, let us go back to the process. So after doing the commit, what is that we have to do? We have to pretty much now push the changes to the central repository so that others can take and work on it, right? Excuse me. So how is that you're going to do that? Now, whatever the two branches that we have created is available only in this workspace, right? So now, if I want to do a push of the changes from my workspace to the central repository, what is that you will do? Now let's say from this branch, if I do a git push, it is going to give you an error because on your central repository, you actually have only the master branch. So in fact, what happens when you do a push, if you have noted it very carefully, it is not going to push from the repository to repository. Okay, but what exactly it is going to do now is, it is actually pushing the contents from a branch in a repository to a branch in this repository. Because now I know in a repository by default, you are going to store everything only in a branch. And that way, master branch is the default one in which we are storing everything. So when you did a push, actually, it was trying to take the content from the master branch of the local workspace and push it to the master branch of the central workspace. So that is how it was working. But in our scenario, if you look here, this master branch is the only thing available in the central repository. You do not have the Windows branch. So in order to work for this, there are two kind of scenarios that we can do. But before that, let me show you how it works. Now, if I go to master branch, and if I do a git push, what it will do, it will push only the changes which is available in the master, that is not available on your central repository's master, it will push. That is the CDA, whatever commit ID that we created for 6.java, right? Only that will be available. This particular commit ID will not be available on your central repository. So if you come here and check for the git log, you can now see that it talks and knows only about 6.java. It is not saying anything about this 5.java. That is because this particular branch is available only on your in your workspace or repository, and it doesn't know anything for the central repository. So in this kind of scenarios, how is that you are going to share your change from a branch which is available on your workspace? So to understand this, first, as I said, there are two scenarios. Now let's take a scenario one where you have created the branch only for your purpose, which means not everyone is going to use the same branch, or they don't need it. Only you wanted a branch for doing some parallel development, and for that purpose, you have created it only on your workspace. So that case, now the possibility to share the changes only if you have the same branch name available on the central repository. You can push directly from the Windows branch here to the Windows branch here. But that scenario is not there. The reason is no one else wants this branch. Only you have created for your purpose. So the only thing that we can do is, in the central repository, the branch that we have is master. So anything that you want to push to the central repository has to happen only through this master branch. Right? So now what I can do is, as a solution, if anything that has to go to the central repository has to be available in the master branch, so that from my master branch, I can push it to the central repository's master branch. So how do you make sure that these changes which are available in the Windows branch is also available on the master branch? So that concept is what we call it as merge. Okay, so a merge is nothing but a concept where you will try to take the changes from one branch and put it onto the other branch. Okay, so now when I merge both these things, as the name says, what do you mean by merge? You are collaborating both of them together. So now when you are trying to do a merge, where if you say merge the contents of this branch to this branch, then whatever the commit IDs that you had here will be stored to this particular branch. Okay, so that is what we are going to do by merge. So how is that we are going to do a merge technically? Now we will use a command for that called as git merge. Okay, now watch very carefully. So in my master, I do not have the 5.java, or corresponding to it, I do not have the commit ID, whatever we have it in the Windows, right? So now let us try to do a merge. So to do the merge, we will use a command called git merge. Okay, and for that, the merge will take two options. So the git merge will take two options. The first is, what is the source branch from which you want to take the content? Okay, and to which branch you want to put the content. So that way, the source and the destination. Okay, so what is the source? My Windows branch. And what is my destination? My current branch, that is master. So now if you do, whatever the commit IDs which is not available here, it will take from the Windows branch and put into the master branch. Okay. Now, when you are trying to put it into the master branch, once again, the basic concept comes here that anything that you are trying to do on that repository, you have to create a new commit ID, right? So when you are trying to do a merge, practically, it will create one more commit ID, and with that reference, it will be storing the new changes which you have merged from this branch to this branch. It is not like blindly it will take this commit ID and put it, because Git is going to track everything. How it is going to track? Using a commit ID. Now, you are actually doing a change. May not be directly from the file, but internally from the branch to branch inside the repository. So that is how any change that you're going to do in Git has to be tracked using commit ID. So internally, the merge will create a new commit ID and it will be put on top of the new commit ID that you are getting from the Windows branch to the master branch. So if you put an enter, you can see now it will be actually doing a merge and it will be asking us a commit message. Because once again, the basics of commit. When you do a commit, I used to give an option called -m and a message, right? That is because you are by default giving a message when you are doing a commit ID. But now, when I'm doing a merge, internally, it is actually trying to call the git commit, and for that, we have not given any message. So it is going to open up a file and ask what is the message that you want to use. By default, it is showing it as merge branch. So let me continue to have it. So how will I close a file in Unix or Linux? Since internally it will be using an editor called vim. Now pretty much these things will be covered in the scripting in deeply. For now, you just press escape, that is the escape keyword, and then press colon keyboard and then followed by WQ. So this will try to save the content and come out of this. That means you are proceeding with the commit. So now if you look, you would have got the file.java as well as if you do a git log, in addition to this, you would have got the commit ID which you have created for adding this file as well as this commit through which you have actually merged. So you will be getting additionally 2 commit IDs into this. Okay, so you can see now you have got this commit ID which we didn't have so far. On top of that, it has created a new commit ID to track that we have merged this. Okay, so now all those things that we need on the master branch that we had on the Windows branch is available on the master. Okay, so now from this, if you do a git push, it is going to directly connect to the central repository's master branch. And now if you try to do a git log, you can see that it is going to get all the commit IDs here. Okay, so this is the first scenario where you do not want everyone to create the same branch. If you have created a branch only for your testing purpose, then what you're going to do is do a merge whenever is needed, so that from one branch it will take the content to the other branch, and then you will try to do a push from that default branch called master. Getting it?
Yeah, sometimes if I miss to record, at least if someone can see and let me know so that we don't miss the recording. Okay, so now one of the scenario that we saw in the last session is when you have a branch and that branch is being created only for you and no one else wants to have a workspace in which they will have a branch similar to what you have. So in that case, now, in order to share the changes from your workspace in the particular branch that you have created, first, we will try to merge it to the master branch, and from the master branch, we will try to push it to the central repository. So that is the first scenario that we saw. Now, suppose on the other scenario where the branch on which you have created, that is the parallel release branch, everyone is working on it, or there are a couple of others who are also interested to work on the same branch. So then what is that we have to do is, now first we have to make sure that this particular branch is being available in the central repository. So that is how, if we want, I can directly choose to push from the particular branch to the central repository. And if someone is trying to create a workspace, a clone, then he will also be getting all these branches into their workspace. So how is that you're going to share your particular branch that you had in your workspace? Now, to do that, all you have to do is now simply just say git push -u -all. So until now, what is that we were doing? A push means from your workspace on the default master branch, whatever that you had, you were pushing it to the default master branch on the central workspace. So that is what exactly push was happening. So now, if you say push -u -all, -u means consider everything in your repository. So along with this master branch, it is also going to consider one more branch that you have. And in that branch also, whatever you have, everything together from the repository of your workspace, it will be pushing it to the central repository. Okay, so to do that, first let's cross check. I'll go to the central repository. And here, if I do a git branch, I'll not be having it. So now, if you simply do a git push -u -all, then along with the master branch, whatever other branches that you have, that means the entire repository content, you're trying to store it to the central repository. So that's how now, whatever the Windows release branch that we have created, now it will be available in the central repository. And anyone else who wants to work on that, they can go ahead and work on it. Okay, so here, if you look, you can see that that branch is also available. Now, when I say the branch is available, obviously, it is not just the branch, but inside the branch, whatever you have, the contents, that is the commit ID, will also be coming into the central repository. So that's where the second scenario on which everyone wants to work on the same branch. So going forward, if anyone now is trying to create a workspace that is the clone of the central repository, at that point of time, whatever he has, he will be getting. So that way, the new workspace, the user will also be getting the Windows branch in addition with the master branch. Let me open up one more command prompt and we'll see in it. Anyway, I think it's okay. Okay, so here, now to cross check on the here, if you see on the other workspaces, you do not have. So now let's create a new clone. So I'll say git clone central and new workspace 04. Okay, and in this, if you go now, okay, and if you do a git branch, whatever the contents I had in the central repository should be available here, right? So if I do a git branch, how many branches that I will be seeing here? right? But it will not be showing. Now, what is exactly happening? Now, if you do a clone, whatever is available in the central repository should come to your local workspace or the repository. But why is it not showing the other branch? Now, to understand it, the concept that you have to understand is, now from your workspace, that is the clone of the central workspace, Git has actually created. And now the repository on which you are working, you are currently pointing to the master branch as default. That is why it is showing only that. Whereas the other branches that whatever you have is also available in your repository. But unless and until you switch to that particular branch for the first time, it will not be appearing. Okay, so to understand it, instead of just saying git branch, if you just say -a, it clearly says that as of now, how is that I am pointing to master branch? That is because by default, this is the branch in which the contents will be viewed. And that is why whatever the contents you have in the master, you are seeing it in the working directory. But the other branch that we have is available, but unless and until you don't switch to it, it will not be physically appearing it on your repository. So that is why it is saying that the other branch that we have is still pointing as a reference to the original, that is the central repository. So from this, it has created a reference and it has put it inside your workspace. So as of now, for the Windows branch, the reference is still available. But as soon as you do a checkout to that, then the complete copy of the Windows branch or this particular branch from the central repository, it will try to put it inside your workspace. So if you simply say git checkout and the other branch, so now physically what it is doing is it has removing the reference and it is creating a new branch under your workspace. So now if you do a git branch, you can see both of them are available. So it is only for the first time. What exactly Git does is it will be creating a clone. Clone means it is an exact replica of this. So unless and until you go inside it, it will be still pointing as a reference. But as soon as you go inside it and start using, then in order to view it, you have to have a copy of that completely inside the workspace. So that is how it will create a complete copy only if you switch to it. So make sure that as soon as you go inside the particular workspace, just try to do a checkout of that, then everything will be available. But until then, it will be just pointing as a reference from your central repository. Okay, so this is the second scenario where you will be interested to create the same branch across different workspaces. So now all the users, if needed, they can work on the master branch, or if they are interested, they can work on the Windows branch. So they can switch and they can do the changes and they can do the push from here specifically. So the workflow is going to be the same thing. Okay, so that is the other scenario when you want all the users to have the same branch and they should also be working on the same release branch for parallel development. Okay. Now, in this, there is one more concept that we need to know is, let's go back to the merge. Now, if you see what exactly is merge, let's try to recall. So merge means whatever I had in the source branch and that which I don't have in the other destination branch, it will try to take from here and it will put inside this. Correct? That way, when you are trying to merge from one branch to other branch, by default, it will take all the commit IDs, whatever is available in the source and whatever is not available in the destination, it will put everything. Now, let's say you created some 3 files in it, and for that 3 files, you created 3 commit IDs. So when you do a merge, what will happen is all those 3 commit IDs will be taken at one shot for the merge and it will be put inside the destination branch. So be clear in this. When you say merge, whatever commit IDs that is not available on your destination, that is available on your source, everything will be taken and at one shot,
all of them will be stored inside this. So that is how when you have more than one commit IDs, when you do a merge, everything will be merged to the destination. So in our example, when we did the merge, if the Windows branch had more than one commit ID, everything will be taken and it will be trying to put it into the master at one shot. So that is the normal behavior of the merge. But if you look, the purpose of doing a commit ID first in your repository and then doing a push to the central repository is you should have the freedom. But now, let's say a developer first did a commit and he did it by mistake, and on top of that he fixes and he gives one more new commit ID. Okay, so that the latest commit ID has all the fix. Now by mistake, if you do a push, what will happen? It will take every commit ID, all the commit IDs. Same way, if he tries to merge from here, both the commit ID that he first created, which is going to have the problem, and the latest commit ID, both are going to be merged into the destination, right? So in this scenario, now at any point of time, if we have to merge only one commit ID, like you are choosing which commit ID that you want to merge, then you will not be using the merge command. So instead of the merge, we will be using a command called cherry pick. Okay, so the difference between merge and cherry pick is, for the git merge, if you give a source branch and the destination branch, then whatever commit IDs that you have in the source branch that is not available in the destination branch, it will take everything in one shot, it will try to put it. Okay. Now, instead of the regular merge, if you go with cherry pick, then in the cherry pick, you will have to specify what is the particular commit ID that you are interested to merge. So that way, instead of taking all the commit IDs which is not available in the destination branch, you will specify only those commit ID which is of your interest. Okay. So now here, this is the source that you are telling to take from a particular branch, but what is the destination? So if you do not give a destination, then by default, it will be taking as the current branch on which you are running. Okay, so that is how the merge or the cherry pick takes the destination as the current branch on which you are working. So like that, now if needed, you can do a merge completely, or you can specify only a particular commit ID and do the merge. Okay. Now let's try doing it. So let's say I'll first go to the Windows branch, and in this, let's quickly create a file called 6.java. Okay, and we'll add it and commit. And corresponding to this, you would have got a new commit ID. Okay, now we have one commit ID. Now let me create another file. I'll create another file, and in this, what I'll do is, let me try to put some content. For example, line 1, and I'll say Windows branch. So what I'm doing is I'm just creating a file called 7.java and I'm trying to put a line into it. Now let's add this again. Commit it. And corresponding to this,
you would now have got one more commit ID. Okay, so now we can see these two commit IDs are newly created. Now let's go to the master branch. Okay, now in the master branch, you will not be having these two. So let's see that. So I don't have these commit IDs. Now from this, I'll try to do git cherry pick. Okay, and then I will give a commit ID. Now let's say I want only this. Okay, now before that, you can see, okay, master also has a 6.java. Fine, then let me try to do a commit of only this. So I'll say git cherry pick, and I will try to give the commit ID, where this commit ID corresponds to what? Only this file called 7.java. Okay, I'm not interested to take this 6cdde. Okay, and now for this, I'm not giving a destination branch. So by default, the current branch on which we are working will be taken as the destination. So this commit ID from the particular branch in which it is created, that is on the Windows branch, it will be trying to merge to the current branch, that is the master, as the destination. Okay, so you can see we got the file, and let's try to do the git log. Okay, now can you look here? I'm just comparing these two. So earlier, this was the commit ID that we had.
Hello, Adam. To interrupt you, could you please tell me that why we use the cherry pick option?
That is what I'm trying to show. So now, when we did the cherry pick, it is actually a merge, but we are not merging everything from the source, but instead we are merging only a particular commit ID. So that is how, if you see now, after this, we have merged only one commit ID, and we have not merged everything from the source branch to the destination branch. Because if I did a merge, what will happen? By default, it will take both this commit IDs from the source branch, that is Windows branch, to the destination. That's what we did last session. That is, when you do a merge from one branch to other branch, whatever the commit ID that is not available here, everything will be taken at one shot. But instead of taking it, if you want only a particular commit to be merged, then you will use a cherry pick. Cherry pick means don't merge everything, pick only a commit ID of your interest. So that is how now we did the cherry pick of only this. That is why after this commit ID, it has merged only this commit ID. It has not considered this. Whereas instead of the cherry pick, if I had told a git merge, then it would have taken both. That is the difference between git merge and cherry pick. Cherry pick means pick only a particular commit and merge. And the regular merge is, by default, it will take all the commit IDs which is not there and it will merge.
Okay. Okay. And one more thing. And if whenever we are merging entire thing from one branch to another branch, if the both branches are having the same files, then what would you do?
I'll come to
like
that.
will it okay, that would be fine. Thank you.
So is it clear on what is a regular merge and what is a cherry pick? So now the developers have the flexibility where they can store as many commits they want in their workspace or in their branch, and they can choose which one particularly you want to merge, and then they can try to push only that. So that's the advantage, where now they can choose
whether everything to merge or only a particular commit ID to be merged. Okay, getting it? All right. So now we saw that depending on the need for a user, he will be trying to work on a parallel branch, which could be used for a release, or he can create his own branch now. Let's say I want to do some testing, then I can create another branch rather than storing everything on the master. I can create one more branch, do the changes in it, and then use cherry pick or merge to exactly merge those changes or all the changes from the test branch to the master, so that we can push either from our release branch, that is the parallel release, or directly on our master branch. So as the question came up, now many times when you say the parallel release, the contents and the files will be almost same, other than certain features are going to be changing. So that is when there will be a set of files which will be common for both the branches. So what will happen if the same file has modifications? Now in case if you don't have a file in one branch and you're trying to merge, then it is clear that you don't have, so let me merge. But if we have a problem where the same file had to be modified for both the branches, so let's say for both the release you had to modify a same set of files, then the content in one of the file will be different and the content from the other file will be different. So that is when you will be getting a merge conflict. Okay, so conflict is nothing but Git doesn't know how to resolve, because there will be a file on both the branch and both the branch has its own content, and when you say to merge, whether you should be taking the content of this branch or the other branch, the Git will not be knowing. So that is when we have to resolve the merge conflicts manually. Okay, so to do it, let's try to first create a scenario for the conflict. So now we have this file, right? Now quickly, if you look at this 7.java, you have this line called what? Line 1 Windows branch. I'll try to change this, and I'll try to change from the Windows to master. Okay, so now the 7.java which I have in the master branch has a content called line 1 master. Okay, this is what we have. And if I want, I'll add one more line to it. Okay, now I'll say second line is line 2. So this is what the content I have. So 2 lines in which first line says master branch and second line is just empty. Now let's do a git add. Okay, so we have committed, and corresponding to it, we would have got a commit ID. Now let's go to the other branch and let's open this file. Now in this, if you see, the content is Windows branch, okay, whereas in the previous one it was master branch. In this, let me add another line called line 2 in this. Okay, so this is the content what I have. Okay, now here let me add it. Okay, so now if you look, we have a content from the Windows branch on the file called 7.java is this. The same thing if you go to the master and if you see the content, it is little different, where the first line is different here, the first line is different, And in fact, the second line also is different because I have put I in small here, but I have put I in caps. And the second thing, there is a colon here, there is not a colon here. So pretty much now the file is same, but the contents is different in lines. So now any point of time, if you're trying to do a merge from your source branch or the destination branch or a cherry pick, pretty much, now it will be a conflict that it will be showing. So let's try to do a merge. So I'll say git merge the source branch and the destination. Suppose if I don't give the destination, then your current branch on which you are working will be the destination. So it clearly says that now there is a conflict on this particular file. Okay, so how is that it is going to show the conflict? If you open the file, it will clearly show now on each line or wherever the conflict is happening, on each of the line, it will be trying to show that what is the conflict that is happening. And in that, it is going to clearly show what is the content you are getting from the source branch and what is the content you are having in the destination branch. So how is it going to differ? So the first thing now you can see, wherever the line you have, which is having the conflict, it will be showing it in this way, separated by this line, where the one that you have on top of that is your destination branch. Okay, and the one that you have below it is the source branch. So the left arrow indicates that this is the current branch on which you are trying to merge, and the greater than represents the source branch from which you are getting it. So now it is, Git doesn't know now what to do. So that is why it is trying to show it clearly like this, where we have to now choose what is the content that I want to do. Suppose if I want to replace this and keep this, or if I have to mix both of them, it is up to us to choose and then proceed. So first, to resolve, you open the file and modify the content, in which make sure first you delete all these supporting data that is giving. So these lines. Okay, now out of this, which is the one that you want to keep? Now let's say, since this is a master branch, I don't want this particular data, but I want to keep the other two lines. So I choose whatever that I want, and then I save the file. Okay, so now you can see that the content is exactly as what you want, but it has not yet committed. It has done a modification. So because of this, if you do a git status, you can see that it is saying it is a file which has not yet been added to the staging area, because we have just modified the file. So just like how you will do a normal commit, you go ahead and add it to the staging area, and then you do a commit. Okay, so like this, what Git is going to do is, on each of the file where it is having a conflict, and in each file, whatever lines that it is trying to have a conflict between the source and the destination file, then it is going to show the result in such a way that the left hand arrow mark will be representing that as the lesser than will be referring to the destination branch, whereas the right hand side or the greater than arrow represents the content from your source branch. So you have to pick and then commit with the changes what it is needed. Getting it on how do you resolve the conflict in Git? Any questions, or is it clear?
Hi Adam, this is Hari. Okay, if I want to keep the same content in that and I wanted to commit it, so shall I do that?
It is up to us. I just edited the file. So now it is up to the user who's trying to do the merge, edit the file, and what content you want to keep, you keep it, because Git is going to give you both the contents by showing it, say, hey, this is the one that I'm having in the source and this is what you are having in the destination. You go ahead and choose whatever you want to keep. So if you want to comment, you comment, you want to delete, it's up to us to
have the content and proceed further.
Okay. Okay. Fine. If I want to continue with the same content also, I can do again commit.
Yeah.
Am I right?
If that is the case, then you don't need a merge, right? So practically merge means you want to take some content. So it is up to us how to fix it. Basically, the point here is Git doesn't do the conflict resolution because it doesn't know what is that file, what content we have. So it is us who have to help Git in resolving it.
Okay. And mainly it compares the file name. Am I correct?
Yeah, for each file, it will try to check, and inside it, whatever contents you have, then it will be taking. So first is file to file, then in each file, whatever line you have the conflict, in each of the line, it will be showing it like this.
Okay.
Getting it?
Yes, sir. Yes, yes.
Others? Yeah, only the conflict will be resolved. So anything else that it could merge by itself, it is not a conflict. What do you mean by conflict? Something that Git couldn't do or Git doesn't know how to merge. That is what we will help by doing the changes manually and then going ahead with the commit. But for any other content that Git itself can resolve or Git can merge easily without a problem, it will proceed further, because before this we did two merge where there was no content which was having conflict. So that's why it was doing it automatically. But for any file where it finds a conflict, it will show the exact line in which it is trying to have the conflict. And even if it is in more than one file or in the same file, many conflicts that you have, everything will be shown clearly. Okay. So we saw how do we do the change, how do we commit it, how do we push to the central repository, how do we try to pull the changes from the central repository to update your workspace, git clone, and then we saw branching, how do you merge, cherry pick, and share things between one branch or the other branch, and then from your central repository to a particular local repository. So that is what as a developer workflow that we did. Now, there are certain...
Adam,
Yes?
Adam, say there. I have one question. Actually, we did the merges. We are resolving the conflicts manually, right?
Mm-hmm.
We have the tools also, right? That like a K3 diff and merge some of the merge tools. We can configure or we can do that.
See, by default, Git doesn't know anything to do. Now, you have the automation tools that is available. Then we have to give the intelligence on writing some script on top of that. So simply, if you use that, any external command or tool that you are going to use on top of Git, you are trying to tell it, right? So ideally, the question comes is Git doing everything? No. So we have to guide some way. So if you have an automation through which you can resolve, it is done. But pretty much when you have a conflict, many times we will not be resolving it automatically, because there will be always a problem if you miss something. You cannot always give the same logic or a particular logic on which the merge will be taken. For me, I should be interested in getting one kind of content. When you do a merge, you will be interested to have different kind of contents. Like someone said, I want to just commit the content and put it. So whatever could be the requirement, it is not easy to do a merge when you have a conflict automatically. Okay, so that's when many cases it will be solved automatically, but for other scenarios, we just have to help the Git to understand what exactly is our content and then do the commit. Okay. Now, once again, coming back to the topic. So I was talking about the developer or the user workflow. Now, other than that, as a user, while he is working on Git, there might be certain other requirements that we have to help him with. So that way, now, one of the scenario that we will be having is taking a backup. Now, let's take that you are a user, okay? And as a user, you want to write some code to fix a problem. Now, forget about branching and all those things. A simple requirement I'm saying is, there is some particular workspace or a branch in which there is a problem that you are trying to fix by writing some code. Okay, now you think of some idea and you modify some files, maybe 2 files you modify, and after modifying, before you do the commit, you go ahead and do some testing. Now, while testing, you feel that you are not getting the exact result as you wanted, and you are looking for some improvement. So that way, now what is that you will do? If you look, whatever change that you have done is not getting a result, but you are trying to focus on doing some modification to it, or you might have to create a new change or apply a new idea for it. So that way, when you want to apply a new idea, then whatever changes that you have done should not be overwritten. So practically, you have to take a backup and keep the changes, right? So point what I'm saying is, when you try to do a change, excuse me. All right, so what I was trying to say is, when you first did the change based on one idea, you modified 2 files, but now you feel you want to try it out with a different idea and you have to modify the same set of files again. But it is not guaranteed that the second idea that you are going to implement will be as good as first one. So that is how you cannot overwrite the contents what you have put in the first ideas based on that, the modified files. So what is that we will do? We will have to take a backup of the files and keep it somewhere. Now, if it is just 1 or 2 files, it's okay. But if you have more than 2 files or multiple files, then it is difficult for us to implement it. So first problem is, how is that I'm going to take a backup when you have more than 1 files? And let's consider the same situation once again, where you do the second idea and based on that you modify the files. But once again, you don't get the exact output. You feel that you want to do some changes again. So that is when you will have to once again take a backup of the second idea, all the files you have modified. So like this, if there is a scenario where you want to take a backup and the file contents should also be removed completely, so that rather than adding the content, you will be trying to do the changes freshly from the beginning. So such a kind of scenario when you want to have, then you will be using a concept or a process called as stashing or stash in Git. So when you have done a change, which could be on a single file or a multiple file, and before going into the staging area or committing it, if you feel that you want to take a backup, then you will do a git stash, where git stash does 2 things. That is, no matter how many files that you have modified, it will try to take a backup of all the files, all the modifications. And then the next thing it is going to do is, it will undo the changes from the file so that it will leave the file exactly as it was before you started doing the changes. Okay, so those 2 things will be done by the stash. What and all are they? It will try to take a backup of all the changes before you have the commit, and then it will try to undo the changes so that if you want to do a new change, you can pretty much start writing it from the scratch. Okay, so those are the 2 things that we can do using git stash. So let's try to do it. But before that, let's try to do some change and then try to do a stash. So now let's say I'll modify these 2 files. Okay, now these 2 files, there is no content. Okay, watch it very carefully. In these 2 files, 5.java and 6.java is empty. Now what I'll do is, I'll try to put a content into it. I'll say idea 1. As I said in the beginning, we are not interested in writing the code here. Okay, so the content is not a big matter to the Git tool. So we are not worried. It doesn't mean that this is the exact code you'll be writing in Java file. So whatever they want, they can write. The concept is what we are trying to see, where I've just put a content called idea1 in this 2 file. So you can see in this 5.java and 6.java, you have something called as idea1 in each one of them. Now in this, in order to do a stash, if you do a git stash, as the name says, it will be now doing 2 things. What and all it is? First, it will take a backup of both the modifications that you have done, that is before the commit. And second, it will try to undo the content from this particular files that you have modified. Okay, so it will do both the things. So let's cross check that. You can see the 6.java is empty as well as the 5.java. So it has done both the things of taking a backup as well as undoing the changes from the file. So I can see that it has done a undo of the changes, so that it has left the file exactly how we had before doing this change. Now, where exactly is the backup? So to see the backup, you have to use an option called list for the stash. Okay, let me just clear it so that you can see. So how many backups we have taken so far? There is only one backup. So with respect to that, we can see that there will be an entry that the Git will be showing. Now that backup entry that it has taken is local to the repository, and it shows that it has taken a backup and it is available here. Okay, now let's go ahead and do the change once again. And on the file, let me now add a idea2. So first time I did the idea1, and now you can see I have added a new line called idea2, and pretty much it is also not committed or added into the staging. So it is just available in our working directory. If I do a git stash again, what it will do? It will do 2 things. Take a backup of these 2 things, that is 2 files, as well as take the changes and undo it. So if you look now, you won't have the content. And if you do a git stash list, you can see that there will be 2 entries available in it. Okay, so like this, whenever you do a stash, it will undo the changes and it will take a backup. All right. Now this helps the developer or a user to solve only first half of the problem, because what is the purpose of taking a backup? So going to the requirement now, if you have done 2 changes and at some point of time, if you feel the first idea was the best idea that you have implemented, and so far the results that you got on the first idea's changes was the best one. So at any point of time, if you want to get it back, you should be able to get it back from the backup. That is why you store it as a backup, right? So in that case, now this other half of the requirement that we need to fulfill is from the backup, how is that you're going to retrieve the contents back to your workspace so that you can go ahead and do the commit based on that, because you don't have to rewrite everything. That is why we are doing a backup. So in order to understand how to take a backup, first let's understand on this particular part on how exactly it is trying to store the changes. Okay, now here, if you can see, it is actually showing us 2 lines of entry. Okay, now there is some concept called as array when you are trying to write a script or a program. Now, what do you mean by an array? An array is nothing but a variable that will be used in a program or a scripting or in your environment, which will be containing or storing more than one value. Now in this, if you look, it is not one single value or not one single backup. You have two backups, which means two values that you're trying to store. Okay, and in the programming concept, we call that as an array. Array is nothing but a group of elements that you want to store. You can store and retrieve. So what Git does is, Git internally uses the same array to store values. So now, whatever that you are seeing stash at the rate is actually a array which the Git is using to store the backup. So in this, now there are two backups or two elements. Now, what and all are they? If you look, the first one that we did was idea1, correct? And then we had one more element called idea2. So these are the two values or the elements that we have stored inside the stash. Now, when you are actually storing some value, how the Git will be storing is, it will not be storing as a regular way of storing from the left hand side to the right hand side, that is adding at the right, but instead it will be doing the reverse. That is, if you are trying to add a new value or a new backup, it will put that as the first value. So now if you look, whatever the latest one that you have put will be the first value, and the one before that will be here. Suppose if you do one more backup, let's say idea3, then you will get that as the first value, and the second one would be the one before that, and the one that you had in the very beginning will be the last. So like this, it will be trying to store the values at the beginning. Now, this is how it gets stored, but I am interested to take a backup of a particular idea, right? We will not be interested to take everything. Now, if you are interested to take only a particular backup of an idea, then from this stash array or Git array, you will choose the element which has the content. Now, for that, in the concept of array, we actually use something called as index number. Now, index number is just like how you have in your book, you refer that this page number points to this chapter. Same way, now the elements that is available in the stash will be using an index number, and the index number begins with 0 and it moves on incrementally. Okay, so whatever the first element that you have will have the index number 0, and the next one is 1 and goes on. Suppose if you add one more element to it, what will happen? It will move on like this. Okay, so this is how, if you say the 0 index of this particular stash, then it will give you this value. If you say the index of 1 for this, it will give you this. If you say the second index element, it will give you this value. Okay, like this, the last value would be the first, and it will always begin with 0. So in that case, now in our stash, how many times we have stored a backup? We have stored 2 times. So with respect to that, now if you look, there are only 2 indexes available. That will be 0 and 1, where 0 represents the latest idea that we had, and the 1 represents the one before it. So that is what it is trying to show. So now here, the 0 index that it is showing here is nothing but the backup that you have taken here, and the index of 1 is going to refer to the idea 1. So based on what exactly the backup that you want to take, you have to refer to the index. So now, if I want to get back the idea 1, which is of my interest because that was the best one that I feel, now what is the index number that I should be using here? I'm saying I want to take the idea 1. So what is the index number I should refer for the stash? Yes, 1, because the index 1 refers to the old idea that we had, because it goes on with the incrementing. So that is how we need to use this. Okay, so how is that you're going to apply? To apply, simply say git stash apply,
and give the index name in the same format what you are seeing. Okay. Now, if you look, what is that you are doing? You are doing two things. First thing is, from that particular backup, you are going to apply the changes from the git stash to your workspace. So now, after it has applied the backup, if you can see, the file content will be exactly as you had before. So it has done. Now it is saying actually there are two files modified, and in this you can see that you got back the content from your backup. So that is how you store the backup, and whenever you want, you will be applying it specifically. Okay, and for that, let's go ahead and do a commit. And before it, I have to do a git add, right? Because we haven't done it. Because when you do a apply from a stash, you are just putting it into your working directory. So from there, we know the concept is first we need to do a git add. And now both the changes will be taken together. And from this, we will do a commit. All right. So like this, you will be taking a backup at the same point of time, undoing the changes using the git stash. But if you look at the git stash list, what will happen is it will be available in the workspace as long as you keep it. So once you have done the commit, you are no more interested in the backup, because the actual backup that you want to store is what you have in the repository, right? Because repository is the one which is going to store everything as a backup and track. So you don't literally now need these two things available. So that is when, once you have done with all the changes, you can go ahead and do a git stash clear. So it will remove all the entry. So when you say apply, apply will just take the backup from the stash area and it will try to apply it inside your workspace. Okay, it will not be deleting it. So that's how, once your task has been done and you are no more interested in it, go ahead and do a stash clear. Getting it on what is a stash and how is that you will be applying it? No, it is a backup, as I said. If you want to directly see, it won't be possible. It is not feasible to look because the content that it will be storing is in a specific format. Clear with what do you mean by stash and how do you apply? Okay. Now, if that is clear, let's move on to the next one. That is reverting. Okay, now to understand that, let me come back to this. Okay, if that is clear, then let me come to this. So here, when we are working, what is that we will be doing? One more thing is, now you will be doing changes here. And once you have done the changes, the next thing what you will do, you will try to put it inside the staging area, right? And after you have put the changes to the staging area, from this, you will try to put it into the repository. That is the next thing that you will do. Now, at some point of time, let's forget about the backup. You have done some changes and you want to undo the changes. Okay. Now, before you are going into the commit, you are actually trying to do a undo. So you can face that scenario, right? You modify something, then you realize that it is not a right change that you want to actually do a commit, then you will undo the change. Now, if it is just one line, you can edit the file one line and modify. But if it is multiple lines, multiple files itself, then it is not easy for us to keep going into the file and deleting the line, or just modifying it directly. It will be a little hectic. So that is when, if you want to undo the changes what you have done before committing, then you will be using a utility, or you will be using a command called reset. So reset means you reset the content of the file what you had before the changes. Okay, so in fact now you can think like this. When you do a git stash, it is actually taking a backup and it is also doing a reset. Okay, so reset means you are trying to undo the changes whatever on the files you have done from the workspace. Okay, so that is when, before you are going into the commit. Now, some of the scenarios when you will be doing it. So one thing is, after the user who does the modification, he will be doing a testing. So while testing, he might have got some error. And that point of time, he might be interested to undo the change. Or when you go as an organization, you will always be following some development process. And in that, one of the best practice that you will be following, regardless of your whether you are a developer or a QA person or an IT person or a program manager, documentation engineer, anyone, if you are trying to do some modification, and before you roll it out to the production or before you exactly implement it, first thing you have to do is testing. And after that, get it reviewed or verified by your teammates. That is what we call it as peer review. Now, this is one of the things which the developers will be following. But as we are going into the DevOps engineering concept and automation is the major focus in the organization, everyone is going to write some kind of code and they will be trying to store it in the tool. So pretty much now, when a user has modified some files and he has to send it for review to the peers, and within the team, someone will look at the code, and if they feel that there is some change needed, they will suggest. So it is just another way of looking at the problem rather than one person's point of view. Okay, so that way, sometimes you might get a suggestion saying that, hey, whatever the changes you have done might be working only for your component, but it might be causing a big problem to the product somewhere else, like that. So that is when you might have to undo the changes what you have done. Okay, so that is the requirement. But now, if you look, the changes what we actually do, let's say that I do a new change called 3.java. I modify a new file called 3.java and I would have put here. But what if before the commit, I actually put this file into the staging area? Here, still I haven't committed, right? I could have put into the staging area. Now, at the same time, what exactly happens in the repository is when you now do a commit, the changes will be added to the repository and it will be trying to create a new commit ID. Correct? So that is the concept. But what will happen is, even before doing the commit, when you actually put it into the staging area, there will be a temporary ID created in the repository, because only through which it will be trying to refer to the snapshot what you have done. Because when you say a snapshot, it means you have done some change on top of the existing one. So the content of your file is not pointing to the latest commit ID what you are having. So that is when, as soon as you do some staging, now in the repository, it will be creating a temporary commit ID and it will be tracking it. So as soon as you do the actual commit, that will be converted into a new commit ID. Okay, so that is how, in fact, it will try to know that there is a difference between what you already had in the repository and what you have modified. So that way, now, when you look at the repository, now, if someone asks, what is the commit ID on which you are working? what will you say? You will take the first commit ID, and that is the commit ID on which you are currently working, or on top of that, we are trying to do some change. Okay, so that way now at any point of time, if you are pointing to a particular commit ID or you are working on a commit ID, then that commit ID will be called as the head of the branch. So head of the branch means a particular commit ID in which we are trying to work. Try to understand the word. In a branch, we have many commit IDs, right? Out of that, whatever commit ID that you are trying to work, that commit ID will be called as head of the branch because we are working on that. So that way, currently, we are working on the latest commit ID. So the head of our current branch on which we are working is this. So now if I do some change in this, what it will do is, so first thing, let me just put a reference so that you will understand. So 0EF, right? So currently, let's say in this master branch, we have 0EF. Okay, so this is the commit ID. Now there will be a head of the branch referred to this. Okay, now for that, let me remove it so that it will be easy to understand. So here, there will be a head of the branch reference, and this will be pointing to this particular commit ID. As soon as we do a new commit ID, it will be creating another 40 characters, and the head reference will be moving from here to the new one. That we know. But as soon as you put the file into the staging area, it will create a temporary ID. And because we have this temporary ID now, the head reference will not be pointing to this. So it will be now pointing to the temporary commit ID. Okay. Now these many things actually happen when you do the change. So now if you look, even without doing a commit, you have actually modified on all the areas of your workspace. So why is that I'm saying all these things? Because unlike in other tools, if you have modified a file and you are interested to undo it, it is not just only from the file, the content has to be undid, but you have to undo the changes from the other areas of your workspace in the Git. Okay, so that is how when you do a undo in a Git, that is if you want to do a reset, you have 3 areas in Git, and with respect to that, you have options in Git reset based on which it will be undoing from these areas. So remember, undoing means it is not just only from the file directly, whereas you have to undo it from the all 3 areas based on your interest. So to do that, now the Git reset has some option, or sometimes we also call it as a reset mode. So the 3 modes that we have in the reset is soft, mixed, and hard. What do you mean by soft mode? So if you want to do the undo of only the repository changes, that is the temporary ID should be removed and the head reference should go back to this older ID on which you were working, then you do a git reset soft. So soft mode means it will undo only from the repository. The next one is mixed mode. So when you say mixed mode, as the name says, it will be mixing both these, that is the repository and the staging. So Git will first undo the changes from your repository as well as undo the changes from the staging area also. So mixed means it will undo from both these things together. Okay. And then the last mode, that is hard mode. So when you say git reset hard mode, it will be undoing from all the 3 areas, that is from the repository, staging, as well as directly in the file. So hard mode means on all the 3 together. Okay, so to quickly understand, If you say git reset, it will undo from the repository. If you say git reset mixed, then it will undo from the repository as well as in the staging area. The same thing if you say git reset mixed, then it will undo from all the 3 areas in your workspace. So depending on your requirement, you will be choosing one of them. And in case if you do not pass any option to the git reset, by default it will be running on the mixed mode. Okay, so one of the common thing that you will be using is actually git reset hard, and you will not be using the git reset soft, because when you do a undo from the repository, we will not be able to see the content in the repository. That's why the soft mode will happen, but we will not be able to see. But the hard mode and the mixed mode we will be able to see, and the hard mode is the default one where you will be undoing from all the areas at one shot. Okay, so let's try to change and do the change and then try this. So first of all, do I have any change in my workspace? Nothing. And what is the commit ID on which we are working? So currently we are working on this particular commit ID. So now let me do some change here. Okay, so on that 6.java, I'll try to add a line. Okay. Now because of it, you can see that we have one particular change that have been done, and where exactly it is available only on our working directory. So now if I do a git add, it will be putting into the staging area. Okay, so you can see that it is showing in green color, and now it says it has to be committed. Earlier it was ready for staging, but now it says ready for commit. So that means now we have did the change here as well as put into the staging area, and because of it, automatically there will be a temporary ID created, and the commit reference, that is the head reference, will be moved from here to here. So let's try to undo it from all these 3 areas using the options. Okay, now first let me do a git reset soft. Now what it would have done, it would have undid the change and the repository, and the head reference will be back to the original commit ID. Now as I said, we will not be able to see, but at least let's check whether these 2 things are proper. First thing is, do you have the content in the file? Yes, that means it has not done anything to this. The same thing, is it still available in the staging area? If you do a git status, it is saying that it is in green color and ready to commit. That means in your staging area, it is available. So that means reset soft will try to undo the head reference only. Now, if you try to git reset in the mixed mode, what and all it is going to do? So it is going to do 2 things. First, it will undo the repository head reference, as well as it will undo the changes from your staging area. Okay, so this it will do, as well as, it will put the head reference back to this commit ID, and then it will try to remove the contents from the staging area. Okay, so now let's go and cross check. So first, let's check whether the content of the file is there. So the content is still there. That means it has not removed from the working directory, but let's check whether it is there in the staging area. So if I do a git status, you can see now it is saying that it is ready to be committed. No, it is saying it is ready to be staged, and it is showing in red color. That means the files is not available in the staging area. So that is how mixed mode is going to undo from these 2. So now, finally, if I say the reset in hard mode, then it is going to undo from all the 3 at one shot. So none of them will be available. At the same time, now you can see the head reference will be moved once again. Okay, the very first thing it is saying that the head reference is now back to this commit ID. And then do you have anything on your staging area? Nothing. As well as, do you have the content in the file? No, it is not there. Okay, so that is how in Git we have 3 modes from which you will be able to undo with respect to 3 areas that you have in your workspace. So with respect to that, you will be using the reset soft mode or mixed mode or hard mode. Okay, so whenever you have to undo from your workspace in Git, remember you have 3 areas with corresponding to it you will be doing. And the general way that you will be doing is git reset hard, so that it will undo from all the areas at one shot. Getting it on how is that you will undo the change?
Adam,
Yes.
I mean, we can revert the after pushing into my central server the changes we can.
Can you repeat it?
After pushing entire my changes into the central repository,
Mm.
we can do the undo. I mean, reverting the changes. We can or we cannot, right?
No. As I said, central repository, you cannot modify anything in the central repository. So that is why we call it as a bare repository. So only on your local workspace, which is of the type non-bare, you can modify everything. Okay, if you want to undo something, first you undo it on your local workspace, and then with respect to that, you will try to create a new change or a new commit ID, and then you push that as a new change to the central repository. So to understand this, first we will see how is that you will undo a commit, because the concept what you are saying, forget about which repository. The first thing that we need to understand is that is a change which you have already committed, right? First we should see and understand how is that you will be undoing a commit. As of now, what is that we are doing? We are trying to undo a change before we are going to the commit. So that is when you will be using this command. And specifically when you have a scenario where you have already committed, and when you want to undo a commit which you have already done, then there is a separate method that I will focus next. But before that, is this concept clear on how do you undo a change before you are going to the commit? Is that clear to everyone?
All right. So to quickly go through, in the last session, we particularly saw how do you do a stash, which is nothing but taking a backup and at the same time undoing the changes to its original content. So that's what we saw in the stash. And we also saw how do we reset. That is, before you have going to do a commit, if you feel you want to undo a change, we will be doing an undo from not one area, but correspondingly, we know that we have 3 areas, right? So based on that, we used to do the undo. So that is one from your repository, and then you will have from your staging area. And if you want to do it on all the 3, that is on your repository, staging area, as well as your working directory, then based on that, we used to use option. Now, to continue, let's take a scenario where you have not just did the changes you put into the staging area, but let's say you actually did the commit. Okay, now I was telling you that until you do the change, there will be a temporary ID that is being created, and when you do a commit, it will be actually creating a commit, right? Now, what will happen? Let's say you have done the commit and then you want to undo it. Getting the problem? That you have done the commit, okay, but then you want to undo it. So what are the common scenarios that you will be doing? So these are a very common scenarios that we will be going through when we are performing a build or when we are trying to give these changes to the QA. So let's say now at a particular point of time, if you have 10 developers, all the changes given by 10 developers will be
put to the central repository, right? So individually, let's say Vinay, you do the changes from your workspace, and then Syed does his changes from his workspace, and then Karnakar, Hari, each one of us does changes in our individual workspace, and then we'll all going to be pushing into the central repository. Yeah, that is the ideal scenario where each one of us will do the changes and will be pushing it individually. But now, when we have to give it to QA, what we will do is, at some point of time, we will try to take the latest change from the central repository, and we try to create a build out of it and then give it to the QA, so that we will be having all the changes done by 5 of us. As I said, when we have many people and all of us have submitted our change, and now when we have to give that to the QA, what will happen is we are going to accumulate all the changes, and some point of time we will be trying to create a clone from a workspace, or we will update a particular workspace so that whatever changes we have in the central repository, which has been submitted by all 5 of us, will be taken together, and from that we will be trying to create a product. Okay, so this is how every time when we want to give a product to QA for testing, we will accumulate all the changes. Then from that we create one build, or we actually create a product out of it. That is what we call it as build. And then from that we will be giving the created product or the deliverable to the QA to test. Now, what happens is, either while testing they might find an issue, or while you're trying to create a product, you might face an issue. So that step is what we call it as build. So we'll talk more about what is build in the next session or in the next topic. But the point here is, when you're trying to create a product or build a product with all the changes that you have put into the central repository, and then at that point of time, if something is failing, now we need to find out what exactly is causing the problem, and in that, whose change is causing the problem. Okay, so let's say out of 5 of us, now let's say the change that I did is causing some problem, because the change what I have done is not compatible with any one of your changes, because of which either the build or the product is not getting created, or while testing the QA might find some error. So that case, now what we can do is, instead of waiting until I give a fix or whoever is the developer who has caused the problem, because until you keep that code which has bug in it, none of the other code will be working fine, because everything will be failing on top of the same thing. So that is when the first point what we have to do is, we have to undo that particular commit which we have already done. Okay, so this is the practical scenario where every time when a build is being done and we give it to the QA as a product, if something goes wrong, we need to find out if it is a code issue, whose code is causing a issue, and then we will try to undo that change. So that way, if you have a scenario where you have a group of changes which has already been committed, and if you're interested to undo a particular change which has been committed already, then we will be using a command called git revert. Okay, so understand this. Git revert is all about undoing a commit which has been already done. Okay, be clear in it. Is it clear, or any questions on it? Any questions on it? Or I can talk deeper onto what is the scenario.
Undoing in the sense, I have committed 3 IDs, I mean 3 commits. It will undoing entire commits, or only specific whatever we have mentioned, those changes it will revert back?
Anything. That's what I'm saying. If you feel the problem that you have caused is 1 commit ID, or it could be 3 commit IDs. But ideally, if you see, you will not be considering 3 commit IDs. But whatever changes that you are doing will be top of the other one, right? So you have to find out the exact one and pick it out. Maybe if you have done 2 separate commit IDs and both of them are different and both of them are causing problems, then you have to undo both. But the scenario is, finding out a particular commit ID, and if you say that this commit ID is causing problem, then we will be using a command called revert. Okay, so that it could be a single or it could be multiple commit IDs.
Okay. Yeah.
Getting it?
But here, yeah, here Vinay is asking to how to undo in central repository changes. He is asking.
I still didn't go to that. I'm just trying to give you a scenario on when is that you will be requiring to
Okay.
change.
Okay.
Others, is it clear? Okay, so that way, now, as the question comes, okay, so who is going to do the undo? So that is one question where now we can ask the respective user who has done the changes to undo, or we can do it ourselves, wherein we, being a DevOps engineer, we are also responsible for the health of the code line too. So now, whatever workspace that we are using, in which we would have taken all the latest commit ID, and from that we are doing the build, right? So from that, we can go ahead and undo that particular commit ID. So for that, first thing that we have to do is we have to use the git revert and the specific commit ID. If you say, it will be trying to undo that change. Okay. Now, once again, when you are trying to undo a change, practically, it is not possible in Git, unlike other tools. It is because when you say a commit ID, it is a 40 characters that is set, right? Where that 40 characters is not just a random characters that it is creating, but it is actually called as a checksum value, which is nothing but it is equivalent to some data that is available in the repository. So that is how any commit that you have created cannot be changed, because Git is so powerful in security, it keeps a track of everything. But what we can do is we cannot delete the commit ID or do the changes, but on top of that, we can do one more commit. So that is when internally, if you do a revert of a commit, what it is going to do is, for a user, he might think that it is trying to remove the contents from a file which you have done a commit, and that is what you are trying to do a revert. But practically, it will be removing the content, but along with it, it will be trying to create as if you are doing a new commit. Okay, so be clear, undoing or reverting a commit itself means you are trying to undo the content of that commit, and for that change, you are going to create one more commit. Okay, so that is how revert is going to work. So from a user, the content of the file will be reverted, that is undo. But from the Git, it is not just going to leave it like that, but whatever changes that you have done, it is going to create a commit ID once again for that also, because it is going to track saying that this is the commit you did. After that, you have to, or if your interest was to tell to the Git to revert it, then you are going to undo the content from the file, but at the same time, it is going to create a new commit ID as a reference, and it will keep it. So that is how, from an administrator's perspective, we will be having the commit ID as a track on why did you undo it. You will have the details, and at the same time, from a user's perspective, if you look, the content of the file will be pointing to the previous content that he had before the commit. Okay, so that's how we'll be solving both the requirements. Now, before getting into the deep of that concept, let me first show you how do we revert it. Okay, so first, let's see whether we have any changes. Okay, we do not have any changes. And let's quickly see some latest 3 commit IDs that we have. So what I'm going to do now is, I will try to do some change in one particular file. and I'll create a commit, and then we will try to undo that commit, that is completely revert that commit and see how Git is going to behave. Okay, now we did some change and this is the commit ID that we have. Okay, and let's choose a file. Okay, let's choose 5. So in the 5.java, we have a line called idea1. So in this, let me quickly add a dummy line. Okay. So for this, let's do a git add. And now let's do a git commit. So now what would have happened for this? Pretty much we would have created a new commit ID. Okay, so for our understanding, let me not make it complicated. So let's try to do a revert of this itself. So let it first show what is the commit ID it has created. So now if you see, it has created a new commit ID. Okay. So now to understand, first we had this commit ID, right? Let me put it up this way. Okay, so we had this commit ID. At this point of time, what was the content of the 5.java? So we had only one line, correct? So this was the content of the 5.java. Now, what we did is, on top of this, we created one more commit, okay? And that commit is nothing but this one. And for this commit, what actually happened was, we added some content to the file. That is, we added one more dummy line. So this was the content of the file. Okay, so this is what we did. At least be clear in this. We first had this as the latest, and on top of this, we added one line and we created this commit ID. So that is what we did. So now, if you want to undo this commit ID, practically what it means is you are going to point the content of the file, that is 5.java, back to what you had originally. Because undoing this commit ID means what was the location or what was the content of your repository before you had created this. That is what you mean by undo, right? So that way, before creating it, we were working on this particular commit ID where we had the content of 5.java as one line in it. So in this, we added another line and created this commit ID. So that's what logically we did. So now undoing this commit literally means that you have to go to that situation where in the repository, whatever was the scenario where you never had this content in it, which means simply you have to point it to this particular location. That is the head reference of your file should be pointing to this location where whatever content that you had exactly at this point, you should be having the same thing after undoing this commit. So that is what our practical requirement is. Okay, but as I said, if you try to undo the change, Git will not just directly delete the commit ID because anything that you have put into the repository is permanently tracked. But instead, what Git will do is now on top of this, it will create a new commit ID. And in that commit ID, if you look, this new commit that it is creating will be exactly same as what you have here. Whereas it will get the content of the file like this or correspondingly whatever you changed. So this way, this commit ID is exactly equivalent to the content in the files as of this. But in terms of the logical tracking, you have obtained this by undoing some change. So that is how any point of time the reference will be present. So from a user perspective, you're going to create a new commit ID whereas the contents will be exactly the same as what you had before creating that commit. Okay, so that is how Git is going to track everything, and security wise, that is why it is more popular when compared to other, because in other tools there are scenarios where you can delete the version information, but in this it is not literally possible, whereas the changes can be done on top of the existing. So both the content will be reverted, but it will be creating a new reference for it as a new commit ID. Okay, so let us do the same thing now and see how it is going to work. So now if I say git revert from my workspace, whatever commit ID that you want to give, where whenever you are referring to a commit ID, you can either refer it fully or the short form where the first 7 characters is sufficient to track it. Okay, so with this, if you enter it now, it will be asking us a commit message to enter. That is because internally the revert is going to create a new commit with the reference of the modification. So that is why it is opening a file and asking us to enter what is the message you want to give. By default, this is the message that it puts. As of now, I'm not interested in giving any more messages. So I'll just save it as it is. So now if you look at the content of the file, we have got back exactly what we had before creating this. That is, at this point, whatever we have the content, we got it. And the same thing, if you look at the commit ID, you will not be seeing this, but on top of this, you will be seeing a new commit ID that is going to be the exact reference of this commit. You can see. So it has created a commit because internally from the Git, you have actually modified something, but logically you have reverted the content of a commit from a file. So that is how it undoes a change which you have already committed, but that also will be taking as a new commit ID. Okay, getting it on first, what is revert? So remember, undoing a commit ID in Git literally means that you are actually creating another commit, whereas the content will be pointing exactly to what you had before creating the commit. Okay. Now, coming back to the question that you guys had, where that is correct. Now I have undo the change or I have reverted. And where is this commit ID available? It is available in our change. So literally now, if you are interested to undo a change in your workspace, it is also creating a commit ID. And now anything that is a commit ID in our workspace, if I want to share it to the central repository, then I have to do a push. So that now, if you do a push of this, literally it means that from the content of the central repository, you are undoing the content, and top of that you are putting a older content, but it is in terms of new commit ID. So that is how in the central repository you cannot do a undo, because once again central repository is a bare type repository where you will not be doing any changes. It is only used for storing. So now typically in our central workspace we would have been having this commit ID, right? On top of that, if we did this and pushed in the central repository also, you would have been this only. Now, since we have reverted it, we will revert in our workspace or wherever you are doing, and from there you will push the new commit ID, so that in the central repository also this will get updated, where the content of this is the revert of this. That means it is going to point to the previous one. So that is how you will be updating the central repository. So anything that we are going to do is going to be a commit ID, and that is what you're going to share it to the central repository, or we will be taking it. So simply, when you want to do a undo, it is not on the central repository. You have to do it in any one of the workspace. So that is when I said either you ask the developer to do, or if you're trying to automate that process also, whatever workspace that you are creating in which we would be trying to do the build or do the testing, right? From that workspace, we will go ahead and undo, and in that you will create a commit, and that commit can be pushed back to the central repository, so that whoever wants to take that as the latest, they will update the workspace. For instance, the developer now he wants to do the change, he will do a pull of that. So in his workspace also, whatever changes that is causing problem will be reverted. In turns, the content of the file will be pointing to the oldest content, and top of that, he'll be doing the changes. Getting it? Do you guys get it on what do you mean by revert, and how do you exactly revert, what happens in the revert, and where do you exactly do the revert? It is not on the central repository. Everything is on your local workspace. Any questions? Others? Vinay, Hari, Karnakar, understanding the concept?
Yes, sir. I'm following.
Okay, I might repeat the question just to make sure that you guys are following, because if it's a silent, the part that I can think is either you understood or it's completely confusing. Okay, so just let me know as soon that I can proceed.
Sure, Adam, sure. I will.
Karnakar? Okay, so now, so we saw how do we undo a change. Okay, that's great. And then we saw from the undo, how is that you are going to create a new commit ID, and how is that you will be pushing it to the central repository. Now, let's take a scenario of the same point for a developer. Okay, now let's say the changes has been creating a problem while you do a build. Now, when you go to the developer, now I will say that, hey, look, I am trying to do the testing, or I'm trying to create a product, and I feel that your change is actually causing the problem, because let's say the build failed or the product creation failed in 5.java. So that is why I'm saying it is causing problem, and we have reverted this change also. And whatever content he has done in 5.java is also not there in the central repository. So that is absolutely fine, because from a product perspective or as a process, you have immediately trying to address the problem by undoing the change, so that you are not fixing, but you are making sure that that problem is not appearing, so that any other latest change you want to put, you can use that and do the testing or create the build. But if you look at the developer's point, in order to fix, how is that he's going to reproduce it? So to reproduce the problem, if he has to once again create the change, it will be a problem, because what we did is simple one line. But in his case, if he has modified more than 10 files, multiple lines, then it is already going to be a headache for him, where he cannot keep rewriting everything. So this is one of the scenario where he would be interested to go back to a particular commit ID. Okay, now let's say this is your workspace on which you did a pull and you got all the latest one. Okay, now assume that this is what you have got. And now, as a developer, my interest is I want to do the testing of the change, whatever I did, once again, in the same way what the DevOps engineer or the build engineer has done to create the product or testing. So if I want to reproduce, I want to go back to the same content what I had, or simply I want to go back to the same commit ID. So that is how, whenever you have a scenario where you want to traverse between one commit ID onto another older commit ID, then what is that you're going to do? Okay, now simple scenario, as I said, we are currently pointing to this commit ID, right? And now I want to go to this commit ID. Okay, so that is when, if you want to traverse from one commit ID to other commit ID, then you will use the command called checkout, and for this you will give the commit ID. So now what will happen is, Git will actually take you from this commit ID to this commit ID. Or internally, what it means is whatever the commit ID head reference is pointing, it will take that and it will go back to a older commit ID. Okay, so now here, let's say you have these many commit IDs. Okay, and so currently the head reference is pointing to this one because this is the latest. By default, it points here. Now, if I want to go back to this commit ID, then it means that I should tell the Git to get the head reference from there to put it here. So that now, whenever the head reference is pointing, it means we are exactly looking at the content in our working directory similar to what you had here. Okay, that is what internally it means. So now what Git is going to do is, if I say check out this commit ID, it is going to move the head reference from here to that particular commit ID. And because of that, the content of this will be visible in our working directory. Okay, so that's how when it moves, corresponding to that, you will be seeing only the content. And that is the reason whenever we do a commit, the head reference will keep moving to the latest commit ID because that is what you are interested to see, and top of that you want to do. In our case, instead of the latest, I am actually going back to an older commit ID. So when you do a git checkout under commit ID, the head reference will move to that particular commit, and in that, whatever content you had, you will be again looking at it. Okay, so let's first do this practically. Now I want to go back to this commit ID. Okay, so watch very carefully. The content of the file is this, but now if I want to go back to this commit ID, let's do a git checkout and this commit ID. Okay, and in this, let's check out the content. So you can see now, this is why Git doesn't delete anything as it is. So any point of time, you can easily go back and refer a particular content that you had. So that is how you can switch. In fact, this was one of the question I believe Vinay or Syed asked me in the very beginning, saying that how is that I can check out only a particular content or only a particular commit ID. This is what exactly you do. So by default in Git, whatever branches you have or the default branch, you will be getting all the copy of your central repository to the local workspace. So in that, in a particular branch, wherever you are working, you will be getting the entire commit IDs as you had in the central workspace. So in that, you can choose where you want to do. So it is not that you will always be pointing to latest. If you are interested to go to a particular location, simply say git checkout to that particular commit ID and it will take you. Okay, so this is the concept. Getting it on how do you move from one commit ID to the other commit ID?
Adam,
Yes.
hello. Can you hear? Adam, whenever we do checkout to the particular commit ID, so that means it will be reverting the changes as it was. Am I right?
Don't get confused. It is not a revert. What did I mean here? I said checkout means you are just changing the head reference from one commit ID to other commit ID so that you are looking at it. You are not doing any changes. You are just looking at the content. Now, once again, if you want to go back to this particular commit ID, if you just say git checkout this, then it is just taking the reference of that. Once again, go back to the basics. What do you mean by checkout? If you're going through the very first session in the terminologies of SEM, I said checkout is nothing but the command or the concept where you are telling to the tool to exactly show you the content of what you are interested to work. So that way, if I say git checkout this commit ID, what I'm telling to Git is I am interested to see the content, because what it does is it takes the head reference from whatever commit ID it is currently there and it will point it to the particular commit ID where you have told it to check out. That way, that content, whatever you're going to have, will be internally shown in the working directory. So revert is separate, checkout is separate. Checkout means you are interested to jump from one location to other location, but you are not doing anything to the changes. You are just jumping from one commit ID to other commit ID. So if I want, I can once again go back to this. I can come and see the content of this, or I can come. So if you want to traverse between any commit ID, then you will say git checkout and the commit ID, where the head reference will be moved from one location to another location corresponding to what you are seeing. And with respect to that, the contents of that will be visible in your working directory.
Okay, got it. Thank you.
Getting it right?
Yes, Adam, I got it. It's kind of changing a directory. You are going to some directory and seeing the files.
Yeah. Internally, you're not changing the directory, you're changing the content. So I want to go back to older
Yes.
and coming back to the latest content.
Correct. Okay. Now it is clear, Adam.
Okay. So if you've understood it, now here, what did I do? I did a git checkout. And suppose if I want to go back to the latest, what is that I have to do? Now, once again, if I say git checkout and a particular commit ID, it will take me to that particular commit ID, so that now whatever the content you have, you're going to see. Correct? This is what it's going to do. So if you look very carefully, where did we use this checkout command? Did we use it anywhere else before?
Switching between branches.
Exactly. Now, currently I am using git checkout to move from one commit ID to other commit ID, or traversing between the commit IDs. Okay. Yeah, everything. See, you are not doing any change. You are just going back from one location to other location, and when you come back, so whatever was there at that location, you can easily get it back. So that is what you mean by tracking, right? So what do you mean by exactly tracking? Tracking means any point of time I can go back and have a reference of what you had at that point of time. So that is why we are internally creating a commit ID. So the ultimate point is not about just storing and keeping a record of it, but anytime I want, I can go back to that, and then everything will be there exactly at that location, at whatever you had exactly at that time. So that is what we tell by commit. So if I say this commit ID, whatever that you had at that point of time, you're taking a snapshot and you're storing it as a commit ID. So that means if you go back to this commit ID, you're going to get the exact content what you had as if this was the latest commit ID that you're pointing. Okay, so everything will be shown as what you had at that point of time. So that is what you mean by traversing between a commit ID. So same way, if you have looked, we also use this command to switch between one branch and another branch. That is what, if I wanted to switch between the master branch and the Windows branch, we use this. Correct? Now, here, if you look, I am using the same command to specify the branch as well as I am using it to specify the commit ID. So literally, how does checkout work, or Git understand whether this is a commit ID or which is a branch? Okay, so to understand it little more deeper, now the question comes is, where exactly is the commit ID? Okay, so a commit ID is inside a branch. Okay, and where is a branch? A branch is inside a workspace or a repository. So it is like, an example that I can say is, now if you are working in an organization, okay, now from outside, if someone asks you or if they want to identify you, they will say he is an employee of this company. Nageshwar, can everyone hear me? Hello? Okay. So the example what I'm saying is, now if someone wants to refer or identify you, they would say that, hey, this person is working in this organization. But where exactly you are working in that organization, if you come inside, now they will say that he's part of this team, right? That is how they will say that this person within an organization is working in this team. But within the team, if they come and they try to find out, or within the business unit they want to come and find out, then they will be trying to refer exactly with your designation or with your role, correct? So that way you can compare it like this. Okay, so designation, and you can call it as your BU or business unit, and then your company or organization. So that is how anything that you want to refer in Git internally means you have to give all the combination of these three, which means now when you are working, you are ideally going to work on one workspace. Okay, so whatever commands that you're trying to do a commit, push, pull, or anything pretty much is within a repository. So that is how this comes down to this position. But inside our repository, now we know that we are not trying to store directly into a repository, but anything that we are doing a modification is specific to a branch, right? That is how you switch between the branches, and in that branch you specify what you want to do. So now you are going to use a specific branch, and in that branch you are going to do a commit ID. So literally now if you say that I am working on a Git workspace, ideally it means that you are working on top of a commit ID, correct? So that way, where is the commit ID? You cannot just say that I am directly working on a commit, but that commit belongs to a particular branch, because you will be having more than one branch in your workspace. In that scenario, you have to specify which is the commit ID that you're working, and that commit ID belongs to which particular branch, and this branch belongs to which repository. So that is how you have to say all these things, through which exactly you will be able to point to a particular content. So that way you're going to work in one repository. So that is absolutely fine. So in this, when you're trying to do a checkout, which means you are telling to Git that you are interested to look at a content of one commit ID, then you have to give a combination of both, which means the default way that you have to tell us, you will tell what is the branch, and in that branch what is the commit ID. Okay, so that is how if you point to something, you have to point in this way. So that is how within your workspace we will be able to exactly go from one location to other location. So a commit ID is not just a direct commit ID, but it is coupled tightly with the branch. So that is how you have to say that a particular commit ID associated with the branch. Okay, so in the same way, now coming back to the problem, how does it identify both of them? So if you look, if you don't even give the value, then there are certain default value that it is going to assume, because of which we were able to actually go from one branch to other branch. So if you really look, when I did a checkout from one branch to other branch, we were going into the branch, and in that branch everything is a commit ID, right? So on what commit ID are we doing the changes, which means on top of what commit ID are we actually doing? We were working on the latest commit ID only, right? Did we ever go into any other older commit ID and work? No. Whenever we do a git checkout from one branch to the other branch, it was literally taking us to the latest commit ID. So that is how any changes that we did, we were doing on top of the existing latest one. So that way, if you do not give a commit ID, then by default it is going to take the latest commit. Okay, so remember, that is how when we did the checkout of a branch and we didn't tell the commit ID, it means Git will take us to that branch, and in that branch it was taking us to the latest commit ID. That is how we were always pointing at the latest commit ID, and we were seeing the latest commit ID's content, and anything that we did, it was on top of that. Okay. Now, the same thing. In this scenario, sometime back, when I didn't give a branch, but I only gave a commit ID, then it is always going to take the current branch on which you are working as the branch in which the commit ID is available. So if you say git checkout a commit ID, by default, it will check on your current branch, and if it is available, it will try to take. If not, you have to tell specifically, or you do a git checkout of that particular branch and then try to do a checkout, or simply it will take it up on the current branch. Okay, so that is how the checkout actually works, because it is not just a commit ID, but whenever internally, if you see, Git understands everything in the concept of a repository, and in that repository which branch, and in that branch what commit ID. So that is how it used to show you the content. Okay, so simply remember this. So far, whatever we worked, it worked in this concept. So now, if you are interested to move from one commit ID to other commit ID, then simply you just pick one particular commit ID, and then if you say git checkout commit ID, it is going to consider your current branch on which you are running the command as the branch in which the commit ID is there, and it will try to go to that, because it will be available in the commit ID. Because if you are trying to search, I am trying to search it from that branch, because this commit ID cannot be the same in other branches unless and until you are merged. But ideally, whatever that you are doing, you are working in that branch, so it will try to switch on that branch. So if I want to move from this commit ID to this commit ID, watch very carefully. There is one more thing that you need to know. So if I move this, currently I'll be coming from this commit ID to this commit ID. Okay, so that is how you move from one commit ID to other commit ID. Now, watch this. I was here. Now I came back to this particular location. And now, if you do a git log, see the output. It is not going to show from here, but it is always going to show from the commit ID where you are working. Can you see the difference? So earlier, it was showing everything from the latest to the oldest, but now it is trying to show you only from the middle to the older. That is because git log will always work with the reference of where you are working. So as of now, the commit ID is not pointing here, the commit ID is pointing here. So it takes this as the current commit ID where we are working. So git log means from that commit ID where our head reference is there, it will try to show all the things beneath it. Okay, so it is always going to show the reference based on the head's location where it is. So with the reference of where is your head pointing to, from there it will be showing it. Okay, so understand it. That's how you try to switch. So the point once again, now what is that I have to do if I have to go back to the latest commit ID? Now currently I'm pointing to this, right? If I want to go back to this commit ID, what is that I have to do? You getting my question? Currently from here we checked out and we came to this particular commit ID. Okay, what if I want to go back to this commit ID?
Again, we'll have to do checkout.
Exactly.
To commit ID which
yeah, if I do a checkout and if I give a this commit ID, what will happen? The head reference, whatever that we had, which was pointing at this location, right? So it is pointing at this. So this is where the head reference is pointing. Now, if I say git checkout and this commit ID, this will be removed and the head reference will point back here. Correct? That is how you move from one commit ID to other commit ID based on your interest. Whether it could be an older commit ID or you want to come back to the latest commit ID. Okay, that's a good answer that you said. But now watch the screen. I did a clear screen. Okay, and now literally I don't know what is that commit ID, because every time if I do a git log, it is always going to show me from my current commit ID only, right? So how is that now I can go back to the older commit ID? Can anyone guess it? The answer is here. What I'm saying is, we came from the latest commit ID to a older commit ID, and now how is that we go back to the latest commit ID?
Then you can do the checkout branch name.
Exactly, sir. So we now know that at any point of time, if I just give a branch name, it will always take to the latest commit ID, isn't it? That is what I was trying to explain. So now I don't have to worry what exactly is the commit ID. Once again, if I say git checkout this Windows branch, literally it means that it will take you to the latest commit ID of that. That is what I was trying to explain some time back, where if you switch from one branch to other branch, it is going to take you to the latest commit ID. But it doesn't mean that to switch a branch, you always have to go to other branch and come. So if I rerun the same command called git checkout and the branch name, it is just going to change the reference of the branch, where now if you look, you are going to point to the latest commit ID. So it will show everything from the top to the older commit ID on that fashion.
Adam, your voice is not audible.
Can you hear me?
Yeah.
So now you can see that whenever you do a git checkout of a branch, now what it has considered is, since you have not told the commit ID, it is going to take the latest commit ID as the default commit ID, and because of that, you're going to get everything back, which means now the head position is moved to the latest commit ID as default, and that is how you will be able to get it back. Okay, so remember these two things. Checkout means it is not just only a branch or a commit, but a combination of the branch and a commit in it. And by default, you are working on one repository. If not, it is actually the repository in which branch and in that which commit ID. But here, since we are already into a repository, so you're going to simply say in that repository which branch you're interested to work, and in that branch what exactly is the commit ID you're interested to work. So that you will tell it here. So if you do not give a commit ID, just give the branch, then it will take always to the latest commit ID of that branch. Same way, if you just tell only the commit ID and not the branch associated to it, then by default it will always take the current branch on which you are working, and there it will try to move the commit ID from wherever you are pointing to that commit ID. Internally, it is not just pointing the commit ID. What exactly it is doing is, it is moving the head reference from one commit ID to other commit ID, and corresponding to that, whatever contents that you had exactly in that commit ID will be appearing in our working directory. Getting it? On what do we mean by exactly a checkout, or how do you traverse between one commit ID to other commit ID and one branch to other branch? Vinay, Karnakar, Hari.
Clear, Adam. Everything is clear.
Okay. So if that's clear, now let's move on a couple of other things which is important. Now let's say, so far what we did, we created a commit, we tried to push and pull, and we were trying to traverse from one place to other place. Now at any point, if you have a scenario where you want to delete a file, okay, now let's say that you have done a release, and after the release that particular file is no more needed. Maybe the functionality itself is obsoleted. So you'll be hearing this word a lot in terms of the release management, where you are obsoleting some feature. Okay, so that way, now corresponding to that, the files whatever that is going to give you the functionality should not be available in your repository. So that is how when you create a product, based on that, the files will not be there, and according to it, the new feature will also be, that particular feature will also be not available in your product. So deleting now literally means that you are not deleting from the repository, but you should put a reference in such a way that it creates a commit ID, and that commit ID is also available in the central repository. Okay, so when you want to delete a file, simply use the git rm and then delete it. Okay, so let's say I want to delete this file. So make sure to just say git rm and the file name. So what it is going to do is, it is going to do two things. First, it is going to remove from the current working directory, not the workspace, but the working directory. And then it is also going to put it into the staging area. So that is how you will try to directly commit it, where it will be stored as a reference. Getting it? So now what it means, you are deleting and you are creating a reference for it. So now if you push this commit ID to the central repository, and from that going forward, anyone tries to take that commit ID, on top of that he does the change, he will not be seeing the 7.java going forward. So that is how you delete a file and create a commit ID. And it doesn't mean that you cannot see the content. If you want, any point of time, you can go back to a particular commit ID where you had all this content, and from that content, you can just refer it. But literally it means, in Git, if you want to delete a file, delete the file and put it into the commit ID or into the repository as a reference through commit ID, and that you push it to other central repository, so that going forward you will not be seeing this file in any of the workspace, because it is not the file, but you are referring to a commit ID in which the directory doesn't have the content of that file, or it doesn't have the file at all. Okay, so that is how it creates a snapshot of that and does the change. Okay, so literally deleting a file means use git rm and create a commit for that also, and use that commit ID as a reference to work. So going forward, on top of that, whatever you changes you do, you will not be able to see that file or files which you have deleted. Okay. Then there's one more thing called as clean. Now, this is again something that we will have to do in terms of testing, where now if I'm trying to do a testing or build of this product, there will be many runtime files that is created. Okay, and in that, if you recall, what is the git ignore? Git ignore is a file in which if we put a file name, then Git will not be considering that file at all. Correct? But when you are actually creating a product, it means that you have to do some testing, and for that you will be creating many runtime files. Okay, so you cannot keep adding all these runtime files to a git ignore file and keep tracking it, because at that point of time, if you create thousands of files as the runtime file, it is not easy to keep on adding everything, because that itself is going to take long time rather than trying to test it. So that is how, from a developer point of view, or from a testing, or from a point where you are trying to rebuild the product, if you do not want all these runtime files that you have created, you can just delete it at one shot. Where, what are these files which you have created during runtime? These are not available in the central repository, or sorry, it is not available in your local repository. So that way, what do you call a file which is not available in our repository? We simply call it as an untracked file, because the repository doesn't know anything about it, right? So at any point, if you want to delete the files in your workspace which are untracked, which means which you have created for the first time and the repository doesn't know anything about it, then you will use a command called git clean. Okay, now let me quickly create some files. Let's say I create some Excel file, okay, and then I'll call it as dummy.log. So that way, whatever files that you create, now all these things will be considered as untracked. And I don't know how many such files will be created, so I don't want to keep on adding in the git ignore and waste my time. But simply now, if I want to delete all these files, then you will use a command called git clean. But before you do a git clean, you can always use an option called -n that will give you the expected files that can be deleted by this action called git clean. So it will clearly show you that these are the files which are not being tracked by the git in your current workspace. So these are the expected ones which the git would remove. Okay, so that's how you do a dry run first. Dry run means don't delete, but tell me what you exactly you're going to delete. Okay, so by this you can cross verify whether you need this file or not. In case if you are requiring this file, go ahead and do the commit of only this. How would you do? Just say git add of that file and it will be added to the staging area. Then do a git commit, only that file will be added to the commit. And then go ahead and do a git clean. So now when you're doing a git clean, use a -f which represents forcibly clean everything in your workspace which are not being tracked by the git. So now you can see those runtime files or untracked files will not be there and your workspace will be clean. Okay, so clean especially is used whenever on a workspace you have already built a product or you have already have all the files of the complete product as it which you have used for testing. So now in that case, once again, if you want to create a new product, you don't want all the previous files that is present. So that way you just want to clean everything and redo from the beginning based on the latest changes what you have. So in those scenarios, as a developer or as a QA or particularly as a build engineer where you have to create the product, you will be trying to do a clean of your workspace which will just delete all the untracked files. Getting it? Is that clear? All right. So let's come to one of the last topic that we have in Git in terms of practical. So tag. So what do you understand or what comes to your mind when I say the word called tag or label? Have you ever come across a word called tag or label anywhere?
Yeah, just it is a reference of wherever we are releasing the code. Like just we are based on commit ID, we can refer
Okay,
like label, right?
other than Git, is there any place where you have seen what is a tag or a label anywhere in your day-to-day?
Yes, yes, Adam. In Facebook, every time we will try to add a tag for our friends.
That's good. Okay, so now, what is the purpose of tag? You tell me, whatever you said, Facebook, that's exactly correct. So why do you need a tag in Facebook?
So whatever we are doing, we are let them also know, and we are sharing everything with them.
Exactly. Same way, now there is other word that you can use for tag is label, correct? So have you used label anywhere on your day-to-day life?
Label in the sense it's like a comment. It's like a comment labeling. So if you want any, if you want to give, it's kind of comment only label.
Forget about technical. I'm saying You go to a shop, have you seen a label anywhere or a tag anywhere?
Yes, any
Emma,
product you can take, it will some label, right? Some thread kind of thing. They will attach one label.
Yes.
I mean, remembering the how much cost this one.
Yep.
Same thing.
So either it could be a Facebook, which you are creating a tag, or you're going to a shop and you're trying to buy something and you see a label or a tag. So what exactly tag says? So tag, we are trying to attach something as a reference so that if we want to quickly refer something, I can use the tag and quickly refer so that we can easily get the particular reference of it. Okay, so it is the same way now a tag in a Git is used for. What is the necessity? So let's say on a day-to-day basis, we are trying to do so many commit. So ultimately as a user, if you look, what is he doing? He's trying to do a commit. Okay. And like this, there will be many commit IDs that will be done and we are going to store and we create a product test. If everything is fine, we'll move ahead, do a release or keep doing the same thing with commit IDs, testing, giving it to release. So that way, how many releases that we have done, we cannot keep a track directly. And suddenly if someone comes back and says that, hey, can you tell me what is the release that you have given for a particular customer? I don't know that from what commit ID I picked up, because by looking at this commit ID, I cannot easily say that this is the commit ID that I've given. The same way, now, suddenly if the QA comes back and says that, hey, yesterday I did one testing of a product of a build what you gave, and I think there is some problem and I want to test it again. Can you tell me what is the commit ID that you guys gave me so that I can try to recreate a product and test? Now, not only that, we as a developer or when we are doing some change, we want to know at that particular point of time what is that we did in terms of commit ID. So any point of time, if you want to refer something in Git, it is a commit ID. So it is not easy for us to refer all these commit IDs with the names, because even though if it is 7 small character, it is not easy to remember, which is complex. So that is when you can create something called as a tag and attach it to the commit ID, where tag is nothing but a string or a name where we will attach it to a commit ID. So whenever we want to refer to a commit ID, if you can remember the name or the tag and you can refer it, internally we are going to point to that commit ID to which it is attached. So that is how it will be easy for us to remember a name rather than remembering a commit ID. So that way, now let's say you are using a tag. Now for what and all purpose you will be using tag? So generally you will be using tag for releases, or to notify or identify a release, or to identify what exactly is the commit ID on a daily basis that we are giving it to a QA for testing, right? So these are the two major scenarios that we can use. But internally, if a developer wants, he can try to create a tag whenever he wants on a particular commit ID. But from an organization, tag is used mainly to identify a commit ID which we have released, or a tag which has been given from the developers to the QA to test. That is the build what you have done, and then what is the commit ID on which you are trying to test. So that way, when you want to create a tag, it is nothing but a name. So every organization will try to follow some kind of naming convention for the tag. So it is completely up to the organization or the product or the person who is trying to take care of Git. They will create a naming convention through which it will be easy for them to understand. Now let's consider that we are also using a tag for applying it for release. Okay, so that way now you can have a naming convention. So now let's say if we are trying to use a tag name for release, I can have something like this. Okay, so I'll say the word as release, which represents that I'm using it for a release tag, and then I will give the version number. Okay, so you can give it like this. For example, I can say release 3.2.1, or I can simply say release 3.1.2, or I can see. So it is just a naming convention that you are going to use. Everything is going to give you the same meaning. It is you, the one who are creating it. So you will be having a naming convention through which it is going to be easy to attach. So now from the commit IDs that you have, okay, so all you have to do is now you have to pick a particular commit ID on which you want to attach a name which will be as a tag. So that name will be attached to a particular commit ID. So going forward, if you just ask the Git to give you the contents of that particular commit ID, then internally it is going to fetch the details based on the commit ID which is attached to that tag. So that is how it is easy for us to remember this. Now, here, let's say we are following this as the convention that in the company, okay? And now, let's say I am trying to attach this particularly to one commit ID, okay? Now, let's say I'm using this commit ID, and for this commit ID, I'm attaching this naming convention, okay? So, now, what is going to happen is, you are actually creating a name and attaching it to this commit ID. Okay, by that way, anytime you are referring to this, internally it is going to refer to this commit ID. Okay, so that is what we mean by a tag. Now, like this, if I want to create another tag, and I can keep on creating and applying, and we don't have to remember this name, because if you just remember the naming convention, then it will be easy for us to just recall it. For example, if this is the naming convention that I'm going to use, and tomorrow, let's say, if there is a older commit ID that you want to refer, okay? Now let's say I am interested to refer a older commit ID that could be like 2.1.2. Let's say you want to refer to that. Then without any problem, you can easily now say that the release tag will be exactly in this format, because this is the naming convention that you're using. So simply refer to this tag name, and whatever that commit ID referring to it, Git will be pointing you to that. So that is how it will be easy for us to refer to a commit ID in the name of tag rather than remembering it. Okay, so how is that you're going to do? So basically, first you're going to use a command called git tag, and for that you will say -a and the pattern or the name that you are trying to put. And for that, what is the message that you are trying to give, so that you will know why is that you are creating a tag, and corresponding to it, to which commit ID you want to apply, you will use it. Okay, so let's try to do that. So now if I say git tag -a release 3.1.2, and this, let's say I apply it to this particular commit ID. Okay, and I'll say test commit for release 3.1.2 version. Okay, and then followed by the commit ID. So you have created a tag and attached. How do I see a list of tag? Just say git tag and it will show the details of this. So anytime now, if I refer to this, it is actually going to give you the complete details of the commit ID. So look at this now. If I say git show and this, it is going to fetch the details of the commit ID from which we have created. So it is going to say that this tag is created by this person, this email ID on this date and time, and this is the reason what you have given on the message. And then this is actually pointing to this commit ID, where this commit ID was created by this person and this email ID and the date and time stamp, and it is going to be giving the details on what exactly you did. So this is exactly as equivalent of saying just git show of this commit ID directly. So whatever that you are seeing it, directly you're going to get it here. So that is how, instead of pointing to a commit ID, you can attach a tag name, which if you follow as a pattern, just keep changing the pattern in the same way with different values. I mean, keep using the same pattern with different values. Then you can always recall any name by just looking at it. Wherein if I say git show, it is going to show me all the, git tag, it will be showing me all the tags that I have. From that, I can pretty much use what commit ID is referring to it. Okay, so that way it is going to be giving you a more meaningful way and an easy way for identifying a commit. Getting it on what do you mean by a tag and why is it you have to create, and practically how do you create? Others, did we get that? So now, to continue this, let's understand one more thing. Okay, now I'll go back to the tag that you guys were saying from a material that you want to buy. Let's say you are trying to buy some product on a shop. So there will be one label on it where now the same product can be having more than one tag on it. Now let's say that you are going to buy a mobile phone, and in that shop, for that mobile phone, you might have more than one tag where there would be a tag for price, there would be a tag for the specification details, and there will be a tag which gives you the warranty and other details. Like this, for the same product, you can have more than one tag, which is completely valid. But we cannot have one tag attached to two products, right? Now let's say you're trying to buy an iPhone. Okay, and so in that shop, for that iPhone, he will give you a tag attached which will give the price, and then there will be a particular specifications of it. Now, next to it, you might be having an iPhone of a different version, an iPhone 5 and an iPhone 4. So now you cannot take a single tag and attach to both. That is because a tag is specifically to that product. So that way, try to remember, one product can have many tags, whereas one tag cannot be shared across product. The same thing applies to the commits, which means one commit ID can have more than one tags on it, whereas one tag cannot be applied to two commit IDs. Understanding it? It is simply because I can do more than one releases on the same commit ID. Let's say I gave the release 3.1.2 on it, and I also gave a release called 3.1.3 on it. But I cannot take the same 3.1.2 and from this particular commit ID, and now if I go and apply on something else, it will not apply, because a commit ID will be referring to a tag, and this tag is actually committed internally to this commit ID. So simple logic is one commit ID can have more than one tag, okay, whereas one tag cannot be attached to more than one commit ID. So let's try to see that also. If I want, I can attach the same tag to this also. Okay, now let's say I'll create a new tag and I'll attach it to this commit ID. Okay, now we have two tags pointing to the same commit ID. So this is possible because we have two releases done on top of the same changes. So that is why, oh sorry, is it the same commit ID that I took? Okay, it's just a commit, the tag, right? So now for both of this, I'm trying to point to the same commit ID. Okay, now logically this is fine, but if I try to apply, let's say the same tag for some other one. Now right now I applied to this. What if I try to apply the same tag to some other commit ID? It will not be possible. So let's say I use the same 3.2 for instance, and instead of this I'm trying to apply it once again. and it will say that you already have a tag and you cannot apply. So that is how the concept here is one commit ID can have more than one tags, whereas one tag will always be associated to only one commit ID. Okay, so understand the difference between a tag and a commit ID and how it will be attached. Getting it? Karnakar, Hari. Okay, so understand the difference. How do you tag? Now, you have created a tag. So where is that you have created? Going back to the basics, anything that you create basically is going to be known only to this repository. So ultimately, the tags, whatever we have created, is in our local workspace. So now, if I want to push that tag to the central repository, we will use git push and give a -- tags. So that is when, instead of just taking the changes, what the git is going to do is, it is going to push the tag information other than the tags. So if I just say git push, it will take only the commit ID. Whereas now, if I want not the commit IDs but the tags, then I will say git push -tag. So by default, git push means commit IDs. And for that, if you are interested only to say the tags, then you will say -tags. Okay. So now we have created it. Simply, if I try to push it, and all the tags will be available in our central repository also. Okay, so that is how, going forward, if anyone is creating a workspace, he will also be getting all the reference, so you can easily cross verify them at any point of time. Okay, so you're trying to see that it is trying to push not the commit IDs but specifically these two tags, which is going to be updated in the central repository. Getting it? All right, so let me stop it today. Actually, I just have another 5 to 10 minutes, but it might be confusing. So let me stop, and whatever is there remaining on the Git, I'll explain
Now,
tomorrow.
So far, what did we see in Git is basically we first understood what is the workflow, how do you create a repository, and how do you do a change, and from that change, how is that you will share a change between people, how do you store it as a central repository, and then further we also saw the concept of branching, how we will be doing the parallel development, and then from that, how is that you are going to merge and share the changes between users in the central repository. And then we saw a couple of scenarios on if you want to take a backup or if you want to undo the changes, what are the scenarios and how do we move from one place to other place. So it's all more of the workflow, and from the Git perspective specifically on the user level we were trying to look. Now coming to the next point, there are a couple of things which we need to understand. One, what we need to know is there is something called as branching methodology. So that is quite important that we need to know. And then talking about the management of the repository itself. So that is one thing that we need to at least have an idea of what it is. So before we get into it, now, if you remember, if I say a workspace in Git, it is going to contain 3 areas. Right? So what and all are they? It is a working directory, staging directory, and or the staging area and the repository. So these are the 3 areas that we have in a workspace. And now, did we ever get back and see where exactly do you have all those things? So that is when, now let us go to a workspace and let's try to see where exactly these 3 areas are. So for instance, now let's take this workspace. Okay, so in this workspace, if I'm trying to see, there is only list of files. So in this workspace, where exactly is the working directory, where exactly is the staging, and where exactly is the repository? So in that, What is a working directory? A working directory is a place where we will be actually seeing the files physically, right? That's what I meant. So that is the directory where you will be able to see the files and modify the files. So in that way, now this is the directory where I am able to see the files and modify the files. So pretty much this is our working directory of the workspace. Then where exactly is the staging area? Staging area is a buffer place which will not be visible, but where is the repository? Because repository is again a directory where you are storing everything. So all the details about when you modify a file, it is saying, and when you try to take a list of branches, the commit IDs, all those things, where exactly do we have in it? Am I audible to everyone? Hari, can you check your mic again? Okay, I'll be a little loud in case if I'm sounding low. So whatever that we were trying to store, if you look, it was actually in a repository with respect to the workspace. Now in that case, where exactly is this information available in this workspace? Because if I go out of this workspace, I'm not going to get this specific to this workspace, right? So that way, where is our repository in the workspace? So in order to understand it, now if you try to see the files, it will not be there. But if you use an option called -a to the ls, which will try to show you the hidden files, then you can see there is a directory called .git in the same directory or the workspace. Okay, so this is the Git directory, or this is the Git repository in which all the information of what we are trying to store, the commit IDs, branch information, everything is available. Okay, and the reason why is that we have it by the name called .git, because inside this, if you go, you will be having all the metadata required, which will be acting as the repository. And if all these things was directly available under your workspace or in the working directory, and by mistake if you delete it, then it will not be treated as a Git workspace at all. So that is why, in order to separate in your workspace, where the default directory that you will be going inside your workspace is the working directory, and there will be an additional .git folder which will be treated as the repository. So this is how it will be classified, and this .git is going to be treated as your repository, and inside this you will be having all the details. So the objects, whatever that you're seeing, is the folder which is going to track all the commit IDs that you have. Okay, and then the head is nothing but the head reference of where we are currently pointing to. And configuration is a file which is going to store the details about from where you have connected, all those things, for example. So here, if you see, it is clearly saying that this is your origin, or this is your central repository from where we have taken, and in that what and all branches we have, and what is it a reference. Okay, so that is how it is going to track each and everything inside a .git folder, which will be treated as the repository. So be clear, .git is the Git repository for your workspace, and this directory itself will act as the working directory. So that is why you are trying to see this. Now, the same thing, let us go to the central workspace or the central repository. Okay, so this is my central repository. And in this, if you do a ls, do you see any similarity between what you have inside the .git folder and what you have here? It's kind of same, right? So what is the difference? Now, the difference between the bare repository and a non-bare repository. So what is the difference between a bare repository and non-bare repository? Can anyone quickly tell that? What is the difference between central repository and a local repository? Or what is the difference between a bare repository and non-bare repository type? Why do we call this as a central repository? Why do I call this as a local repository? No? You guys forgot? Yes. So in the central repository, we will only store and share, whereas in the local repository, you will try to store and share as well as you will modify. Okay, so that is the point now. In order to modify, you need a working directory. Okay, so only with the help of working directory, we were able to look at the content of the repository. Now, when you say that in the central repository, you are not going to do the changes at all, that simply means that you don't have a working directory at all. That is why, since we do not need or we do not have a working directory in the central repository, the contents of whatever you have in it is directly put inside the workspace. Whereas in our local repository, we need a working directory as well as a Git repository. So that is why you are going to put the contents of the repository into .git. Whereas in the central repository, there is no working directory. So you don't have to create one more folder called .git inside it. So directly you can put everything. That is the reason why even if you try to do some changes, you will not be allowed. That is because you are actually directly working on the repository. Whereas in the local workspace, repository will be put separately inside a .git folder and you will have a working directory. Okay, so understand that is the difference why it is called as a bare repository or central repository, because it doesn't have a working directory at all. Okay, so whatever you see is nothing but the content of the repository directly. Now, if you say central workspace or central repository, it is both one and the same, because in the bare type repository, you do not have a working directory at all. Getting it? Is that clear? And why do we call it as a bare repository? Now, by saying it, so far, what is that we did? Now, all the workspaces that we created so far, where was it available? Now, if you look, all the local workspace or all the central workspace that I had was available in the same directory, right? Now, when you go to an organization or in a production, it will not be like this where this workspace may be for one user, this might be for another user. In that case, this workspace will be available in his laptop or in his machine, and this will be available on the other user's laptop or on his machine. Like this, each one of them will be available on his own machine, and the central repository now should be in such a place where they will be able to access it from all the machines, right? Because if I am working, I am creating it. But what if all the 5 of us are working? I cannot keep this in my laptop. So I have to keep it in a common location where we have to access or we have to give access to all the people. So one way that you can do is you can have a separate machine in which all the 5 of us have access, and in that machine I can create this directory, and whenever we are doing a git clone, I can refer to the directory available in that particular machine. But instead of doing it, which is going to be a time-consuming process and you need a lot of authentication to be given, one of the simplest way that we can use is GitHub. So what exactly is GitHub? GitHub is actually a place, or simply it is an online place for storing
the Git repositories. Now, instead of storing the repositories on your machine or a particular machine, you can store the repositories online. So that now, if you want to do a clone, rather than referring to a machine in which a directory is available, you can refer to this online place called GitHub in which you can store. Okay, now it gives you all the freedom where you don't have to be dependent on one machine, and at the same time you don't need any specific access for that machine. So directly you can go to GitHub, and from the GitHub you can allow people to connect to that repository or do a clone of that any point of time that you need. So that is how it is going to be simpler in terms of the process and also for maintaining. So GitHub is actually a free place which is been given by the GitHub where you can store the repositories. But as an organization, if you see, it is not possible to use the free space, because whenever you say free, then there is a catch that is going to be public where anyone else can access it. So that is when, if needed, by default, GitHub will be giving a free account where you can store. But if not, if you want to keep the repositories privately, not to be shared with anyone, then you can buy a particular location in GitHub using which we can try to ensure that place is private. Okay, so that is one of the things that you will be doing. Or in some companies, they might be working on some other tools. So we have tools like GitLab, or we have tools like Gerrit, where that is another tool, just like how you're saying GitHub, where you can store all the repositories. Ultimately, no matter what kind of tool that you are using, you are going to use it only for storing, whereas from that, whatever user commands or whatever the git commands that you have to work will be the same on your machine. The only difference that will be is, rather than keeping everything under one machine, you put it into this place like GitHub or GitLab or Gerrit, where it will be maintained separately. But in that way, GitHub is completely available online. You don't have to store anywhere else. Whereas the other tools like GitLab or Gerrit is actually another tool which you need to install, and then from that you have to create a web access from that particular location you are going to store. So in those tools, you can actually think about giving the permissions for the users, saying for this repository, who and all should be allowed to work, who should not be allowed to work. So those kind of changes can be done on top of that tool. So depending on the company, which tool that they have to use or which tool they have to choose depends particularly on their need. But if not, a common place to store is GitHub, because it is completely available for free. So if you go to the GitHub, first you have to make sure that you have an account created. Okay, so if you do not have an account, use a Gmail ID and create an account. Okay, and then once you go inside it, you will have a private place where you can store all the repositories that you want. So here you can see that if you want to create a new repository, you can create, or an existing repository you can push to it. Now in my GitHub account, I have 2 repositories available. So as an example, if you see here, I have some set of files that I have put, which is actually a Maven based Java project. Okay, so now anything that I'm going to store, instead of storing it in a machine, it will be coming up here. And now, how is that you're going to access this? Specifically, if you're accessing through GitHub, then this has a path which you will use, and that path will be like this. So simply now, if you want to refer to this as a central repository, then you have to do the clone based on that. So if you want to do a clone, how do you do a clone? Git clone, and you have to give the path of the central repository. So instead of giving a physical path, you are trying to give a path on the GitHub, where anything that is storing with .git is actually a central repository. And where is the central repository available? It is available under the GitHub, under an account called My SEM Learning Center. So that is how using this central repository available in the GitHub, we are actually going to create a clone. So now, let's say I'm going to create 05. So it is trying to access the GitHub, and from that, it is trying to do a clone. So you can see this is the same that I have over the GitHub online. So like this, I can choose this online place to store. So here, what is that we did? We created this workspace as a user. So any changes that you want to do, you do it here. And from this, when you do a git push, it is always going to refer to the origin of this or the central repository, which is this one. So like this, the only difference is from where you are trying to do the clone is the difference. Other than that, a user will create his workspace, and his machine on that workspace, he'll be using the normal git commands, and he'll be trying to do the changes, and then he'll be trying to push the changes from his local workspace to whatever is the central repository that he has used. Okay, so that's the major difference, where GitHub is an online place for storing our repositories rather than storing everything in our local repository. So pretty much now you can create your own account, and any repositories for Git that you want, you can try to upload into it and maintain. So that if you want to share it with someone, you will just give the path of this particular repository so that the user can directly do a git clone from this, and he can get all the changes. So whenever he wants to modify and push, he'll be pushing back to it, or if he wants to update the workspace with his latest changes, then he will do a git pull. So everything is going to work with respect to this workspace, which is available online on the GitHub. Okay, so this is going to give the complete details about how many commits has been done, how many branches you have, okay, who and all has been done the changes. So everything is clearly, this is just like how I am seeing my commit details inside the central repository through command line. We are trying to see everything using the GitHub account. Getting it? So like this, depending on what kind of tool that you want to use, you will not be actually storing everything on your machine or on a particular machine. So it is from the users, they will be trying to create a workspace on their machine, whereas to store, you can think about using some online storage like this, like GitHub, which is available for free, and you can upload everything to that location, or you can purchase a location and try to put everything online on this GitHub. Getting it? Any questions? Here, you all have the option. So go back to your GitHub account, create a new repository. And it is going to ask you for the options, where either you can create first an empty directory, as we did, you can initialize the repository, or if you already have a repository, you can use it to update. Okay, so simply you're going to say what is the name of the repository and what is the type of the repository, whether it is a, okay, so here you just give a name, test repo. Okay, and I want this to be public repository because anyone can access. Now, do you want to put a initializing by giving a readme? You can do. So this is your new repository. So if you go back now, you can see that I have created one new repository, and if I want to share anything to it, I'll use this as the account. So simply in this, instead of working on this, if I want to do a git clone of this, I'll say git clone of this and test. So now using this as a central repository, it is going to create a clone of your test. And inside this, now you see, you are just going to have a README file, which will give you the details what I have stored when I create it. So this is what I have, nothing else. So going forward, if I do any changes in it, I will first do it in my local repository, and from here I can push and update it to the central repository. So that's the difference. So you can directly create a central repository, and from this you can have a reference. Okay. So now there is one more advanced topic which is out of the scope, but at least I'll give you an overview of what it is in Git. Now, one thing what you need to understand is, now Git you are going to use only for managing the commit IDs. If a user wants to work, and how is that you are going to prevent authentication on who should be working and who should not be working? So that is how, as I said, you will be using some tool like GitHub. So if you have an account into it, you will be able to access. Or pretty much if you go to organization, you will be using some tool like GitHub or Gerrit, using which you will be trying to log in, where to that tool you will be integrating your LDAP. So I'll talk about what is LDAP in later session. But for those who don't know what is LDAP, LDAP is a utility or a server where you will be allowed to log in with a single username and password to many machines. So now when you go to an organization, you will be doing the same thing, where you will be having one account, and using that one account, you will be trying to log into all the machines. So that way, now whatever the tool that you're going to use on the backend, you will be trying to associate that particular tool with your organization's LDAP. So then if you try to log in, you will try to allow to log in only if you have an account in your organization's LDAP. If not, you will not be able. So that way you will make sure who has to log in. But now, if anyone who is working in a company will have an account, by default that will be available in the LDAP. But if you want to restrict on who should be working on this repository and who should not be working, so those kind of advanced options is available only on any of the tool. Okay, actually I have not connected. I'll try to show you in some time on how is that can be done. So those kind of advanced options where you want to take care on giving permissions. Let's say only Adam should be doing a push to it. No one else should be able to do a push. So how is that you're going to restrict those kind of authentication? So those kind of things can be done in that tool. And in addition, if you want to implement some process, then there is something called as triggers or hooks in Git. So what exactly is a hook or a trigger? Basically, it is nothing but a simple script that you can use in which you can try to put some process and you can apply that script to a particular command. So that way, whenever you are running any Git command, you will run that script which is called as hook or trigger, and based on what validity or any functionality or process that you want to implement, you can apply it using that. Okay, so one example that where you can use is, now like I said, every commit needs a commit message. Okay, so that way now if a user is giving a message, you do not know whether he is giving a right message or not, or even if he gives one space and enters, it will be taking it as a message. But when you're working as a project, you want people to enter some proper meaningful message, or in organizations, you will be actually having something called as a bug tracking tool, using which the QA or the developer will be trying to write the details on what changes they have done. And with that only the management can track what exactly is happening to a particular release, whether the development has completed it or whether testing has been done. So like that, whenever a developer or a user is trying to give a commit message, he has to make sure he's giving that ID against which he's trying to work. So every bug will actually have one number, that is what we call as ID, which will be used to track, so that you will know what is the purpose of that and what you are trying to achieve and for which release you are giving. Now, rather than giving all the details, you can just give only that bug number against which the user is modifying the files. So if you want to make sure that that is mandatory, then you can write a script which will try to take the message before it is going to do the commit and validate whether the message is exactly as what you wanted, and only if it is there, allow him to proceed. In case if it is not, you can make sure that you will try to stop your commit command and give the message to the user saying that, hey, the message that you're using to commit doesn't have the proper syntax, so try to give the details which is required. So like that, you can try to set up a process. Okay? Or there could be some times where before the release, you would like to make sure that none of the developers are going ahead with any new changes, because while we are doing a testing, if a developer modifies a file in between, again, you have to take that and do a testing. And in case if there is something which he has caused is going to be a problem, then the testing will also fail. So that is how in an organization, before doing a testing completely, once all the development activity is completed, they will basically ensure no more new check-ins or commits should go into that repository. So how will you make sure that? So that is one way where you can write a script and say no one should be allowed to do. So anyone who is trying to write or do a git commit or a git push, then it should be giving a message saying that you are not supposed to do a git push. You can go ahead and create a commit in your workspace, but you cannot do a git push. So like this, these kind of things can be done on top of a git commit command or a git push command. So that way, those are called as hooks or triggers or wrapper scripts. So what kind of script that you can use? Simply you can use a shell script or a Perl script or a Python script, anything which is based on your operating system on which you are running the git command. Okay, so that way, if you go into any one of the workspace, okay, and if you go to the git directory, which is .git, in that you can see a folder called hooks. And if you go inside the hooks, you will be seeing certain files, okay, where these files are the sample files which the Git is giving us. So now, when you are trying to apply a hook, which is nothing but a script, you can apply it to a particular command in two ways. That is, whether you want to invoke that script before executing the command or after completing the command. Okay, so that is what we call it as pre-step or post-step. So pre-step means as soon as you enter a command, you want to make sure that first the script is triggered, that is the hook is triggered, and it will try to do some validation, and if everything is fine, then it will allow you to proceed further. That is one. If not, the other one that you can do is after that command is completed, then you can try to call a script which will take care of some activity. Like, let's say for every commit, you want to get a message to be notified. So you can set the mail. So what you can do is simply now you can set a script which can act as a post script or a post hook for a command, wherein after the command is completed, you will call that script automatically, attach it to that command, and it will try to run the script. The same thing if you set it as a pre-commit or a pre-hook, then before you run the command, it will first run the script, and then everything is fine, it will go ahead with the actual command. So depending on what is your scenario, you can do. Okay, so I'll just quickly show you an example of what we can do. Now, let's say in this, I want to apply some rule where I want to do a commit, and before a commit, actually I'm trying to run a script, that is a hook. So that way, the name of the script, what you are going to put inside it should be the command followed by the pre or post. So if I am interested to write a script which is going to be applied for the pre-step of a command called commit, then I have to put a file inside this folder with the name pre-commit. The same thing, if I want to run a script after completing a command, then I will say post-the command. Okay, so now whatever that you are seeing here is a sample file. So if you rename this to this way, let's say pre-commit sample to pre-commit. Now what it is going to do is, now whatever the content that you have will get invoked whenever I call the commit command, and then this is the first thing that it will execute, and after it is completing, it will proceed further with the actual commit command. So like this, before doing a commit, I can validate certain things. Okay, now to just test, I'll try to edit this file. Okay, so you can see this is nothing but a simple shell script, nothing big in it. Now here, I'll try to write a message. Okay, now simply I'll try to add one condition, and I'll say if okay, let's not do first, let's understand that it is getting called echo pre-commit okay. I've just put one line. Now this is a simple script which they have given, which is actually not going to do anything, whereas internally I'm trying to put one command. So now in this workspace, if I try to do some change and call a commit command, now to that commit there is one a pre-commit hook or a script which has been created. So what will happen is, the first thing that it will do is try to run the script, and only if it is allowing, it will proceed further. Okay, so let's come out of this, and in this, let me quickly create a file. Let me do a git add, and let's do a commit. So now, as soon as you call this, it is not basically going to do the commit directly. The first thing that it is going to do is, it is going to call the pre-commit hook, because I am invoking a command called commit, and for that there is a script called pre-commit. So the first thing that it is going to do is, it is going to call that script, which is the hook, and then based on what you have given inside it, it is going to execute, and only then it is going to proceed further. So you can see the first thing that it did is, it is checking whether it is having any hooks, and there is a hook called pre, which means before you are executing the commit command, the first step that you have to do is call this. So it is calling, and since we didn't do any validation as such, it is completing it, and after completing, it is proceeding with the actual command, whatever that you have entered. Okay, so like this, you can try to set up the process of whatever is needed for your organization in terms of pre or post a particular command. So all you have to do is just say pre and what command you want to apply if you want that script to be called before the execution of that command. The same thing, if you want the script to be called after you have executed the command, then you will simply say post and the command name. Okay, so like this, whatever is the need for you to do automation of any process or authentication, you can do it. Now, once again, if you are using any tool like GitLab or Gerrit, they have these kind of options directly in it. So rather than you taking care of all those things, you can try to set up a hook directly in that tool where you're trying to store the repository. Okay, so those kind of advanced options are also available in those specific tools. So that's why people, use the administration perspective, whatever you have to do on those tools. Whereas the normal use case that as a user, they will be using the regular workspace. Okay, so remember, you can do those kind of authentication and creating a process about who should be working, who should not be working, or when to do a command and when not to do or execute a command using the hook scripts. Okay, so that's one thing that you have to remember as an advanced concept. In case if you have a necessity to do, you can simply do it. So Now, if you try to compare Git with any other tool, you can literally see the differences on what we are working. Now, one of the tools that you will be comparing with Git is Subversion, because Subversion or SVN is again a free tool. Okay, so that way, now the major differences between the tool that we are going to have compared with the Git is, first thing is, in Git, everything is distributed, which means every workspace will have its own repository. So whatever that changes you are doing, you have to do and store first in your workspace or repository, and then from there you will be trying to push it to the central repository. And then second thing is speed, because your workspace is going to have a copy of your repository, so pretty much any changes that you're doing will be fast enough in that itself. And also talking about branching, since every workspace has its own repository, you can create as many branches as you want and store everything and merge. You don't need someone else to do that, because in other tools like Subversion, the branches will not be available in your workspace. Branches will be available in the repository, which is available in only one place. So anything that you have to create, first you have to create in the central repository, and you will just refer to it from your local workspace. Whereas the advantage of that in Git is you will be having everything as a copy of the complete repository inside your workspace. Okay, so that's the advantage on why people start using Git, especially in terms of automation, lesser maintenance, and it's easy for the developers to take care of their workflow. Okay, and that's why one of the reason, importantly, that we use Git in DevOps automation. Getting it?
Hi Adam, this is Hari.
Yeah, Hari.
Hello, can you hear me?
Yes.
Actually, the GUI which we are getting it from GitHub. So can't we get the same GUI from our system, like a central repository?
Yeah, this is an open source. This is nothing to do with
Yes.
your machine. It is online. I am trying to connect it through online. I have not installed anything. This is an online tool,
Yes.
just like Gmail. So do you have to install anything for Gmail to access from your laptop? No, it is available online, right? That way, all you have to do is, if you can create an account on GitHub, then you can log into it and access, just like Gmail. So GitHub is an online storage for Git repositories.
Yes, I said this I understood, but I wanted to get the same GUI from the system, from my system, which I have installed Git. So can we get it?
Yeah, go to github.com. You can access it. I am not accessing it anything specifically my machine. This is the github.com site. So just go to the github.com site. That's what the example I'm trying to give. Now, if I go to gmail.com, does it mean I have installed anything for Gmail? No, I am trying to access it through web, right? Same way, if in your laptop, if you want to access Gmail, you can just go to the URL and enter. So that is how GitHub is also something available online. You don't have to install. All you need is, if you have an internet connection, then you can try to connect to that GitHub online, because it is an online storage.
Yes, actually, this I understood. This you are accessing from github.com. Just I wanted to access same like this kind of GUI from my server, like where I have installed a Git. So can we access? Can we?
Now that is a question. What do you mean by your server? Your server means your laptop?
No, yes. Suppose if I am using my laptop to install a Git, so it is called as workspace. So whenever, so I wanted to access the same kind of GUI from my workspace.
Yeah, then go to github.com URL. That is it. See, you are installing Git command for running the Git operations. So whatever that you have installed here, it is for running the Git commands. But in order to access the repository online, then go to this particular site. So that is what I'm trying to say. So from your machine, if you want to store something on the GitHub, then make sure that you have internet in that connected to that machine or laptop. And from that, if you can go to the URL and give http github.com, it will be trying to connect to it. So the only thing that you need is internet on that machine. If you have internet on that machine, you can connect to it.
Okay.
Getting it?
Yes, sir.
That's why I'm saying compare it with Gmail. So now, if I show you that I am logging into Gmail, does it mean that you cannot log into Gmail? You can log into Gmail. Only thing, you should be having an internet connection on your laptop or your machine. So if you have it, it is good enough. The same way, GitHub is an online place. It is not a tool. It is an online place for storing your repositories.
Okay. Okay. And later we will be going to discuss how we will integrate Git with LDAP. Am I correct?
Which one?
No, LDAP. So I wanted to manage the users for accessing purpose with the LDAP, as you told. So that
Yes.
how we are going to integrate with the LDAP.
That depends that you need to work with the IT team. Now, what tool that you're using, that pretty much differs, because this is one of the example, but I'll show you an example of GitLab, how we are using. But for working it, you need to go check with your IT team and you have to get the details like what is the LDAP server, what are the details of the LDAP server, and then you will attach it to that tool. So that is going to be something specific to each company. So every company will have their own tool, or they can directly use the GitHub itself. So depending on what kind of tool they are having, it is going to be separate in specifying it. So I'm just giving you an overview that in case if you are using any other tool, then what is that you're going to do is you will try to make use of LDAP, because in some companies you will also not be using LDAP. There is also something called as AD. Okay, now if they are using anything like that, the concept simply here is in company you will not be allowing users to create separate account. There will be one common account which will be created. That is what we call it as single sign-on. So for all the machines, they will be giving you one account. So you will use that account to connect to your laptop as well as to connect to different machines or applications where they will integrate whatever the mechanism that you are using with that tool with other accounts. So that is how with one account you will be able to connect to everything. Now to do that, you need to first understand in the organization how you have set up that single sign-on. So you have to work with the IT team and then try to do the same thing for whatever application that you are doing.
Okay. Okay. Actually, what I was asking is, so is there any option to integrate directly with some server where we can give the directly LDAP server name? From that it will take. Okay. Go ahead.
We have, but like I said, it depends on how your organization is trying to say. Again, I'm not saying every company will be using LDAP. LDAP is one of the option. Now, like LDAP, you also have something called as AD. They will be using that also. So depending on the company, what kind of mechanism they are using to ensure one common account. That is what you need to know. And second thing is how they have set up. You have to check with the respective IT team or the engineering team, or that is the engineering support team, and trying to find out how is that you can ensure the same thing for this tool. So they will give you the details about this is how we have done. You take the same details and put into whatever tool you want. And then if you add those things to the tool, it will be trying to take care of the authentication.
Okay. Okay. Yes. Thank you.
What I want you guys to do is create a GitHub account for yourself. So go to the github.com, try to create an account by signing into it. And then so far, whatever that you are practicing, instead of keeping the central repository in your machine, try to put it to the central repository on a GitHub and then try to do a Git clone of it, do the changes, try to push to that and pull to it. Because now anything that I push from here or pull will be going to the respective central repository from which we have created this, which is be on the GitHub. So that is the difference. Rather than having the central repository on the same machine, try to put it on your central GitHub that you have. So that is how, if I use some other laptop and if I want to access this, all I have to do is use the repository's path which the GitHub gives, or with respect to a tool what path you're getting, you just try to use this and do a clone, so that whenever I'm accessing, we'll be accessing this repo available on the GitHub or the other tool. Okay, so first try to practice it. The only difference is, rather than keeping everything on your machine, you will be trying to put it under your GitHub. Okay, so depending on whether you don't want to give any money, then go with GitHub. Suppose if you want to give some money and maintain the tool, that is when you will be going with the other tools that I showed. So GitLab is actually a enterprise tool where you have to pay money for maintaining that also, like purchasing a license. The same way, if your organization is thinking about not giving any license more, or specifically not to spend money, then they will be going ahead with the free account like GitHub, where you can store everything. Getting it? What will happen once the developer does all these things? So the next thing is, if you are moving ahead on the release process, you will have to give these changes to the QA to do the testing. So when they are going to do the testing, how is that you are going to actually give these code what we have written and pass it on to the QA? Okay, so for that, the next concept that we need to understand is what we call it as build management. Okay, so let me try to. Okay, so before we jump on to the concept of the tool, let's first understand what exactly is build management. Okay, so what is build management? As I said, after the development has been done, that is, after they have written the code, now pretty much in order to give it to the QA, you have to create a product, and that product, whatever that they are going to use, and for creating it, whatever steps that you're going to do is what we call it as a build management. Or in simple words, when you're trying to create a product, you call it as building a product, or simply we call it as a build of that project, or a software build. Software build means you are creating a product from the program whatever the users have written. But in that, what exactly do we do? So basically now, when a user or a programmer or a developer writes a program or the code, so we call it as a source code. Source code means the source from which you are going to create a product. So all these Java files or C files are considered as a source code for a project. So when you're actually doing a build, what happens internally is these Java files or the C files, which is the raw source code that we have, will not be understood by the machine. So the first thing that we have to do is convert these raw source code that we have in format of the Java file or C file into a file which a machine can understand. Okay, so that process where we convert the program files into a machine understandable file is what we call it as compilation. Understand this? Compilation is a process where we convert a raw source code into a file which a machine can understand. So that is how for each program that you write, whatever that we see the content, it is actually a raw format or a raw source code. So now the first thing that we have to do is we have to convert each and every file that we have in our project correspondingly into a file which a machine can understand. And that file is what we call it as compilation. And pretty much each of the file that you are trying to convert into a machine understandable format is what we are going to call it as object files. So first, you are going to have the source code. So for example, you're going to have 1.java, and you have to convert this 1.java into a file which a machine can understand. Okay, so pretty much now, those files which you convert on each of the file is what we call it as an object file. And this process of converting the raw source code into object file is what we call it as a compilation step. Okay, so like this, every program file has to be compiled where it will be trying to convert from the raw source code into an object file. Okay, and that is the very first step of our build management, where we will be doing something called as compilation or compiling. Compiling means in our project, whatever the raw source code we have, we will convert each one of them into a respective object file which a machine can understand. So the object files will be differing from what kind of program that you have. So in case if you're writing your source code in Java program, and if you try to compile it, then you will be getting a class file which will be the object file. The same thing if you're trying to write a C code, the source code will be 1.c, for example. And if you try to do the compilation step for this, you will be getting a file called 1.o. So like this, depending on the program, you will be getting an output file which the machine can understand, and this file is generally called as object files, but specifically the step where you do this is called as compilation. Okay, so like this, the first step in your building the project is compiling. Compiling means converting all the source code into a machine understandable format. Okay, that is the first step. Second thing, when we convert these files, is it the only file that we'll be having? No, I said in your project, how many other files you have to convert everything into a specific object file, because each of the source code is going to have some functionality. Only with the combination of all those things, you are going to create a project. Now, let's take a simple example where we are creating a project for calculator. Okay, let's say the project what you're creating is actually a calculator app. Now, you write 4 files where in one file you will try to write the program that will try to do the addition. So let's say you will actually have a file called add.java, and then you will be having something called subtract.java, and then you might have one more file called divisible Java, and then if you want, you can have something like this, where using each of the file, you will be able to provide the functionality. So now, when you do the compilation, for each of them, you will be getting a corresponding object file or a class file. Okay. So this is how the first step that you do is compilation. And then, once you have created, now, are we going to use it separately? No, because when you say a product, everything, whatever is necessary, has to be put together and assembled as one single software. So if you install any software, are you taking files separately inside it? Because after installation, if you go to that particular directory under your program files, especially in Windows, you can see that it will have multiple folders, and then it will be having multiple files inside it. Now, are you going to install it separately? No. Basically, when you install, you see one executable or one deliverable file, which could be a zip file or a tar file or a exe file, which you try to install it, right? So that is how out of these files, you are going to combine everything and then create one particular deliverable. That is the actual software product that we are going to use. So that way, now out of all these things, you are going to assemble everything. Okay, so whatever the different components that you have, and out of that, you are going to create one single deliverable. So like this, now either you can have one deliverable or multiple deliverable depending on how many functionalities that you want to give. But simply building is all about first doing a compilation step of converting all your raw source code into an object file, and then from that creating a single or a multiple deliverables wherein each of them will be having all these files inside it. So that is how when you run this, with respect to whatever that you have inside it, you will be trying to get a particular functionality. Okay, so that is what we call it as the build step. So build step means you will be having two actual process and steps. The first step is compilation and the second one is assembling them. Okay, now why do you actually need something called as a build management separately? Now, if you look, it is not just one file or few files that we have. In a project, there could be hundreds to thousands of files. Now, if you are trying to create a project, you need to know what and all are the dependencies of it, how exactly you are going to do, which file you have to do first, that is, which file has to be compiled first, which file has to be compiled next, and for creating a deliverable, what and all are the files which you have to combine and create a deliverable. So as the number of files gets more and more, and the process also for creating a product that is built will also get complicated. So that is when we cannot keep doing all those things manually every time, and remembering all of them will be difficulty. So simply what we can do is we can think about doing an automation of whatever that we have to do in such a way that by just clicking one command, you can able to do all those things automatically. So such kind of automation, what you are trying to do to automate all the process of compilation as well as creating the deliverable by assembling them, is what we call it as build automation. Okay, so build automation is all about automating the process of creating a build for a project, which includes the compilation automation as well as assembly to ensure you create one or multiple deliverables. Okay, now at this point of time when you are focusing on DevOps, you don't have to just think only on doing the automation for compiling and assembly. Whatever that we are going to do, we have to think as a release process. So that is when the build automation can also take care of doing some automated test on top of the binaries that we have created. Okay, the binaries or deliverables. So many people will call it with different names. They will call it as a deliverable or binary or a package. Everything is going to be referred to the same, which is nothing but the actual product that you have created. So now you don't have to just constrain ourselves for the build automation only to do these two things, but if needed, we can also think about running some automated test once you have created the build, and then if needed, you can also take the same files and do the deployment to a particular system, which could be a production system or a test system. So like that, we can think about extending the automation to do various levels or steps that we need as part of the build automation. Okay, so that is why it is quite important as of now to understand how you're going to automate, because from a developer, he doesn't have to focus on wasting time and all those things. He can just use one utility where as soon as he has changed, with respect to what he has changed, what and all files he has to create, that is compile and build the product and do the test, everything can be done using build automation. Okay, so that is why build automation is the another area which is quite important, where we will be trying to reduce the time of the developer as well as the QA, and also ensure that the release process is going to be smooth. So now, as part of our build management, whatever deliverables that we are going to create is what we will be giving it to the QA. Okay, so that is why every organization has to focus and will be focusing on this area, where for all the projects that you have and all the files you have to create a build automation which will take care of all the files for that project and do the build. So that way, now how is that you are going to do a build automation? Now a build automation can be done by simply writing any script, because whatever I said, it is all some kind of steps. So for this, there is a command that you will use, and for doing this, there is a command. So you can just put all this command into a script and get the things done. But as the complexity of the project keeps increasing, it is not easy to write a script and maintain. So that is when, as of now, for doing the build automation or for handling the build, we have specific tools which are called as build tools. Just like how we have SCM tool to take care of the version controlling, we have a tool which will be used specifically to take care of all these build activities, which are called as build tools. Okay, so that way, the next topic that we are going to understand and learn is one such build tool called as Maven. Okay, so before that, understanding, or did you guys get what exactly is the build management and why is that we are supposed to do the build management, and in that, what is that we are going to do, as in at least an overview? Others, is that clear before I get into it? Okay, that's a good question. So when is that you are going to do a build? Now, whenever we want the product to be created and giving it to the QA. So when is that you're going to do? Now, every day or at particular point of time, you have to decide saying that we now have done all the changes that the QA needs. So once the development team says that we have done all the work, so that is when you will be having a lead from the development side or pretty much from the release management side who will be tracking, saying that, hey, this is the actual product or the change which we have to give it to the customer, and that have we done all the development for that. So that way, whenever the development activity has been completed or when we have all the changes done by the developer for which a functionality has to be tested, then we will go ahead and do a build. And for that, now at that point of time, you will go to the central repository and take a particular commit on which you have all the other commits following it. So that way, now once you have that particular commit in which you will be having all the latest files, using that commit ID on a workspace, you will do this actual step of build and then create a product and give it to the QA. So commits will be done by the developers as and when they complete the change, but you decide when you have all the change that has been done so that you can create a product out of it, and then you go ahead and do the build. Wherein it is not just only to give it to the QA, where how is the developer is going to do a testing of his change. Now, if a developer has modified a file called 1.java, how is that you are going to test it? So he cannot directly test his 1.java because 1.java is just a raw source code. Once again, even he has to do a compilation of that file called 1.java to 1.class and then run that 1.class and verify. So that is how even a developer to do his testing or verification, he has to basically go through the build step or compilation, where he will not be creating the complete product. He will be creating only the component, whatever his change is going to be considered. So that way, a developer also has to do a build to verify whether his changes is creating that particular component of a product. And now, when you go to the QA, you accumulate all the changes like this, what we have done, and you will be using all the changes together and create the product. So that is how Using this build tool, if you want, you can create only a single component which a developer will be using it for testing, or he can use, that is, we can use the complete files and create the whole product and give it to the QA. So that's the comfort level where you don't have to do all those things manually. So you write a build tool or use a build tool in such a way that you can create based on certain files, either one component or all the components or the complete product as it. Getting it? Okay, so like this now, as I said, focus only on the developer part first. Let's come back to the release later. But now, regardless of whether he's a user, that is a developer, or a QA, if you want to create a build of your project, you need to do something. That is build automation. What is that you have to do is what we are going to see. And later on, we'll come to the process on when you will be doing this build, how exactly you will be doing all those things as part of your release is next thing. But first, now after you have created the file, how is that you are going to create a product out of it or a deliverable? And for that, we are going to use a tool called build tool, which will help us to do all the steps that is needed. Okay. So now, one of the tools that we are going to use for doing the build automation is Maven. Now, to understand Maven, the first thing is Maven is actually a build tool specifically for Java projects, which means Maven is used to create a product based on Java files only. You cannot use Maven to build a project against a C file. Okay, so Maven is specifically for Java-based projects. So if you have Java-based projects, pretty much in this market now, you will be using a tool called Maven. Okay, so remember that. And the second thing is Maven is a free tool, or it is an open source tool given by Apache. Okay, so actually we call it as Apache Maven because Apache is the organization which has given this tool called Maven, and it is an open source tool, which means it is available for free for us to work. And the third thing is Maven is also built on Java, which means Maven is used for Java projects or is used to build Java projects. And then the next thing is Maven is an open source tool, which means it is available for free. And then Maven runs on Java, which means now if you want Maven to be installed and run, internally Maven uses Java to run. So that means now on your machine, if you want to install Maven, then you need to have Java on that machine so that Maven will use Java and run the project for Java. Okay, so that's what you need to understand. So Maven is created on Java. In fact, Maven is nothing but a tool which is created using Java programming only. So it runs on Java and it is used to build only Java-based projects. Okay, so that's the first thing that you need to understand. Now, why is that we are focusing only on Maven? Because if you look at the projects, almost all the organizations are moving their programming languages to Java, and that is why we are trying to understand a tool which is most popular in the market based on the programming language which is more popular. Okay, so that way if a question comes what project that you are handled, you are actually handled a Java based project, and in that you are going to use a tool called Maven. So that way Maven is actually a project management tool, which means it is not just a simple build tool, but it is a combination of various features that you will be seeing it on different tools. So assume this way, if you had 4 to 5 tools, in that you will be having separate functionality depending on the tool. Everything put together as one single tool is what we call it as Maven, because it is a superset of various features found in various other tools. Okay, and that is why we call Maven as not just a build tool, but a complete project management tool. And using this Maven, we can do much more things beyond build, and you can actually manage the complete project. So what and all it is going to do, that is what we need to understand. But specifically, if you're looking at Maven, how is that it is going to take care of our complete project management? So basically, it is going to use the object-oriented model. So just now we know that Java means, basically we call it as OOPS. OOPS means object-oriented programming. Same way, when I say Maven is built on Java and it is going to run on Java, Maven is also going to use the same concept of object-oriented, and that is how it is going to treat your project. So basically, it is going to treat your project or split your project into smaller and smaller components, and each component that you have in your project is going to be treated as an object so that it can easily handle. Okay, so in that, if you are using Maven, no matter how many projects you are using, it will be following a single standard across all the projects. Okay, so remember, if you are working on Maven, we will be following a standard. So whether I can use a project or I can use another new project, or wherever company that you go, you will always follow one standard when you are using Maven. And next thing is the life cycle of your development. So after doing a build, how is that you are going to do a compilation? How is that you are going to do a packaging or assembly? How is that you are going to do the test? What you have to do first? So all those things will be a big confusion. So that is when, if you are using Maven, along with the set of standards, it will also give us a defined life cycle. Life cycle means it will tell us what we have to do first, what we have to do next in a proper order and a sequence. So if you are working on Maven, then along with the set of standards that we are going to follow, we will also be going through a defined life cycle. Okay, so we will be doing in terms of phase by phase, phase 1, phase 2, everything will be done in an order. So remember, if you are using Maven, along with the standard, we are going to follow a defined life cycle. Okay, then Maven helps us in doing a dependency management system. What do you mean by dependency management? Since Maven is going to treat our project in terms of object-oriented, now whatever is the dependency of a project in terms of a libraries. So generally when you say a project, for working on that project, you might be requiring many library files for it. Like a Java project might be requiring many library files. So simply, when you are using Maven, we don't have to worry about all the dependency, because if you're using any other tool, you have to take the burden of telling what and all are the dependencies for the project, what and all are the libraries that you need. Whereas if you're using Maven, the advantage is Maven will take care of the dependency management, whatever is needed for the project. That is another advantage. Okay, so by using these three things, Maven is going to take care of our complete project. That is, by treating your project as an object, and then it is going to give a set of standard, and it is going to give us a defined life cycle which we are going to follow. And top of that, it will help us by taking care of the management on the dependency completely. Okay, so by using all those things, it will be taking care of a complete project management. So that is why we call Maven not just as a regular build tool, but as a complete project management tool. Getting it? So if you have understood it, for today, I'll just explain few more things and I'll stop. And now when you are working on Maven, whatever instructions that you are going to pass to a Maven will always be in terms of something called as goals. Okay, so now if you are invoking Maven against a project, you will actually give something called as a goal. So that goal is nothing but the particular part of a life cycle. So what is that you are interested to do? So for that project, my interest is to compile. My interest is to create a package or a deliverable. My interest is to do a testing. So like that, what exactly you want to do to that project is what you're going to instruct through something called as goals. So remember this word, anything that you're going to instruct to Maven will always be a goal. So with respect to that goal, it will be trying to do something. Okay, now internally, how is that you are going to do something in terms of goal? So if I tell to Maven, you try to copy a file or you try to compile a file, how does it is going to do? Where for each goal that you are passing to Maven, it is internally going to call something as a plugin, where plugin is nothing but a specific file using which Maven will be actually performing a goal. So that way, for each action that you want Maven to do, there will be a plugin associated. Only with that, it will be trying to do. For example, if your goal is to compile, then when you say Maven compile, then corresponding to the compile, there will be a plugin specifically which it uses to invoke the compilation step. If you want to copy a file, then you will specify a goal as copy, where for that copy, it will be having a specific plugin which it will be using to run the copy command. Or if I say create a deliverable, then it is going to basically give the name of the goal. Let's say I will say create a deliverable, and that is my goal. For that, whatever the plugin that is needed, it will be trying to use. So specifically in Maven, we are going to use different kind of plugins and achieve a particular goal that is needed. So that is how what we will tell to Maven is the goal, and every goal will be associated to a plugin which internally Maven will call and perform an action. So this plugin is what exactly going to do a task. So remember, when you're calling Maven, you will be actually giving Maven something called as goal, and that goal will specifically call a plugin, and that plugin will actually do a task which is needed. Okay, so try to understand this, because going forward, the next session, whatever that I'm going to talk will be in terms of this goal and plugin, but pretty much we will see what exactly are the goals that we are going to use in Maven so that we can get a task done in the Maven project. And now simply to compare Maven with any other tool, the advantage is Maven is not just a single build tool, but it is a combination of various features available in different tools. And next thing is, it is going to give us an easy build process, because you are going to follow a defined life cycle. So no matter what kind of project you are going to work, you are going to follow the same life cycle. So it will be easy for us to work on the system. Same thing, it is not just the life cycle, you are also going to follow a standard. So that way, no matter how many projects you are creating, you will be always following a standard, because of which all the build system that you are going to have for different projects is going to have a uniformity. So when you say everything is going to be similar, then maintenance will be easy, right? So that is why the reusability and maintenance is quite easy in it. So that if you create one project using the files that you have done for that project creation, you can reuse it for creating a new project. So that is the advantage in Maven, where it is very simple. You can reuse the project and it is easy for maintenance, because you're following a standard and you're going to follow a defined life cycle. Okay? Getting it?